Good morning and welcome to the second day of this epic React conference. I am Ankit.
And I am Rajat. And for those of you still watching us from your homes or wherever you got stuck last night,
Just like our video yesterday.
it's been a tough couple of days.
It's still raining and I decided to give my suit a break.
Why, Ankit? You look so good.
I know, but I think I was too hot to handle maybe yesterday and that's why our stream froze. And I'm going for the cool look today, Rajat.
Well, you definitely look cool.
Thank you. So, Rajat, what is the status and agenda today?
We have got a lot to do, man. We have got 14 different sessions, 13 of them are talks. I've not prepared the introduction for three of them. I'm sorry, speakers. But other
Relax.
than
Relax.
Okay.
Calm down. Calm down. So, Rajat, let me tell you one amazing fact which I realized yesterday. Given our performance yesterday and today, I don't think we are getting the chance to do this again. So, what I'm trying to say is that let's go and have fun today. What I'm going to do is go on Twitter, tweet a lot, have fun with all the attendees and speakers, and that's my agenda for today.
you know what? I'm going to do the same thing because what happened is I got 50 new followers in the last 2 days, but I'm pretty sure I'm going to lose them by the next weekend. So I say let's just live in the moment.
Let's just do it.
Yeah.
And Rajat, before we start the actual stuff, any blockers?
Blockers, are we in a scrum call?
I don't know. I'm so addicted to daily stand-ups that I need some de-addiction programs. So all the attendees and people who are seeing out there, if you have any tips, please drop your comments into the chat and I will get back to you.
I hope you get better.
Yes,
Yeah.
yes.
Well, yesterday, right, in the opening session, we tried to show you all a video, but because of the technical difficulties, it was not played properly. So I think we should give it another try, right?
We have to. And what they say is second time is the charm.
Yeah. And also, that video is really good.
That is amazing.
It needs
That
to
is
be seen
amazing.
properly. Yeah.
So hold on to your seatbelts. Put your. I hope your speakers are not muted because we have said some excellent jokes here. So I hope everybody caught that. And let's see you after that video. Previously at React India.
React India. React India.
Previously at React
Well,
India.
I hope you had a good time, and I hope you guys learn a lot of React today, and network with other React guys, and also speak with the speakers. And please do ask them questions and answer, in the Q&A sections or in the lounge area. So we'll get started now. Please head to the next session, which is Saurav Verma. I'll see you there right away.
React India.
Welcome, everyone. I hope you're all ready to learn a lot of React. Our first speaker today is Saurav Verma. He's from 1MG. Um, According to him, he's very, very particular about web performance, right? And that's what he does at 1MG as well. Web performance, design systems, a lot of things, right? But when he's not doing all those things, he's riding out to the mountains with his motorcycle or attending concerts. And guys, I really, really want you to pay extra attention to this session, and ask him a lot of questions, because Saurav has promised me he's going to take me out to all the food joints in Delhi. So I really want to eat a lot of good food in Delhi. So please, guys, okay. Saurav, are you ready?
Absolutely.
React India.
Hey, good morning, guys. I hope you guys had a great day yesterday and have an even better one today. There are some pretty solid talks lined up, and I'm really thankful for people who joined up this early in the morning. Thank you so much. I'm Saurav. I look after the front end team at Tata 1MG. We've been doing some really interesting stuff over the past couple of years, and I thought this would be the best place for me to showcase some of what we've done, right? So, as the topic suggests, we're going to wait for suspense. So, we did something of our own, sort of, and by the topic itself, I think you would get that I'm fairly impatient when it comes to things about that I'm excited about. But it also comes out from a place of need, where the kind of things that we wanted from our tech stack was not possible because of the way the rest of the stuff, the rest of the libraries and the architectures were working. So we had to come up with our own. We sort of went away from all the generic patterns that we saw people design architectures on, and we decided that we'll just focus on what works best for us and what kind of target audience we want to go for next, right? Which tells me that you guys probably do not know enough about 1MG, and this is the singular agenda that we hold in mind. We want to make healthcare accessible, understandable, and affordable. It's really important for us to meet all of these three things. However, today's talk would be solely revolving around the accessibility part of it, because I believe the understandable and affordable are far too meta to get into. but we've got some solid substance behind accessibility. And this talk, as the topic also suggests, is around an obstacle that we faced at 1MG, that we wanted users to have a suspenseful experience, but suspense was not out of beta yet. We also wanted to look at how we can drive, you know, really performant UIs on devices that do not have enough power. And there's a reason behind this requirement. It's because 76% of users in India are mobile, and that 76% of 700 million mobile users, right? 790, I think, which is 70 crores out of 125 crores according to our outdated population, right? Numbers. So I was really curious to see that 76%, or I would say about 65% or so of India is online, right? The tier 2 and tier 3 cities are finally coming up, and they are all the rage out there. You've got so many people accessing internet in different ways that you couldn't have even imagined. So naturally, it became very important for us to make sure that healthcare is accessible to them. Whether we can make it understandable for them or not is a question that will come on only later, once someone has actually stepped in, someone is easily reachable, right? And at 1MG, we wanted to be that entity that is easily reachable by them. So what we figured out when we looked at our metrics, right? So these are Google search metrics. We realized that 52 million hits of search results per month at 1MG come from mobile devices, and we were seeing these from all sorts of places, right? We had a ton of tier 2 cities in here. We had some tier 3 cities also coming up, and it was interesting to see that 90%, well over 90% of our traffic was on mobile. So we decided that we needed to make some changes, and since Bharat, as the CEO of Mahindra would say, Bharat is now rising, and we wanted to cater to Bharat beforehand. So we wanted to make our website fast, right? I mean, you could see gremlins coming up and being, hey, make website fast. So these are the usual checkpoints that everyone would probably just hand you over. That you should have server-side rendering. You should have a reduction in your bundle size. You can reduce them by reusing components, code splitting it more efficiently. Compressing your assets, writing leaner components itself. But yeah, so we've sort of figured all of that part out, right? I think we've been going back and forth on this topic for so many years now. I think everyone at least has heard these terms by now. What we want to focus on is optimizing resource delivery, where we want to show you guys a sort of a unique way, just like sort of suspense, of how we do lazy loading at 1MG, and what kind of workaround did we create to get a suspense-like experience at architecture. So what you can see here is that this is a very simple case of how CSR or a server-side rendered and a server-side rendered website would fare. This is simply page load, and on the y-axis you'll see how much of the bit is the rendering bit, the perceived performance of a user, because this is what the user would be able to see. The interactivity part comes in later, where the user is able to see some things, but he's not able to interact with it. So let's say if this is CSR, and this is SSR, right? what we can see here is that whenever you're server-side rendering any page, because of how powerful your systems are, you can actually render them quite quickly, send it out to the user, and the user can get an experience of a whole page that has been rendered, that he can look at, content that he can see, right? At 1mg, after the new tech stack implementation, after the new architecture, we saw that our FCP was somewhere around a second or 0.9 seconds. Similarly, if you look at client-side rendering, you would see that a lot of things have to be done before user can start seeing content on their devices. You would see that the user might have to fetch a lot of JavaScript. Maybe some very large bundle has stopped the entire flow altogether, and that needs to be resolved first. The bundle needs to be, the script needs to be executed, and garbage collection needs to be done. A lot of the entire pipeline needs to flow, basically, right? It's blocking your thread. And if it's going to block your thread, your user is going to face a lot of other frustrations around the block. This is how your server-side rendering would work. This is a very basic top, eagle's eye view of how things might work, but there are a lot of intricacies that go on in, maybe here, because the render part is extremely, extremely complicated. You can have different types of renders, you can have different strategies of rendering. React itself gives you different ways of sending your rendered content. You could stream it, you could turn it into a static content, you could send it as an HTML that later on gets parsed completely. So let's look at it right now, right? So if your browser makes a request at www.1mg.com, it would go to the server. You're going through DNS and your load balancers, etc. You get to the server page. Now, this data fetching could exist anywhere. It could exist on the server. So you fetch all the data that you need, you render it, you create an HTML out of it instead of just sending blank HTML with links for your vendor bundles and the rest of the assets that you've got. You would render it, you would go over what all widgets or components need to be rendered, attach the links for those widgets, the styles of those widgets, create the HTML body that needs to be created, and then inject it into the HTML, and that HTML goes to the browser. Luckily, the browser is great at reading HTML, so it quickly goes over the HTML and renders it as it is, because it has got a pre-rendered HTML after all. It has got a full-fledged HTML after all. So now what happens later on is that the moment user tries to interact with any of this stuff, he wouldn't be able to, because as you saw from our previous slide, both of these setups, let's say if they were equivalent, they achieved time to interactivity at the same, their interactivity was achieved at 6 seconds. So the time taken to be interactive is still 6 seconds, even though the first content was early on server side. And that's one of the problems that we want to mitigate. I'll get into it, why and how we are doing it later. So if you look here, what happens here is that once your HTML has been rendered, your browser would fetch the assets that it has found in the HTML. So all the link tags to your components and other bundles and maybe some functions that you've attached, so that it can hydrate the entire HTML, right? Water the entire HTML. You could also go over how hydration or selective hydration works from the React 18 working group post. That was pretty interesting. So what I've got here is, now once the browser goes over it, once the browser starts fetching all of these assets, the user will have to wait until it can get those assets and then run it and then hydrate the entire thing. And that causes slight delay, right? What causes more delay is that sometimes we do not care about users and we push so much content that we've already got. Uh, we can see, e-commerce websites having 5, 6, 10 folds in their homepage, even though it's paginated. A lot of the content, there's a ton of content to be read there. And yeah, your browser then goes on to hydrate things, and now the browser says, hey, I'm ready, now you guys can come interact with me, I'll respond rather quickly. But the problem here is that the links that for the component that you've created uh, and injected into the HTML, they're still going to be requested, right? Because regardless where the component itself lies, the component could lie, uh, 4 folds, 5 folds underneath, and the browser would still ask for it because it found the link to it. Now, as your page increases in size, and by this I do not mean increases in the weight, the bytes of the page, but as it dimensionally becomes longer, if we are talking about mobile, then the HTML, the rendered HTML becomes larger because there are more nodes to render. There is the entire body becomes bigger, and so does the incoming JavaScript. God forbid if you guys have heterogeneous components. If you do not have components that are being reused over and over again in the same HTML, you guys are in pretty big trouble because you would have so much JavaScript that would be coming in. And because of that, all of the resources would be competing for network and CPU bandwidth. And then comes in a problem where once all of that has been resolved, hydration would take place. Now, hydration could take a good while depending on how much content you've got. If hydration is delayed, interactivity is delayed. If interactivity is delayed, the user will get frustrated, right? Because he's got so much that he can see, but nothing that he can interact with. But hey, there's a solution, right? There's a solution that has been proposed for a good while now, and it has been staring us in the face for the last 2 to 3 years, I'd say. And as you probably would have guessed, it's Suspense, right? Suspense was teased, I think, during React 16.6, and they showed us a very early version of what Suspense was and how it could sort of break away from the traditional way of how we render things, and how the browser needs to wait for certain things and how your hydration works. And they've reworked their internals quite a bit. The problem there was it was almost very closely designed for GraphQL. A lot of the companies, a lot of these apps that you use may not be on GraphQL. They may not even find it necessary to be on GraphQL. But they might still have very bulky RESTful APIs. What about them? And soon enough, they showed another one, which was in 2021. And that was a much, much better spec of Suspense because it looked at streaming from server components. It looked at how you can partially hold off a node from hydrating. It looked at how you can even bubble up certain hydration events from even if a grandchild of a component was not ready yet, or its data wasn't available yet. But it would look something like this, where you can see the HTML and going into the browser. But do you remember that there was this shaded block here? And that shaded block tells us that these components are not ready yet, right? These are components that I would like to say were sent as shimmers you probably would have seen a ton of shimmers in Facebook, and those shimmers would essentially, at least in 1MG's case, we would build it out of CSS so that it can be rendered on the server. Images are not usually fetched there. Uh, unless you're inlining them with the HTML, then it's a different case entirely. But I would not recommend you guys to do that. So you have the fallbacks for certain components, which are shimmers or skeletons. And you can see that the page that we sent, it only had a couple of components that actually was rendered, but they're all demanding that JavaScript. I don't know why they're demanding it from me, but yeah, that's what it is. That's what they want. They want their JavaScript. However, now imagine the scenario if the line, the the line at the fold itself, I would say, if the fold ended here, right? If you look at this, if the fold ended here, component D necessarily does not need to fight for resources while A, B, and C are working towards it. Also, C itself should not be as eager as A and B because A and B have a higher priority. They are pre-rendered, so they actively tell the user that, hey, I'm ready, even though it might not be because they still need to get their JavaScript in. And because of that, what happens here is you've got a contention between these four components, which all actually should have different priorities, right? But they do not. They're equally fighting for resources. What you could do is you could maybe preload some of this stuff, some of the components when you're sending the HTML, so that these assets are fetched beforehand. But then how do you know what to preload and what to not? How do you get granular control over all of your components? Let's talk about it in a way where we can set some of the prerequisites beforehand. So let's say you've got a server-side rendered architecture, right? And all of your chunking happens at component level. By component, I might, also call it widget, because at 1MG we call components to the baseline, atoms, the molecules that are present in the design system are called components here. We call the organisms as widgets. So if you look at the widgets, right, you might have 4 different types of widgets. A could be your user profile and initial heading of the page, etc. Then component B could be quick links to different types of verticals that you want to jump into. Component or widget C could be maybe an ad, right? Ad revenue, come on, it's a real thing. D could be data to your, maybe a link to your previous orders, right? So if we can look at this, we don't necessarily need widget D to be rendered right away, right? It can wait. It should have the least priority, but you don't have anything set around it. So now your browser makes 4 different calls for 4 different widgets. It could be likely that D was a smaller widget, and the request also got resolved faster, and you got D first, and then C, and then B, and then A, right? Completely defeating the purpose of having a server-side rendered page. Not completely, but I'm exaggerating a little bit. Working out, it's basically just sort of being a nuisance in between this race, right? It shouldn't be happening. A fallback, for example, like we sent with widget D or widget C, for example, and it could stay like this. It came from the server like that, but the browser is repeatedly demanding it to become what we can see on the right. Right? What if we can tell the browser that, you know what, you can chill with this widget. I don't want you to request all of the information about this widget right away. Right? I don't want you to get the core, the crux of the matter, the crux of this widget, the JavaScript, and you can simply stick to the HTML until I tell you so. There are multiple ways to do it. We're not going to get into that implementation. We're going to look at different architectural implementations around data fetching, asset fetching, and then rendering, etc. Right? Different strategies around it. But what you need to know so far is that I sent a fallback from the server. I do not want the browser to directly act on it, right? And this is where it sort of deviates from suspense a little bit, where we're taking that control in our hands, in the developer's hands directly, and we're saying, you know what, I don't want this to have a higher priority than some of the stuff that has been requested beforehand. I want the browser to stay idle, maybe wait for the user to do something, and if it stays idle for too long, then maybe I'll get the widget that is pending underneath somewhere, right? Let's say this is below the fold. What we built was we built on-demand component loading. We have an option to do selective hydration. On top, hydration is something that they are touting in really excited of it. A lot less that you need to do manually, and the implementation so far looks very interesting. I have created some examples here and there, but I need to play with it in a full-fledged website to see how well it performs. Or do we need to go back to what we have built right now, where the developers have sole control over how the browser is reacting? So we used loadable components, which helps us split code easily. Loadable components also has their own suspense alternative, I'd say, where they fetch the assets, but I think it hydrates a little bit later, right? I'll have to get back to you. But what we can see here is that this setup, it works in multiple data fetching scenarios as well. So you could have maybe a single REST API that is being resolved on the server, and then you're sending that into the you're injecting that into the HTML or in your into your store, and that's getting injected into your HTML, and then your components and everything are being fetched slowly as they are required, and they are being rendered, right? So I have my API call already ready. I have the data that I need to render, but I'm not bothering with my actual JavaScript right now. You could say that, you know what, my page is too long, or there are some elements which may not or probably do not come in a single API. Maybe because some of these APIs are cached. Some of the data that is coming in later is user specific, is location specific. It's dynamic in nature, right? And that API might be a lot more slower because of multiple reasons. Maybe it cannot be cached. Maybe the query itself is too expensive. So now you've got a scenario where, let's say you've got 5 APIs that are being that you need resolved to render your entire page, but you can only do 3 of them right away because that's where most of your page's content exists, right? So now what I could do in theory is I could resolve those 3 APIs, get all the data that I need, put everything else on a fallback state, because I can have multiple conditions, right? I can have a check on the data value, the data key itself from the store. That if I do not have this key, keep going into the fallback zone. Maybe I have an upper limit to that. Maybe I have another state that can tell me that this API failed and you should probably quit waiting for it. But what I want to say is that I want the components that rely on these other two APIs, right? These other two APIs to just wait, to be in that waiting zone and do not slow down the server, do not slow down the initial response, not the server, sorry, and just keep things moving. You would want the user to see things quickly, right? It's the best way to go at it. So now some of your data has been fetched, but now when it goes to the user, now the users, as soon as the user gets that your server-side rendered page, maybe you have another API call that fires on mounting, and that effect fires off at mount, and you've got a new API coming in that gets new data and then fills up some of the fallback components that existed. That works great in theory, right? However, when you do something like this, you're still attaching the link statements or the script itself of the file into your HTML. So let's say that from those APIs, one of your one of your widget was down in the fifth fold, for example, and your user does not even bother to go down there, right? He's casually just browsing in the first second fold and he moves on to a different page entirely. Now if you had the moment the guy received the page, if you had requested for that asset, or you sent it, your browser requested for it eagerly because it found the link up in the head, that would be a waste of resource, right? And not just a waste of resource, it's the more problematic scenarios that is the bandwidth that could be used for widgets or bundles that needed it more, right? That needed that space to appear, and your interactivity for that zone could be faster. So what we wrote is that we've created, so this is the strategy that we use. We've got an intersection observer wrapper on top of our code split bundles. So every widget that gets imported, that goes inside an intersection observer wrapper, which we have an explicit flag while coding itself to say if I want it to be rendered on the server first and then sent it out as quickly as possible, because I know that this is going to be important. If it's going to rely on an API that is going to be fired later, then so be it, right? I don't want it to be rendered right away on the server. But if I send the entire HTML without any fallbacks, or absolutely omitting the entire widget, what I might see is that I would see layout shifts. The moment user scrolls down to it and the API call finally gets fired and the widget gets loaded because, hey, now I'm in view, the moment the widget would get injected into that DOM, your the layout would shift because you did not leave enough geometric space for it. So those are some of the things you would want to take care of, which is why I showed you the fallback rather than just a blank area. So what you would want to do is you would want to what we've learned so far is that we would want to prioritize asset fetching. We would want to have control over which widgets or which chunks get fetched first and which can stay offline for a good while. There can be multiple implementations around it. So for example, if you look at a very eager setup, right? So you've got a server-side rendered page. This would be akin to your widget A. Now widget A, because it was needed beforehand, it gets rendered and it's probably coming in the first fold right at the user's face. It gets rendered on the server. It gets injected into the HTML. It gets sent along with the data, the API call that you made. And then, the moment the HTML is interpreted, is being read by the browser, you've also added a preload hint on the link. Now, you can add that preload hint now because you're explicitly defining a flag during import itself, telling them that, if this page gets rendered, these widgets are the widgets that I need to go in first, that need to go first. And because preload hints are attached, you'll see that very quickly the asset calls for these widgets are fired, right? Whether the browser comes across the div actually or not, right? Preload hai to fatafat kar do. So now the asset call is just following up right behind the HTML, right? It gets there, the page hydrates, great. This is what we'd want, right? But this is what we'd want for the things that exist above the first fold, in the first fold, I would say, or even like the second fold or so, because users tend to browse slightly more. But the rest of the stuff, you might want to lazy load it, right? So there are two broad ways of how you would want to lazy load. One would be fetching the data at the server, which, like I said, let's say you've got a single API, you fetched it, you got your data, you rendered the HTML, but instead of rendering the actual fallback, you just rendered, instead of rendering the actual widget, you rendered a fallback. And that fallback is being sent to the browser. Now, the browser is not going to bother getting that asset until and unless, the conditions that we've created prior gets fulfilled. So in our case, the condition is when it's about to come into view, right? So that's why the arrow for the asset fetching is the other way around. It's simply to denote that the browser took its own time. As user was interacting with it, the browser found that, oh hey, this is something new that has come into view. I need to fetch this asset to go get it. The JavaScript is fetched for that specific widget, and that widget is then rendered. In a lazy plus plus scenario, you would see the HTML being rendered, but the data for that specific widget not existing either, right? Like we spoke in the scenario where you could have multiple smaller APIs being split. And this is how the browser would react. It would first ask for the data, maybe on mount, on view, whatever conditions needs to be fulfilled, and then it would ask for the asset as well. Once the condition for the widget's rendering is fulfilled. These could be separate conditions, right? It's up to you how you want to design your architecture. And then the rendering happens. These could be some of the implementations you want to do. So what we achieved here was that we achieved a really, really fast hydration. If I talk in terms of numbers, the current stack, the current setup that we built on a 3G device, on 3G fast, on Motorola G4, which is, I think, a 2014 phone, right? It goes up to 3 seconds. So you get your interactivity within 3.5 seconds, which is pretty fast, I'd say, for an e-commerce website, for a full-fledged e-commerce website. Because what happens here is that why is the hydration faster? There are less things that are blocking the network, right? Your thread stays relatively empty. And because your thread stays relatively empty, your browser can quickly go over the stuff that needs to be hydrated, right? Number of assets that are being fetched is lesser. Moreover, these other fallbacks, they're usually not that complex, right? They're just a single layer, divs with CSS. Nothing too complex, nothing to actually go over and hydrate or make interactive. So they stay as it is. And this is where we sort of, run into that whole suspenseful architecture and how we created something sort of around it. Is that in suspense, the server would still stream things as they got prepared, right? It here we choose when the assets are actually fetched. The asset calls are not directly linked with your data fetching calls. So even if I do have data for that specific widget, I may not want it right now, and I can take my time to hold off hydration for that widget. And I'm holding off that hydration by not having a mismatch in your server side render. So the render that's coming from the server and the one that's being read by the browser, and then React says, hey, both of these look the same. I don't think I need to do anything here. If there's a mismatch, then problem ensues. Why we cannot have content in there? Because if I render content, I would have to link my JavaScript, and after I link my JavaScript, it'll have to go over, fetch, and then contest again, right? Neto contest. So yeah, faster hydration, smaller initial footprint. So what we saw was that our initial JavaScript, and I'm talking about this apart from all the third party, ads and Google Analytics and stuff. If we look at the code, we get about 250 KBs, right? In about 250 KBs, we serve the entire product page. Our blocking time is insanely low. We intend to make it even lower. We're still working on some of the things that might help us. Neto competition has been reduced, like we've talked about over and over again. So now there are multiple ways that you can, leverage this additional headroom that you've got. Let's say you used to have a page load that would become interactive at maybe 7, 8 seconds, 10 seconds, right? Now, if you're doing it at 3, you might still have an opportunity to go back, look at the demographic that is using your app, using the product that's creating value for them. And you can play around with maybe more features, maybe more experimentation, and make the product itself better. Earlier, if you did that, you'd probably be just raising the bar of frustration that the user has. And that is also one of the things that we get from, performant UIs. And I'm so happy that React is focusing this entire release on performance, mostly. And, for example, let's say today you also get an headroom for larger pages. We spoke about how a longer page will cause more problems. Well, hey, I can lazy plus everything underneath, right? I don't need to care about it right now. I shouldn't even have to, I can have a paginated API, but I can still have fallbacks ready. I can have separate APIs for separate content. You can have a mix and match of multiple of these things, and still everything would work just fine. And that's primarily why we are so excited with it, because we've used it with different kinds of data fetching setups, and it has worked pretty great. Graceful server rendered fallbacks, like I told you, the user actually sees something there. There's the shimmer tells you that there's some activity that's going on. The user can actually see content. They can skip through that content, and even if in the background that asset is fetched, it can still be it still won't cause layout shifts, and that's a great thing, because you took care of that with your properly sized fallbacks. Creating properly sized fallbacks is also another pain, but I think there are some good trade-offs here. So now we did, create our own selective hydration, or a way to fool React into, going over all of components and saying, hey, everything is a-okay, when in actuality it's not. uh, what do we not have from the actual suspense release, right? Where what are some of the things that they do a lot better, or at least it looks better on paper right now. It's still in alpha. So you've got event tree playing, right? Which is a really, really important thing, right? Because now that I can send pre-rendered content and still be able to delay the hydration bit for that part and focus on the hydration for the rest of the components, partial hydration for the page in on the page. If my user goes on and interacts with some of the content, those events are kept by React, right? React would remember the events that were made, and then it can perform those actions once your widget has been hydrated. Uh, you've got partial hydration with content, right? We do not have it with content, we have with fallbacks. Uh, you have out of order hydration as well. So maybe this could be coupled with the scheduler API that the Chrome team has released. You could actually go over the entire page, and depending on where user has been paying more attention, what area of the web the page he has been paying more attention to, uh, you can go there and you can look at, you know uh, maybe those parts can be prioritized further. Again, it was all about prioritize asset fetching anyway. So out of order hydration as well, and this entire thing is being streamed. Then you've got suspense bubbling, which we do not have yet, or we haven't figured out a good way to do it yet. You can have, if there is a suspense boundary on any of your widget or component, even if it has multiple components underneath, you do not have to think about it twice, because if any of the underlying node is not ready, the parent node would default to the fallback, and that's great, right? What in our setup we have to do this manually, where we have to keep checks for all of these things, but React says that it's going to do it for you without any issues. So yeah, that has been my talk. Thank you so much. I really hope you guys have a great day ahead. I'm Saurav. You can follow me on Twitter. I'm at the rate Saurav Verma, Saurav_Verma, and that's about it. I'd love to talk to you if you guys have any other questions. Thank you.
Thank you, Saurabh. It was a really good talk, and I'm definitely going to check all the links that you have posted. We have a little bit of time for one Q&A. So if are you there?
Yeah, I'm here.
Yeah. So we
I
have a
want to
question.
know about. Yeah.
Okay.
What questions do we have?
Just one question we can take. We are a little short on time. If
Yeah.
we do immense amount of code splitting, let's say for every feature, because they will be dynamically loaded, can it be issue in mobile as multiple JS loading requests will go together?
So I think it's good, right? Because instead of sending a request for one big chunk, you're sending multiple requests that are smaller, and your browser can take breaks between all of those requests, and not just requests, right? Once those JavaScript are downloaded, they'll be downloaded in smaller chunks, and because it has been done in smaller chunks, your browser would go ahead, parse it, execute it, and then take a break, go back to your layouting engine, let it do its own thing, right? It will yield the thread to the layouting engine as well. Whereas if you do it with a bigger bundle, your thread would be blocked continuously.
If you feel like making multiple requests in parallel is a bad idea, you can just rely on HTTP2 multiplexing and let the browser take care of it. It'll work.
Okay.
Yeah.
Well, there are some comments, so you can share all your, and I'll see you around.
All
Right?
right. Yeah.
Thank you. Bye. Hello, everyone. Uh, yeah. Hi, Tanisha. So we have Tanisha here, who is a software engineer at JP Morgan. And apart from that, she is also an organizer of Hello Ally, which is a community that's all about digital accessibility. And she's also a very great writer. She has written a lot of articles about tech, front end, and a lot of other things. So please check it out on her Twitter. There's a link on Twitter. And Tanisha is here to talk about how React and JSX and Babel works. But there's not going to be a lot of tech jargon in this. There's going to be a lot of metaphors, analogies, and sketches. So I think I'm going to enjoy this talk a lot, and I think I'm going to learn a lot about React. Even after 2 years, I still feel there's something I've missed out. So really looking forward to this, Tanisha. So please take it away.
I'll share my screen. Yep. Yeah. So, hello everyone. I am Tanisha Sabarwal, and I currently work as a software engineer at JP Morgan. And today I'm going to talk about sketching metaphorical React. Now, I know the title might sound confusing, but I've realized that like whenever I've gone to learn any concept anywhere, there's a lot of contextual or text heavy content that I get. If I could just explain these concepts in terms of sketches, metaphors, analogies, so that we learn better and we retain better. So here's my first and maybe noob attempt at trying to do this. And I hope I'm able to do the justice and explain you all these things through my sketches. So yeah, let's get started. So this is React, and this is how all front end devs see React, like you, me. But like any other superhero, this superhero also has some sidekicks or friends that help it function the way it does. So let's try and meet those friends. The first one being Babel. Now, Babel is wonderful at how it helps React in creating an experience like we have today. And we'll find about that later. We also have the renderer. And the cool thing about the renderer is he's a part time heavy lifter. And I know that might sound a little confusing, but we'll also get to it later. So, if you broadly see any React component, right? This is a basic version. You could see that this component can be easily divided into three main parts. Something like this. The topmost part where we import all our libraries is what is coming from the React library, right? So that's our superhero. When we go on to move to the major chunk of our component where we write the core logic and the HTML, is the JSX where Babel takes this and compiles it into a form that is better readable for the browser. And finally, the rendering. So basically, this is where your application is finally being put onto the screen and this is how we see our apps function live. So let us take a dig at each of these parts and understand more. Let's talk about Babel. So first we jump onto Babel, let's understand what is JSX. So JSX stands for JavaScript XML. You have a JavaScript, and JSX is nothing but a syntax extension of JavaScript. So in your React components, when you write your HTML and JSX is something which puts takes both of these forms, and it helps you create React elements. So it is great, isn't it? We often talk about React for its developer experience, and JSX plays a huge part in that, because we love the fact that we can put our core logic and the templates in the same file, and that is great. But the question is, what does Babel actually do? So let's take a analogy, right? You have an ice cream, and since JSX is known for its developer experience, such a great experience that it gives to all the developers, it is also called syntactic sugar. So cherry on top. How I think of JSX is a syntactic sugar. So your ice cream is your a web app, and whenever you write React, it is a cherry on top. It's a syntactic sugar. But this sort of ice cream, this form of ice cream with this syntactic sugar, is not something that the browsers can very well understand. So what Babel does, it takes this form, and for the browsers to be able to read it, it converts it into something called React elements. Now this is a more refined form, something that the browsers can understand. So it is minus all the syntactic sugar, just plain React elements, which then on creates our DOM. We'll find about it later. So Babel is great, isn't it? But let's jump on to our superhero, right? Let's talk about the superhero hero here, the React library. Now, whenever I think of a React app, I always think of Lego blocks. These Lego blocks could be anything. It could be your headers, footers, buttons, divs, and spans. And when these Lego blocks are stacked and maintained in a hierarchy, this is what they form a React application. The header on the top, the footer at the bottom, the main section in the middle. So it's all about stacking up, maintaining it in a hierarchy, and there we have a React app. But if you look at these knobs very carefully, if you look at these blocks very carefully, you would notice they have some knobs, right? And whenever we go on to stack it together or form a hierarchy for these knobs, you would notice that we apply some sort of force, and we stack it one after the other, one below the other. And I would like to think it when we put it all stacked up, this is something like props that go down the hierarchy like a force. And similar to how props actually work in our React applications, something which is going down the hierarchy. So it's great how we can analyze this whole force being applied to maintain a hierarchy similar to props. Because although force also helps us to maintain the stack, props also do that, because they sort of link all these components to one another. But let's talk about states as well, right? So states is much simpler, I guess, because respective to every block, state is something which is very particular to that particular block. So a block could have any color or maybe any shapes and size. Similar for in this case, like the blocks, the React components can also have different states, different properties that are just linked to them and not shared between all of these respective React components. So now that we've talked about props and states, this is a very nice topic that we always jump onto, and which is functional components and states. And in no time, functional components have become such a great friend, and we love it for the great experience we have. And it would not have been possible if it were not for hooks and this state functionality that it provides. So we all love hooks, but one thing that always intrigued me were the rules of hooks. And one of the rules says that don't call hooks inside loops or in conditional renders or any if statements. At first, it sounded a little weird to me because I was not able to wrap my head around why is that. So I tried to explain it. So here's my analogy. So I realized that hooks, particular to any functional component, form a sort of a trail. They form something like a list, an array, where every state is stacked one after the other. So whenever you try to fiddle with any of these, any of the elements in this trail, what follows is a domino effect. So if you break any of the rules, what will follow is everything will come crumbling down. So that's why you don't need to, you should not break the rules because your app will start to malfunction. But the question is, why does it happen? Like, why does the domino effect come into picture? So let's try and understand with a code example. So there's a bad component. We have three use states. Out of these three use states, only like one of them is inside a if statement. So let's understand what will happen in this bad component, right? So every component has a hooks array associated with it. So if you look at the use state very carefully, you would notice there's no unique identifier being passed to it. So there's no way for React to pinpoint which particular state are we talking about at a particular context. So the only way it maintains this unique identifier is through the index of this hooks array. So let's see what happens when you first render it. So on a first render, what will happen is it will go through the first use state, it will record in the hooks array. And since the value 1 is lesser than 5, it won't go to the second use state and it will directly record the value 3. So you see how these are recorded, and the only way to identify between value 1 and value 3 is the index in the hooks array. So we just fetch value 1 or the 0th index and value 3 at 1 index and so on. But let's try to fiddle with it and change the value 1 to 8. So what will happen is in the second render, now that the value 1 has become 8, it will again render it. So the functionality of use state is it whenever there's any subsequent renders, it goes back to the hooks array and tries to identify if there's something at the 0th index. If there is, it will return that, otherwise it will create a new state. So in the second render, what will happen is it goes back to the hooks array, it tries to find the value 1, and it does find it and returns it, which is 8. Now now that now the value has changed to 8, right, and the condition becomes true, there will be our second use state. It will try to map with the same hooks array and sees that it already has something at the first index. And what will happen here is a mismatch. So it will try to create a new state, but what will it get in return is actually the value 3. And moving on, when it tries to find value 3, it is again mismatched, and your app will not behave as expected. So the whole point is this is a very broad level view of how hooks work and not the actual implementation. So I hope this gives you an idea why you should not break the rules and what will happen if you actually use hooks inside your if statements. So you could like after this, now that you've understand the broad picture, you can go and see for much deeper details of how it actually works under the hood. Now let's come to the best part, the renderer. Now I mentioned that the renderer is a part-time heavy lifter. The question is why? Because it is actually 39.8 kbs while the actual React library is only 3.8 kbs. So you see that the majority of the heavy lifting work in the whole process is being done by the renderer. Or the React library is something where we import all of our libraries from, but the core logic is with the renderer. And he's great at managing all of these things. Now, the great part of the renderer is it can be a React DOM or it can also be a React Native. So it can take multiple shapes and sizes and give us that awesome functionality that we have. So let's try and understand more, right? Um, Whenever we think of any application or any DOM, we always take the reference of a tree like structure. Like the DOM is a tree like structure, our app is a tree like structure. So let's go forward with the same tree like structure and try to understand how renderer works. Let's take a beautiful example and see what happens when there is any changes in this DOM. So whenever a node is being changed in the DOM, renderer needs to find what is being changed. So there's our actual DOM, there's this virtual DOM, and we try to identify what has changed in our DOM structure. We try to map both of these trees together, and this is called diffing. So diffing is nothing but an algorithm that tries to map both the versions of the tree, the old version, the new version, and tries to find out what are the discrepancies, what are the changes that have been done, tries to map it and identify that particular node. So let's try to understand with the example of ACP Pratyuman. Yeah, the same Pratyuman from CID. So what he wants to do is find the thief here. Now, the thief resides in a particular node where something has changed, and the ACP's task is to go down through these entire nodes and finally land onto the node where the thief is actually residing. So let's see what approach our ACP takes. So it takes the depth first approach. So it goes through all of these nodes down the hierarchy. If it does not find it, it goes back up again, goes to the next sibling node and tries to identify it. Now, this approach is nothing but the stack or recursion based approach, right? But there are two big problems with it. First of all, it is very slow because recursion in itself is quite slow, and he cannot find the thief as quickly as possible. And the second and the biggest drawback here is it cannot be interrupted. So you see, when you do recursion, you actually have to keep a count of where the pointer is, so it has to be completed in one go. You cannot interrupt in between. So now ACP has a lot of tasks in hand, very similar to a main thread. So it cannot juggle between those tasks simply because this cannot be interrupted. So it has to complete it in one go. So if there's any other thief on the run, it cannot catch that particular thief just because he's busy somewhere with this particular one. So that's the two main drawbacks. Let's try and see how our ACP tries to fiddle around with this approach and takes a better approach. So this was our stack based approach, but here's the new approach that our React renderer took and how it improved us. And so we will see how it works out for our ACP. So this is a two-step approach, and what happens in this? There are two phases. So the first one is the render phase. So what render phase is nothing but the reconciliation, where we just try to identify what has changed, and the second one is the commit phase, where now that we have identified what has changed, we just try to push the changes all at once. So what ACP does is it calls for a friend or accomplice and tries to asks him to maintain a list of leads. So you have a tree where you have relationship mapped with all of the child, parent, and sibling nodes. And what you create is a list of leads. You can call it a linked list, and this list is basically something that the inspector would use to identify the thief. So this is a list of potential leads that will lead him to the thief, like eventually. So here's our tree, a DOM tree. Here's the list of the leads, something where things have changed and the thief could actually be. So we have the inspector, we have the thief here. So you see now this task has become very much simpler because of this approach. Because if there's something in between, uh, iterating through the list could be much simpler and it could be stopped in between to do some other task. So if there's some other thief on the run, it can just stop the task in between and move on with the ongoing task. So this was the fiber architecture that was introduced by the React after React 16, and it solved the two major problems that we had with the stack based approach. Is A, it is faster because iterating through the list is much faster while you're going down in a recursive fashion, and it can be interrupted in between. Now let's try to understand with actual code and see how it all plays out. So you have an app, and a fiber is nothing but a unit of work. So a fiber is something that the renderer considers as something a unit of work, and the work it needs to be done on the main canvas. So you have a main route which points to the entire app, and every React element is processed one at a time to form these fiber nodes. So you have an app, you have the main div, the buttons, and the parent divs, the child divs. Now each fiber, if you see carefully, is linked to its parent, uh, the first child, and the sibling. So although div is also a child of the main parent div, but it's not linked to the div. So only the first child, which is the button, is being linked here. Now, whenever something has changed in our app, right, the particular element is tagged for any changes. So in a fiber tree, when say something in the button has changed, for example, the text inside it, the handlers, the fiber tree is also marked with these changes. And this is a current tree. So the current tree is only formed on the first render. The subsequent renders, we'll see what happens, but this is only on the first render. So now that we have a current tree, we also have a work in progress tree. So every changes that we see is being reflected in the work in progress tree. In the stack based approach, if you see, we had only one tree and we were just going, traversing down and changing the things in that particular tree itself. There was no particular tree. So in this, there's a work in progress tree. That's why it's sort of interruptible. So you can keep working on the work in progress tree, and once it's complete, you can go on to push all of these changes. So what happens in the work in progress tree is tries to clone each of the React elements. It sees what has changed, and if nothing has changed, it tries to clone that. So in this case, the app is being cloned. Again, it moves on to the div. It's again cloned into the work in progress tree. But when it comes to button and sees that it has been tagged for any changes, it identifies a fiber node that is being linked to it. So you have the current tree, you have the work in progress tree, and you have the effect list. So now the best part is because it has the effect list at hand, and it was making the work in progress tree as it was progressing. The React thread is free at a lot of times. So that's how it's interruptible in between. Now that we've come to the commit phase, this is something which is not interruptible. This has to be completed in one go, and all the changes have to be pushed on one go. So we have the effect list, we have the work in progress tree. What we do is we go traverse through this effect list, try to identify what all has changed, go back and re-render all of these elements again and have a fresh version of our dorm tree. And when all of it's done and we do have a fresh version, what happens is the trees are switched. So since we were working on the work in progress tree, and this has the current version of our uh, tree, so we just switch the tree, and this handles a lot of memory allocation and garbage collection because we don't have to do it again and again. That's why I said previously that the current tree is only formed once on the first render and on the subsequent ones. On subsequent ones, we only do the switching so that it's we save up on a lot of our uh, memory and we have a great performance. So render is great, isn't it? This is just a small chunk of how it behaves, but there's so much that it can do. And yesterday we were talking about React 18 and how we have batching and all of those things. So this was a very high level view of how renderer works, and this hopefully gave me a lot of idea of how things are working under the hood of something that I'm actually using every day. So it's great how we can explain all of these not in actual context but in the form of sketches. Just a broader level picture. For deeper details we do need text, but I had a lot of fun trying to create these sketches and try to use these analogies. And so was Babel. So Babel, although formed a very small chunk of how all of this plays out, but it's very important to understand that it plays a major chunk in how all of these things behave. So together we have a happy family, because although we know we always talk about React for what it does, it is not it was not possible because of the friends or sidekicks that it had. So it's great, and it's a happy family always and forever. Now, I would end on some resources that I had. I was able to make put these analogies in place just because there were a lot of great resources available on the internet that helped me understand how it all behaves. So you can definitely check out these resources. I will drop a link of the slides as well, and just have a look at them to understand on a much deeper level of how it all behaves. So yeah, I think it was great. I had a lot of fun talking here, and thank you for inviting me. I hope I could I did justice in explaining whatever I had to, and yeah, thank you so much.
Thank you, Tanisha. I really, really enjoyed your talk. And it was a really cool concept of how to explain React to someone. And sadly, we are out of time, so we won't be able to have a live Q&A. But Tanisha is going to be there in the lounge section. So if you have any doubts, if you have any questions, please reach out to her over there. And thank you, Tanisha, once again.
Thank you.
So I'll see you all in the next session. Please join over there. Hello, everyone, and welcome to this new session. We have Anuradha Kumari here with us. She's a front-end developer and a front-end consultant at Passionate People. She's also a Google developer expert and accessibility advocate. When she also, more than coding, she loves to travel, explore museums, reading books, and sketching. So Anuradha is going to talk to us about what more we can do with Next.js, because there's already a lot we can do, right? So Anuradha's talk is going to revolve around how SEO and accessibility can be leveraged in Next.js apps. Anuradha, please take it away.
Thanks, Rajat.
React India.
Hi everyone, my name is Anwara Kumari and I'm so excited to be presenting to you all today. Topic for my today's talk is taking Next.js applications to next level with accessibility and SEO. Before we start, a little bit of introduction. I'm working as front-end consultant at Passionate People. I'm a Google Developers Expert for web technologies and Cloudinary Media Developers Expert. I'm also an accessibility advocate. You can reach out to me on Twitter at miracle_404. So let's get started. The agenda for today is I will be talking about some tips for creating accessible and SEO friendly Next.js application. We will start with a brief introduction about these topics. Accessibility. Accessibility means making resources and services usable by everyone. There are multiple types of disabilities in the world, and the disabled people use different types of assistive technologies to access the web, like screen readers, switch, keyboard, etc. So, we need to ensure that we follow standard coding guidelines and make our applications accessible to all our users. SEO or search engine optimization means optimizing our application in a way that it starts getting higher rank in the search results when users search for the specific keywords. To understand why we need SEO, let's check how the search engines like Google, Bing, etc. work first. Search engine or search systems have four main responsibilities. They pass the content in all the websites. This is called the crawling phase. Then the data collected from the crawling phase is stored further for further access. It is called indexing. It might also perform some optional rendering operations if page has some client-side JavaScript. Then comes the ranking phase, where the data stored in indexing phase is queried as per user search inputs or keywords. Every search engine has a crawler, like Google has Googlebot. So, enough talk. Now let's code and see how we can do some of these optimizations. So I have the boilerplate already ready. I created a new application using Yarn Create Next app, and then I replace some of the default code using a very small, simple code. So let's see how it looks. So we have this website here. There is a simple header which talks about what this website is about. So I'm trying to create a demo game wherein we have different levels and you can choose the level and start playing the game trying to fight inaccessibility. So there are these list of levels, and then we have a default footer which comes with the boilerplate code. Now, what we want to do first is we want to run the Lighthouse report. For that, what we can do is right click on the website and say inspect, or we can use Control Shift I on the keyboard. And then this dev tool will open up wherein we will go to the Lighthouse tab, and there are different categories. We are interested today in accessibility and SEO. So we will select these from categories and create on generate report. It's going to reload the page and give a nice report. So we have got the results now. The score for accessibility is 97 while the score of SEO is 100. So why accessibility is 97? We got one error, which is we do not have a lang attribute for our HTML element. Now, language is a very important attribute for HTML element. It is important for screen readers because it lets them know that which language our page is in, right? So before we go ahead and fix this error, I do want to tell you that these Lighthouse reports, these does not represent the overall accessibility of this website because they only run the automated checks, and these automated checks contribute to maybe 30 to 40% of total accessibility issues. But today for this demo, we are going to take a look at these errors itself. So we ran the Lighthouse audit on our newly created application and we got this issue of missing lang attribute. What it is, so this is actually a very fairly common error, accessibility error. So WebAIM is a organization. What it does that it takes top 1 million websites of the world and it audits their homepage to check for accessibility issues, and then it generates a report every year. So if we take a look at the report, we see that there are 28.9% errors this year in missing document language, and it has only increased from the previous year. In 2020 February, it was 28.0%. You might wonder at this point that why does not Next.js by default puts a default language there, right? So there is a very nice GitHub discussion around it. I have added a link to it. You can go ahead and check it. And so let's see how to fix it. There can be multiple approaches. We are going to discuss about two of the approaches. The first one is adding a custom document, and then second one is using Next.js config. So how to add a custom document? We are going to create a underscore document.js in our pages folder and add the language to the HTML element inside it. So here I have created underscore document.js file in the pages folder, and I have taken this default code from the Next.js website examples. So what we are doing, we are using the HTML and head tags which are given by the Next. So here we have HTML head and then a body which contains of main and next script. What we are going to do today is we are going to add the lang attribute here, and since my website is in English, I'm going to use EN, right? Let's see how it affects the website. Okay, so if we inspect the HTML and see here, we see a lang attribute here correctly set to EN as I had said in my document. So this now, when we will run the reports now the accessibility score will also be 100. So we have fixed a very important accessibility issue right now with this. So now let's see how we can add it via Next.js config. So what we can do, we can add I18N configuration in our Next.js config, and we can also add different locales in it which our website supports, and then we can add a default locale. This is what will be picked by the HTML element and will be put into the lang attribute. So we just had one page for now and we saw one accessibility issue, we fixed it. Now let's add more pages and see what happens when we start adding more pages and start building up our application. I have 3 levels of game. So what I have done, I have created 3 different folders here because I want 3 different URLs like lowest, medium and highest. And I have added some boilerplate as well, code to it. So it's a form wherein it is a form where I have some questions and some answers. So let's see how it looks. Let's go to the level A. So this is my level A of a game, and if we see, we can see some questions here. So what I want to do, I want to repeat the step. I want to again go to Lighthouse and run the accessibility report. So I am again going to select accessibility and SEO from categories and click on generate report. So we got the results, and if we see at the scores have changed. For accessibility, the score is 97 again, and for SEO it's 80. So let's see what's the error with accessibility this time. So we see the error that this document does not have a title element. Now this title element, which shows up when you hover over the tab of that tab in the browser. So this is a very important information for accessibility as well as SEO. So it gives the overview of your page to the screen readers. It also gives the overview of the page to any user which is currently on that website, and search engines also rely on it heavily to determine if this website is really relevant to the search by the users, right? So this is the issue of accessibility. And then for SEO, if we see, for SEO there are two different errors, the title being the first one, and then the second one is there is no meta description for this document. Because now this meta description is also very important, because this is what appears when your websites appears in the search results. So this is what information is passed on the user. So let's see how we can fix this. But before that, there is one more important thing which I want to say, is that when I created a new page, here also I want my headers and footers, and let's see how we fix this. So first we are going to add a layout to my application so that I can have the headers and footers on all of the new pages which I create. So in my components folder, I have created a layout.js file, and what I have done here is I have just copied the header and footer from the main index file. And so the header will contain the heading of the page, and the footer is simply says that it's powered by Vercel with an image of Vercel. So now here also it's point to be noted that it's also an accessibility thing, that whenever we are creating any image, we must always add an alt to it. Now for this example, I have an anchor element and it only contains an image, there is no text. So if I will not add an alt to this image, so the screen readers will not know what to pronounce to the users, like what this link is about, and this makes it highly inaccessible. So we are going to tell them that what is this image is about, like what is relevant to it. So maybe even Vercel should be good enough. And then if there are some images in our websites which are like decorative images, so they do not have any information to the user, they might not have any extra information to the user. So what we can do is we can add just an empty alt to that image. But in any case, always make sure to add the alt attribute. If you do not add the alt attribute, then it's highly inaccessible, because some of the screen readers might pronounce the source of the image, which will not make any sense to the user, and it gives a very bad experience. But if you have alt as empty string, it says to the screen readers that, hey, I want to skip this for the my assistive technologies users, because this is not a relevant information for them, and then the screen readers will skip this section. But if you have all images which have some information, then make sure to add proper alt attribute to it, so that the information is passed on correctly to all the users. So what we have done here, that we have created header and footer, and the main content which we want in every layout on every page, that will come in children, and I have wrapped it in main, because all my main content should be in the main tag. So let's first start fixing our base index page. So in index page, I had footer, main, and also what I'm going to do, header, footer, main. So I'm going to remove all this, and I want to say, hey, I want to use layout here. Okay, so it's a layout, and I remove this from here as well. Right. So, and I have done the same for the lowest. So in lowest, if you see, we just had a section. So I will wrap it with layout. And let's see how it looks. So this is our lowest level URL, and we see now that we got the header and the footer here as well. Yay! And if we go to the home page, also we see that we have the header and footer. So we are good. Now let's start adding the title and meta. So to add the title and meta, we need the head element from Next. So we can add it inside the head and it will properly get added to the head of our HTML. So what we are going to do is first we are going to add a title. And in title, I want to let the users know an overview of what my website is about. This page is about, right? So I will write the name of my game and say that, hey, this is a game and this is the lowest level of it. So they know exactly where they are in my website. And to add meta descriptions, we can add a meta tag. So here, what is this meta? So we have the name that, okay, we are adding a description and the content of it. So the meta is always in form of name and content, in which we tell the key should be in the name and the value in the content. So I want to say that I want to add a meta description and it should hold this value about this game. So this gives a very nice overview of what my page is about, some information which might be useful for the user. So we have added these, and now let's run the reports and see how they do now in the accessibility and SEO. So I'm going to run the Lighthouse report again. So we got the results, and now as we can see, the score is 100 for both accessibility and SEO. So we saw how we can add a reusable code in a layout component and how we can also add title and meta description in the head tag for every page which we create, so that it is optimized for search engines as well as for screen readers. Now let us see at some other important things for SEO. The first one which we are going to look at is robots.txt file. So this is a file which tells the screen engine crawlers that which URLs they can access for that website. We can also use this to block some of the less important files like images. Let's see a sample of how that looks like. So this is a sample for robot.txt file, and here we can see that if we want to block some URLs, like let's say I have some admin URLs and I want to block that, so I can also specify which user agent I want to block it for. So let's say I want to block it for Googlebots, and I say that, hey, this allow this website or this URL to be crawled by Googlebot. And then for other cases, we want that all of the bots or user agents, they crawl all of my all my URLs on this website or application. We can also add a sitemap to our robot.txt file. So this brings to the next question: what exactly is a sitemap? A sitemap is a file in which we provide some information, and it helps to communicate with the search engines. So where we provide the information about our pages, URLs, videos, and other files on our websites, and also the relationships between them. It helps the search engines to find, crawl, and index our website's content. And it also tells the search engine which pages on our website are most important. There are multiple types of sitemaps like normal XML file or video, news, image, etc. And a point to note here is that a sitemap might not always be needed for a website, but we are going to add it today for our website and see how we can add it. So we can generate sitemaps in multiple ways. We can also add it manually by creating a sitemap.xml file and then keep on adding all the URLs as we create new pages. But that takes lots of efforts, right? We can also use multiple ways. I'm going to show you where we can use a package to generate sitemaps for our website. So the package I'm talking about is next-sitemap. So we can add this to our application via in-depth dependencies by running the command yarn add next-sitemap -d. So it adds this dependency as def dependency in our package.json, and then we can create the configuration which we want in a file called sitemap.js. Then what we will do, that we will add a post build script so that sitemaps gets generated after the build is succeeded for our website. So let's see how we can do this in action. So here we can see that in package.json, next sitemap is added as a def dependency, and we have a sitemap.js file also at the root level. Now, what this configuration contains? So this contains the minimum configuration which is needed. We have a site URL. It contains the base URL of the website. So, for example, my website is currently deployed on Vercel and it sits at this URL. So I have added the URL in this site URL, and I also want to generate the robot text file. So I say it's true, and then we can set the default size of a sitemap. And then in package.json, if we see, we can see that we have added the post build script here, wherein we are running the next -sitemap, and we are telling it to use the configuration from sitemap.js. So I already ran the build, and then let's see how it shows up in the public folder. So the results of the robot text and sitemap XML files will be added in the public folder, and we see now here that there is a robot text file and then there is a sitemap, and in sitemap, as we can see, it shows all the URLs which we have. So for this current application, I have the base URL and these 3 levels of games, so 3 URLs. So it generated this for us. Now that we have done these search engine optimizations, the search engines where the crawlers will do their job and index our page and rank it depending upon the content and the user keywords, right? But our job is not done after this. We also go ahead and share our application with people, because we want people to know that we have created something, and they can take a look at it if they want. So we share it on social media, right? But what will the user see when they see your application's link on the social media? Like, what will be the preview of social media for all our links? So we have multiple ways in which we can validate how our link looks like when we are sharing it on multiple social media. Like Twitter has a Twitter card validator of its own, LinkedIn has a post inspector. We also have this meta tags preview website, which I really like because it gives you a preview of all the social media at once. Now we are going to check our website for this meta tags preview and see how it looks. So the code which we have written till now is deployed at the URL, this URL. So what we are going to do is on metatags.io, we are going to paste this URL and see how it looks in different social media. So for example, in Google results, it's going to show you this title which we have added, and then the meta description. And then for a different social media, like for Facebook, Twitter, so this is going to show you there is no image, so there will be no like rich experience or something, just the title and the URL. So users might still click on it, but if we add something more, like a very rich experience kind of thing, a very maybe a nice image here and some more information, then there are more chances that users are going to go ahead, get curious, and click on the website and see what's there. So let's see how we can add this. So we have something called Open Graph. Open Graph is an internet protocol which enables any web page to become a rich object in a social graph. So whenever we are sharing any link, we can also customize it to contain rich information like title, images, URL, and type. So, and the way in which we add the open graphs is we use the meta tag again, and we in the property we write the name of the OZ value which we are going to add, and in content we add the value which we want for that particular Open Graph. What we have done that in our base index.js file, and we need to add these meta description again in head. So we have added these different Open Graph values. And now if we see how it looks, so in Google again, the search results come, whatever we have in the title and description. Now in the social media, it also shows up the nice image which we had added in our Open Graph image. So this gives a very nice overview to the users and makes the user experience better. So now that we saw how to add open graphs to our websites or applications and provide a rich interface whenever sharing it on social media, now let's conclude. So the key takeaways for today's talk are that always remember to set the document language correctly. Add title for every page so that search engines as well as screen readers know what is the overview of that page, and add meta descriptions as well. We also saw how to add robot.txt file and sitemap XML file via configuration. Then we saw how we can add the open graph in the head tag by using meta tags, and how to make enriched social media preview cards. So I have also added some links for the further read, which we can go ahead and explore more on these topics. And all the examples which I have shown today all are at anuradhakumari.com/talks. Thanks a lot. It was very nice presenting to you all.
Thank you, Anuradha, for that wonderful talk. I learned a lot of things, like create React app when we use that, right? A robot.txt file is always there. But usually what I do is I delete that. I didn't know what that is for. But I'm not going to do that anymore. And also the open graph thing, right? I love that. You know, I always like whenever I post something, some once or twice some other info used to come, what I didn't want them to see, or some wrong info. But thank you for showing that. I'm definitely going to. This was very helpful for me at least. And
Thank you.
I think we have finished right on time, so we sadly won't be having a live Q&A session. But Anuradha, please stick around in the lounge room. And guys, please reach out to her. She knows a lot about accessibility and SEO. And please take all your doubts and questions to her. Or just to say
Sure.
hi, just to talk. Just you don't always have to have a question or something, right?
Yeah, so I will be there in launch. Yeah, see you all there. Thanks a lot. It was very nice presenting here.
Thank you. Okay, guys. Bye. Hello, everyone, and welcome to this new session. We have Rishabh Thakur here with us, who is a front-end engineer at Grow. Rishabh has just graduated, and he's already doing a lot of cool things with JavaScript, and he loves to tinker around on with anything, not just JavaScript. Give him anything, and he'll just break it down and build it back up. Apart from that, he's a very big football fan, but I'm not sure how to feel about that because he's a Man City fan and I'm a Liverpool fan. And we recently had a match, and so we are still talking about that. Anyways, Rishabh, please go ahead with your talk. Rishabh is going to talk about how we can use Web Audio API in React, right? Okay.
Yeah, yeah. Okay. Thanks a lot, Rajat. Cool. We'll just start. Yeah. So, sorry for that. Yeah. So basically, what we'll do here in this talk is try to make some beats. Try to have some fun, right? And so, with that about me, I'm a front-end at Grow. Like already, Rajat has given the introduction. But yeah, here's my Twitter handle if you want to follow me or want to reach out. Right, DMs are open. Cool. So, what's the purpose of this talk, right? Like, it's a very different talk than the other talks that we have. So, I guess it will make you a cooler dev, right? And the most important thing, maybe it will inspire you to try something of your own, especially the new folks out there, right? Probably present that in next conf and maybe learn a new instrument, right? So, here's the structure of like what we are going to look at. So, there's Web Audio API, then we'll look how to play a sound and how to create a one, right, through computerized oscillators and stuff. Then we'll learn to master the art of rhythm. Then we'll learn the power of the filters, which is way too much, right? And then we'll finally visualize the sound. And last chapter will move how to structure some complex app like this one where there's a lot of UI state and a lot of things happening. How you can make that in React, right? Make it work in React, right? So before I start, let's just do a quick audio check, please. So you're going to listen a lot of sound from the speakers that I'm playing. So I'm just going to play a beat just so that you can see if you can hear it or not, and just adjust the volume if it's required, right? So hope that is audible, I guess, probably. Then otherwise it will be very bad. But yeah, and I hope it energized you in some way. So okay, moving on. So what basically is in Web Audio context, right? So it's basically a graph, right? And this is the simplest graph you can think of, right? So we have a source node and we have a destination node, right? Source node is something that is playing audio. We'll look into this more. And you need to connect it to destination to hear it. So destination is basically your output or your speaker, right? Cool. So apart from source node and destination node, right, what we can have is modification node and analysis node. So modification node basically allows you to control frequency or volume in numerous ways. Like this thing gets complex way too much. I'm covering what 1% of what is there in the Web Audio API, right? So you can see an example of this thing where there's a individual source nodes that is connected to their individual volume control. So by gain, we mean amplitude or volume, right? And then we have a master volume control or master gain. And finally, it's all connected to destination, right? So this then can go even more complex where we have some kind of effects like low pass filter or panner. Panner, if you are in car and you move that like button to the left, the audio is only playing from left, right? And if you move it to right, it's only playing from right. So that's what a panner is. And yeah, there are multiple effects, right? So enough like talking, let's see how Web Audio API is actually visualized, right? So what we'll do is basically create this example which we have seen, right? This is more simple example. So what I've done here is created a buffer source node, right? Like these two are those buffer source node, and I've loaded the sound of bass guitar and a guitar. Cool. So now what I've done is connected individual gain nodes here, right? So there's that. And if I play it, okay. So if I play it, you won't be hearing it. Why? Because it's basically not connected to destination. So before connecting to destination, like, okay, let's take this simple thing. If we connect it, yeah, you can actually hear this sound, right? Now, instead of directly connecting it, it will add another gain node, connect it to that, right? And then connect this gain node to to the speaker, right? And if I play both of these sounds, you can actually hear it, right? And I can control the individual volume, or I can bring the whole volume down. Like, hope this gives you an idea of web audio API is like this. At least this you should take away from this talk, right? It's basically a graph, right? And fun to play with that also. So, okay. Moving on to the chapter 1, which is basically playing sounds, right? So we'll see how you can, play sounds, right? So there's the demo which we're seeing, which we're going to be building. So the source node can be three things, right? So it could be an audio tag, sorry. It could be an oscillator, which we'll see what it is. And it could be an audio buffer, right? So we were going to use audio buffer. So if I, let's say, move to the code. So all we have is a bunch of file here at the top, right? Which we am calling sound map. What I'm doing is basically loading that into buffer, and it's kept in the buffer object, right? And this is where the magic happens. So what I do is I create a source node, right? Through calling create buffer source, I load in the buffer that is passed to me, right? And then I, most important thing, connect it to destination and start it, right? So on each click here, what I'm doing is calling the play sound with the actual buffer that is there, right? So if I go to the drum pads demo, I can actually click on this and you will hear sound, right? Right. So that's like step 1, right? Moving on to step 2, which is more interesting, and that is basically creating your own sound, right? So the thing we need to understand here is how to create your own sound is creating the simplest sound, which is basically an oscillator. So if I go back here, oscillator is nothing but like it's basically a frequency that is playing. It's a simple clean wave that is playing, right? So if this may sound a little harsh, so sorry, because the basic wave is very boring and very hard to listen to. I'll convert it to triangle. That's little bit. So yeah, you get the point, right? It's very harsh, but basically we have the basic component to create a sound, right? So let's create one. So what I will do is move on to this. So if we see the demo now, what we have is our own little Mario, and it's jumping, right? But it's not playing sound that is there if you have played the Mario game, right? The jumping sound, right? Boop sound, so to say. So we'll create one. All right. So what I will do is create an oscillator. Thanks, Copilot. Yeah. So what I'll do is create an oscillator, and we'll set the frequency value to 350, right? So a clean wave of 350 hertz, and it can be of various type. The structure of the wave, I will say it should be triangle. So I will say let it be triangle, right? Let's try to hear only this. So I will say I need to start it. So I will start. So I can say 0, which will start it immediately, or the same thing is basically saying context dot current time. All right. And then I will stop it, right? So I need to stop it about what? So like about 0.5 seconds from now, because it's a very harsh sound. I don't want to play it for a bit longer. And most important thing, I forgot to connect it. So let's connect it to destination so we can actually hear it, right? So so this is the sound, but it's not the Mario sound, right? Which we know, right? So let's create that. So what I will do, I can actually control the frequency, right? So I will say the frequency needs to be increased to 600 over exponentially over the time period of 1 second, right? So this is what it's doing, right? There's a function called linear lamp to value, but I need an exponential jump. So basically the frequency will go from 350 to 600 over a time period of 1 second. Meanwhile, also we need to bring the volume down exponentially. So what we'll do is create a gain node, set the gain. Okay, let's rename it to gain node and set the gain value to, so exponentially bring that value to 0 over a time period of 1 second, right? And I need to connect that gain node, right? So I will connect the oscillator to the gain node and gain node to destination, right? So if I now reload this and play, I don't know how many of you have played the game, but this is actually how it sounds. You have to trust me if you have not. So if you can hear it, this is the jumping sound of Mario, right? And this saves you a lot of space. And back then, Mario times space was a very big deal. So it makes sense to generate it instead of playing it. So that's chapter 2. Cool. I'm sorry for the pace, but I have a lot to cover. So let's move on to the chapter 3, which is the dopest chapter. It's basically learn to control your rhythm, right? It's very important in music to control the rhythm. So instead of set time out, set interval, all those boring things, we have seen it already also, but you have a web audio API clock, right? So you can get the current time, right? And try to schedule it with that. And also you have this start function where you pass in the time, right? When it's supposed to be playing, right? So if I go to rhythm, I won't be going too much into the demo because it's basically a drum sound and it requires bar knowledge to schedule it. But basically, think of this, right? So I'm playing bass at zeroth, then snare, and then bass, and then again bass, and at the sixth note, I'm playing snare again. So it's basically like bass, snare, bass, bass, snare, right? So that's what it is. So you can use this context.current time to calculate the start time, and then rest of it is just plain simple maths. I know you didn't like maths, so I'm skipping. Cool. Let's just see how this looks and how this sounds, right? So I'll play it. Right. So what I've done is schedule over 3 bars of music, right? So it's repetitively played that over 3 steps, right? So that was chapter 3, controlling rhythm. Okay, moving on to the 4th chapter, which is very mind-blowing and as well as complex probably. So that is basically using filters, right? So we have a biquad filter, right, which again has various types. So there's low pass filter. What it will do is basically say, okay, the sound below this frequency or below this threshold is allowed to pass as it is. The sound above it will be somewhat attenuated, or the volume of it is quite decreased, right? And you can control the volume also. High pass is just the opposite of that. The frequency above are allowed to pass through. Band pass is basically uh, frequency in between, and that is allowed without any formatting or without changing the volume. Rest of it is changed or attenuated, right? So then there's this compressor node, right, which will basically make your sound compressed. So if you have a gun sound and you want to mimic the compressor, you can use this effect, right? You can use this filter to achieve that. Then there's you can use even oscillator and amplitude in a way that is very different than what we are seeing. So we are connecting the amplitude to the gain here. So this creates a tremolo effect. So if you are listening to guitar, this is a very common effect. What happens now is the volume is actually oscillating. So let's say I'm playing guitar here, and yeah. So if I'm playing bass guitar, right, and so it's basically like a sine wave, it's oscillating, right? So it creates that kind of an oscillating effect, which sounds very good in a guitar, right? So this is the demo for that. What I've done, I don't expect you to follow this, but just to realize how powerful this is, right? What we have done still now is basically we have the recorded sound of the drum right here, which has been recorded in a studio, right? The kick sound, the snare sound, right? What now we can do is actually through these filters and oscillators create our own drum sound. So this demo is same as the rhythm one. The difference is that the sound is actually produced, right? So let's quickly take a look at how it's done. It's very complex baby, but it's not actually. Like if you give this time, it's very easy. But yeah, in this talk, it will be too much. So basically, in Kick, what we do is set the frequency and bring that frequency down, also the volume down to zero over a period of 0.5 seconds. So Kick is very clean. Snare is a very punchy and a noisy sound. So what we do is create a noise buffer, load it with random values, bring its volume down, and for the hit that happens on a drum, what we do is create a triangular wave and bring that also down over a period of time, right? So if I play this is the same thing, but the sound is actually generated through computers, right? So right, so this was basically sounded a little bit different. I don't know if you're hearing through speakers than through microphones, so maybe that effect won't be there for you to see, but there's slight effect in the recorded sound and the generated sound. Cool. So last web audio API chapter is basically what you can do is actually visualize the sound. So what you do is create an analyzer and create a array, frequency array, right? And just pass it to it. So this will load the array with the current state of the music, and since this is get byte frequency data, it will give you the frequencies and the volume for that frequency. There's also a get byte gain data, right? So that will give you gain over a period of frequency. So okay, yeah, forgot about the demo. So we have this demo, so I will just give out the demo and explain what's happening. All right, let me bring volume 2 points down. Cool. So basically, at the left side, we have the base frequency like 100 hertz, 200 hertz, right? And as we go, it gets higher. So the voice type of frequency or the high pitch frequency is here. So if say the bass is playing, which is a low frequency, then the visualizer will be more active in this area. But it is right. Like bass is oscillating like over like what one. So you can see that it's oscillating with the drum as the drum is playing, and similarly the rest of the music is moving. So you can go crazy on this, like in audio visualizing. You can use Three.js. This is made with D3.js. You can use Canvas. So basically, you have the array, right? Do whatever you want to it. So all those music videos where there's a visualizer going on, you can create it. And if you check out CodePen, some few guys have done incredible stuff using this audio visualizer. Cool. So yeah, so I have 10 minutes to cover this thing, right? So this is the pipeline of a music instrument if you're making, or a complex music application if you're building, right? So the things to notice here is there's first of all a lot of UI states. So there will be like lot of slider, lot of knobs. So if I see this particular demo, right? So there's a lot of UI elements to control. There's individual volume and stuff goes on and on, right? And then there's, for each source node, there might be an individual filter that is applied to this particular source node only. Then there's something called master filters, where what happens is key any sound that is playing must go through this master pipeline where the effects are applied to every sound. So if I wanted reverb effect on every sound that is playing, I'll put it in the master filter section, right? And then it also has sliders and knobs, right? So it can get pretty out of hand soon, at least for me, right? So one tip on that is keep your UI and audio context separate, at least internally. Like I get it. Like you want to make a component for what? Controlling volume, which is bind to the UI. Do it, but at least do not do it internally, because you might need that gain node, and it even won't have a UI to render, right? You may create an oscillator that won't have a UI component or a UI thing to render, a JSX to render. Also, it adds complexity and reduce reusability, which we're going to see, right? How to achieve that and how it increases usability, right? So first thing first, you're going to use context everywhere, the audio context, by the way, right? Like context.create buffer node, context.create gain node, context.destination and stuff. So just simply put in React context, right? So sorry if this is confusing, but your audio context lives in your React context, right? Just to make it clear. Cool. So for creating those audio nodes, try using hooks, right? At least in majority cases, hooks works best, right? So this is not a very important hook, but what it does is basically for the URL returns you the buffer, right? But let's move on to something interesting, which is creating a buffer source node, right? So what I can do is pass in the buffer, pass in the output node and all those controls, right? And I can create the node here and I will return the node. So your React application or React component doesn't need to know about how to create an audio node, right? That is abstracted away. So there was this one problem that start can only be called once, right? So what you can do is call play. What I've done is I've wrapped the start function over play and stop, and I'm just creating a new node as soon as play and stop is called, right? uh, so I know this is a lot of code, but let's just see how it plays out in in your React application. So what I've done is created a gain node using useKey and created an audio buffer source using this buffer and this hook, right? And I've connected the gain node to the destination while I've connected the buffer source node to the gain node. So it's basically buffer source node, gain node, and this destination. And I'm simply calling this function. Now, the power of this is, let's say you want to put a UI state, like a slider to control the volume. It's basically two lines. Just create a state, pass it here, and pass it to the slider, right? And let that UI component handle that state, right? If you want to replace, let's say, buffer source node with oscillator, it's again a few line of change. Yeah, you have to create this play oscillator function, but the change is very minimal, right? Since we have hooks for that. And now what you can do is create a UI component. So like drum pads, right? You want to create a pad, right? So now you can actually, call this a pad and use this everywhere instead of, creating hooks and then creating the UI component. But I will suggest you can start this way. That helps a lot, right? Regarding the master filters, right? So individual filters are created for each source node, whereas master filters are here to stay. They are created a single time. So how to handle that? There could be a better method. The way I thought of it is just again put it into the React context, right? And expose the last node where individual source node could actually connect, right? So the change will be again very minimal. So instead of output node to be context or destination, it will become master context, which we are using it from here, right? Cool. So some other points which I missed out. You can use multiple audio context, but see if it fits your application. You sometimes need to resume audio context because like if the user has switched the tab for a long period of time, JavaScript doesn't allow you to play sound immediately. It may be very harmful or it may be not a good experience for the user, right? Do disconnect your nodes, right? You can see how to do that because it may cause memory leak if you're not doing it. You can actually schedule the sound, which we have done in the third chapter, to be a look ahead. Like you can say, okay, I will schedule all the sound that are going to be played in the next 2 seconds, right? This increases performance if you are very performance heavy in the audio context department, right? Cool. Let's move on to the final thing, which is basically the demo, right? I have got 3 minutes. So this is basically a drum machine. I know like a lot of you don't know it, but this basically allows you to create beat and now will create one, right? So I'm dropping the bass here, right? So let's bring the volume a bit down, right? And increase this. Cool. let's add snare. All right. So I will drop it at 5 and 13, right? Let's bring in hi-hat. So right, and why it's not that fast. Right, so now there's a lot of effects, right? This won't be sounding good to you, but it does sound good to me, right? So because you are hearing it from speakers, right? So this effect, reverb effect, you can check it out what it does, but it's a very cool effect. Cool. Then we can again go crazy, right? So right, and there's this tap mode also where you can, actually tap it and it will play the sound. So like okay, I'm going to stop it. So that's the like whole purpose of this talk, to go out and do something like this, like even if it doesn't help you in your job or you think it's maybe a waste of time, waste your time. Like basically that's my one thing I can say, right? Cool. I guess I've prepared one more beat, which is actually the same thing. I guess let's play it like one last time. And yeah, yeah, both were quite same, right? And you can actually switch to the tap mode and play it also. Okay. So right. So yeah, I mean, there's the clock running. I would like, if anyone is interested, I know I've skimmed it very fast, so please do reach me out if you are interested in this, because it runs deep. So any effect you have seen DJ do or a plugin DJ have used to create a sound effect, you can theoretically at least do it in Web Audio API, right? And there's MIDI control and live input as well. So if you have a MIDI device, let's say a synthesizer or something, you can connect it to your browser. Cool. That's it. Thanks a lot.
Thank you, Rishabh. We have one question from Manjula itself. She's asking, how much time did it take you to build this?
It took time, but it's so like 1 month or so. Like I was playing, like this was during lockdown, most of it, so I was bored anyways. So
That's a really good way to spend your time. Yeah.
cool.
Yeah. I think Manjula was asking it because maybe, for the next React India, we can hire you to make the soundtrack.
Yeah, I will be the DJ for sure.
Yeah. Also, another reason, we wish this was a live conference, I just got one, is that if you were here, I don't know if you can see, we have a drum set, keyboard, we could have a live jam session right here.
Definitely.
Yeah. So, guys, Rishabh will be here in the lounge area for some time. Please reach out to him, ask him anything about React, music, or even life, So, yeah. Thank you, guys. I'll see you in the next session. Hello, everyone, and welcome to this new talk. We have Dhaivat Pandya here with us, who is a full stack engineer, and he's just 20 years old. Can you believe that? And he already knows React, TypeScript, and serverless, right? And today he's here with us to talk about, how someone can, ship their own NPM or React packages. I mean, we think it is very easy, right? But there's a lot of things we need to keep in mind, and that's what Daivat is going to share with us. So, Daivat, yeah, would you like to add something?
Yeah, I think personally, I shipped a NPM package myself in the last year, and that's where I learned a lot of these things from. And I found that these things are not always straightforward. So I tried to put together things that are might be useful to everyone.
React India.
Hey everyone, I hope you're enjoying the React India conference. And today I would like to share my 2 bits on how to ship modern and maintainable React packages. So, first of all, a brief introduction about myself. I'm a full stack contractor. I'm mostly working with the JavaScript ecosystem. I've authored 2 packages that people actually use. I sometimes like to write about React on my blog, and I'm at the red Daivat 10 everywhere. Okay, let's get straight into the talk. So, what does a good package need to have? Now, the answer to this question can vary a lot depending on things like what's your biggest target with the package, what's your use case. But for the sake of simplicity and for the limited scope of this talk, I have decided to choose 3 variables that I think play the biggest part in deciding whether a package is good enough or not. The first one, I believe, has to be a good developer experience. Like we know, packages are developer facing rather than user facing. It is something that is almost always used by developers. So, if a package is not easy to develop with, there really is no point. Things like type definitions, documentation, code quality, community, all of these things play a huge role in deciding which package a developer would choose over another. The second point is usability. Now, this includes things like how does it ship its JavaScript? How does it ship its CSS? As you might know, some packages don't ship their styles properly, and it causes all sorts of errors with frameworks like Next.js. So those things are extremely important, and of course the functionality itself, it should work, it should do what it is supposed to do, right? And the third point is the maintainability. Again, code quality, you can never go wrong. Things like lines, documented change logs, so you can actually make an educated decision when you want to upgrade a version and things like that. So yeah, those are the 3 biggest factors in my opinion, that decide whether a package is better than another one. So yeah, that's what I'll be aiming to share with this talk, how to achieve these 3 things when shipping a React package in particular. So as a demo, I'll be showing you around this package that I created for the purpose of this talk. It's published on NPM and it's very creatively called Daivat UI. It does literally nothing. It has things like a button and a heading and an input. So I will be basically showing you around the entire setup, and we'll be talking through what tools we are using and why I am using them and how do we set them up. So let's have a quick look at the tools that I have used for this setup for this dummy package. We'll of course be going through each of these in detail when I walk you through the code later, but let's just quickly go through each of them. we are using Rollup as a bundler. So Rollup will basically take in all of the TypeScript or JavaScript files and bundle it and ship. And that JavaScript file will eventually be shipped to npm and will be consumed by your users. TypeScript, obviously, it will help us ship type definitions to our users. Semantic release, it will help us manage the versions of our package and all of the setup around it. I'll show you through, obviously. Storybook, it will let us develop components in isolation. Jest React testing library for testing, of course, and GitHub workflows to set up some pipelines that will aid you in the automation part. So the next thing we'll be looking at is, so as you might see, a lot. This is our actual source code. So yeah, let's go through all of these things one by one, shall we? Let's first look at the package.json. This thing essentially is the foundation of your package. So at the beginning, this is just some metadata about your package. The only crucial field is this. This is the name of your package that will actually get published to npm. So make sure that you get this right. Okay. Next, let's have a look at some of these scripts. Most of these are pretty standard build dev scripts. The only real interesting one is this component new. So what this script lets us do is automatically generate all the needed files like tests, CSS, boilerplate, JSX, things like that for any new component we want to create. I'll demonstrate this later on, but just keep this in mind for now. Then there is this publish script which does what it says, but it uses this thing called semantic release. We'll also get back to this later, and this is important. Then there's no dependencies, always a good thing. We have React and React DOM as our peer dependencies. Then there are a lot of dev dependencies, but we don't need to worry about that for now. I'll be going through their config files instead of going through them here. And we have a system setup for releasing our package automatically. Again, this is not a good place to explain this, so I'll actually demonstrate releasing this package to you. So I'm sure you will understand it better that way. Next, let's have a look at the rollup config. Rollup is our bundler, like I said before. So this is another crucial configuration file. So yeah, there's nothing really fancy going on even in this config. Basically, we are just specifying where our entry point is, where we want our output to go. We are also specifying that we want our output in two formats. One is the ES modules format, which is a modern version of JavaScript. And then there's the common JS format. So for older versions of JavaScript, then we have some plugins going on. Post CSS plugin that this will let us use things like SCSS within our project. We have some TypeScript configuration. We have Cursor so that any comments that we write in our code don't actually get pushed in our final bundle. Then we are just copying the license and README to our build. And we are also, of course, copying package.json. Okay, that's really it. That's all the configuration we need to bundle our package. Then we have just config, again, very standard. We are just using this plugin to mock CSS, and nothing really fancy besides that. We have standard ESLint RC, we have style lint, and we have a standard TS config. Next, we have the storybook config file. Again, we are specifying what format our files are going to be, and we are just adding support for SCSS files so that we can actually see what our components will look like with CSS. Okay, now let's have a look at our source code. So the entry point doesn't really do anything, it just exports the contents of the components folder. So let's have a look at one of the components. So for example, let's look at input.tsx. Really standard, just a React component. We have stories for it, and we have SCSS. And we are just exporting it from here. And we have some not very useful tests. Let's start the storybook server so I can actually show you what the components look like. And while that starts, why don't I create a new component? Let's call this code block, and looks like it generated some boilerplate for us. But before we look at that, let's have a look at our beautiful UI library. As you might have already noticed, it doesn't really do anything. It's just a funny looking UI library. But hey, it's out there on NPM and it works. Let's create our code block component. Again, this is not going to be anything useful. Please don't take it as an advice for creating UI libraries, but we're just going to take in some text and display it inside a code block. And we are going to write some stories for it, but I'm not gonna waste your time. I'm just gonna copy it from another file. And no, we don't want that. We just want a code block, and there we go. That's our code block. Wait, that's not really code, is it? Okay, much better. There we have it. That's our code block component. We can give it some styles. I'm not sure how pretty we can make this, but let's try. Let's give this a class of code block, and maybe let's try to give it some border and some padding. Okay, fair enough. Now I'm not gonna write tests, but you definitely should. But as we have limited time, we're not going to go there yet. So this storybook is just like a space for developing your library easily. You can easily see your components in different states. Now, of course, we are not going to waste time making this pretty, but you can imagine how a wonderful feedback loop this can be when you're actually working on something meaningful. Okay, now that we have everything in place for our very useful code block, let's lint our code before we push it. And there we go. We have a problem. No end of line. in the commit message will eventually determine how my package's version get bumped. Like I told you before, this package is already live on npm, so it's already on version 1.1.0. Now this configuration that I have created, it, by the way, I have not created this entirely. This is thanks to this beautiful template by 6foot6 Designs. But this setup basically lets you bump your package's version by just writing appropriate commit messages. So as you can see, there are some prefixes that you can use in your commit messages, like docs. If you're just making changes to the documentation, it won't change your package's version. If you're refactoring your code, it won't push a new version to npm. But if you're releasing a new feature, it will correlate to a minor version bump in your package's version. Look, semantic version is a rabbit hole in itself. You should just Google it and learn about it. But this will basically bump my package's version from 1.1.2 to 1.2.0. So let's see it in action. We're gonna do add code block and we're gonna push it. I need to pull down. And looks like it pushed. Let's see the pipelines. I haven't gone through the pipelines yet, so let's first do that. In this is basically the configuration which is running the automatic release lifecycle or workflow. What's basically happening is whenever I push a commit to GitHub on the main branch, it tests my code, it lints it, and it builds. Then it publishes the code to npm. Okay, it looks like the pipelines passed. I just probably skipped ahead because these pipelines take some time to run. So in the first step, like I told you before, it just builds the code basically, and this is the important part. This is where the release was done. So as you can see, the new version is 1.2.0. There we go. And if we refresh the package on npm, the new version is here. That's all it takes to really push a new version of your package if you're using this setup. Now, this is all in good, but if you want to start using this setup in your project, or if you want to create a new project with a similar setup, you'll probably have to set up the workflows. Now, you need 2 tokens for that. You need an npm token and a GitHub token. For the npm token, you just need to create an account on npm, and once you log in, there will be a tab which will let you generate an access token. The same goes for the GitHub token. All you need to do is go into a profile settings and generate a new personal access token. Now, once you have those tokens, you need to create entries for them in your repos secrets tab. This is where your workflows will actually get those tokens. We need to create these 2 entries in your repo. So once you do these 2 things and you have a correct name in your package.json, you're ready to go. all you need to do is just push to your repo with an appropriate a prefix, one of these, any of these, and it will automatically push out versions for you. Now that our package is live on NPM, let's actually see it in action. So I've gone ahead and created a very basic Next.js application, and what I'm gonna do next is install the package directly. And there we go. That was fast. Now let's start the server and let's import our components. Let's maybe import the button and the code block and the heading. Let's use the heading hello. Let's add a code block which says and let's add a button. Let's start up the server. We need to pass text to the button, of course. And there we go. Those are those are components from our very own UI library that we just published minutes ago to NPM, and it's live there in our Next.js app. So yeah, that's pretty much it. We went from creating our own NPM package, adding a component to it, publishing it to NPM, and then using it in a live Next.js application. I hope this was helpful. I'm sure I couldn't explain every single little detail about this setup because it is there's so many moving parts in there. So I highly recommend checking out this repo by 6foot6 Designs. They are wonderful people. It's a fabulous setup, and I highly recommend that you go and have a look at all of the tiny little details that they've put in to create this automated setup. And I hope this was helpful, and I hope to see some of your questions. Please be sure to leave any feedback, good or bad. And thank you for listening to me. Thank you for giving me your time. Thanks the organizers of this event for letting me speak. And I hope to see you guys soon. Have a great day and enjoy React India.
Thank you. Thank you, Dhavat. That was a really good talk. And I especially learned a lot about how to upgrade versions. My team, they do a lot of manual version upgrading and it takes a lot of time. So I'm going to pitch your, what you have shared here, and I'm going to really make a case that we should start using something like that.
Awesome. Thanks for hosting this, Rajat.
Yeah, we have a couple of questions. I see that you answered them on chat as well, but we have some more questions also. So let's take a few. Sure. Okay. So we have a question on how do you reflect live changes in the package project?
I think I'm assuming that you mean that when you're developing locally.
Yeah.
So what we're using for that is Storybook. Storybook basically will scan your source folder for any TSX files, basically, to view all of your components in isolation, so you can just focus on one thing.
Okay. We have another question, which is, can you tell us some differences between dependencies, dev dependencies, and peer dependencies? I mean, I always get confused about peer dependencies. So yeah,
Sure. So the biggest difference is where these things live, basically. So dependencies are things that your project needs uh, on runtime. So if you ship your package and someone installs it, they will have to install those dependencies too. Dev dependencies, as the name suggests, is something that you only need when you're developing the project and not when someone is using it. So these things will not get pushed in your bundle. They will not affect your bundle size at all. They just help you develop the project better. And peer dependencies are these dependencies are the dependencies you expect the consumer to have in their project already. So if what React packages usually do is they have React and React DOM in their peer dependencies. So what they're basically trying to tell you is, I expect you to have React and React DOM already in your package or project that you are trying to build. So your package will not ship React or React DOM. It will just use the version of React and React DOM from the project that it's being used in. If that makes some sense.
Okay, we have another question. Mocking CSS in Jest configuration, is it helpful for testing styles?
Absolutely. Well, not in Jest. Let's say mocking in Storybook will let you see it in action, but mocking in Jest doesn't really help, because if you mock it, it won't really get applied to uh, your component. So I wouldn't suggest doing that. Yeah, for not for testing, but for developing, it certainly helps.
Cool. So, okay, we have a last question which you already answered on the chat as well, but let's just go through it again here so that everyone has seen it. What to keep in mind when we want minimal bundle size, and which is your preferred bundler?
So to minimize the bundle size, first of all, the most important thing is to have the least number of dependencies as possible, because that's where most of your bundle size comes from. Try to have zero dependencies, but if not, try to minimize the damage and remove as much dead code as possible. Only keep the code that is actually being published and used. So, and rollup helps with things like that. A rollup tries to rollup has things like tree shaking and dead code elimination. So it does help somewhat, but it's primarily upon you to minimize the bundle size. The bundler will not actually help you that much.
Okay. Well, thank you, Daivat. That's all the time we have today. And Daivat is still around in the lounge area, so please, go to him, talk to him, ask him any questions. Thank you, everyone. See you in the next session.
Thanks, Ajay. Thanks, everyone.
Hello, everyone, and welcome to this new session. We now have two speakers with us. We have Sridhar Arumagam and Mintra, and they are here to talk about their front-end framework that they are using at Mintra and how it's helping them to build applications across different platforms. So please give them a round of applause. Sridhar, Arumagam, hi. Hi, Vivek.
Hi Rajat. Hi everyone.
React India.
Hi React India. Good morning. Hope you all are having a wonderful morning. I am Sridhar Armugam. I work at Mitra as a tech lead. Today I am going to talk about the next generation front-end architecture using Layout Engine. These are the today's agenda. First, we will start off with front-end at Mitra and some challenges we faced at Mitra. After which, we will go through the Layout Engine framework and Mitra homepage on the Layout Engine. We will also look at the impact and the way forward for the Layout Engine framework. We have our Myntra application on 4 platforms such as Android, iOS, PW, and desktop. Most of the pages are written in React Native for Android and iOS. And some platform-specific codes are still in native, for example, Share Dialog and QR Code Scanner, etc. And our checkout experience is powered by WebView as it's critical. Our PW is written in React and multiple pages are powered using React Native Web. This helps us bring parity with Android and iOS. Vivek later will be talking about our React Native web journey. Desktop is also written in React. Let's take a look at the challenges we face at Myntra for the above mentioned platform. Maintaining code base becomes more complex as features and team grows. Every page in the application is implemented differently because every page depends on different API contracts and its content composition happen at the client. To create a page, we had to write boilerplate code for common infrastructures like analytics, loader, pagination, page response, and caching, etc. Page performance metrics such as API load time, page load without network, etc. were also not available for all the pages. As the team grows, each team was creating and maintaining different pages, which lead to the re-implementation of common infrastructures in multiple different pages. It became very difficult to enforce standard practices just by code review. Adding new pages or components to an existing page on the fly was not possible without an app release. As India's leading fashion e-commerce platform, we required dynamic support for adding or modifying pages on their content to provide a seasonal and personalized user experience regularly. Complex business logic at client. Feature parity across platform became a problem. Any business logic change had to happen in React Native, Android and iOS and web separately. Every experimental feature build needed to have both A/B test and feature get checked because experiment can conclude at any time and we would still need the flexibility to turn on or turn off the feature without the experiment running. A/B checks happens across the app. Once any experiment is concluded, we have to clean up such checks and do an app release. Code base size and app size kept increasing with every release. Lots of boilerplate code such as loader, network request, page state had to be re-implemented for every page. For sending analytics event, we have to extract all the details needed to construct the payload for each feature. A significant amount of code has to be written for this construction as each feature are having different response structure. Component reuse across pages is slow. Apart from the MDL components, generic UI components, components are not interchangeable across pages because most of the components are written within that page in mind. Dedicated developer for each page. The developer was onboarded to a specific page instead of application. If a developer had to contribute to a different page, certain page fundamentals are required. For example, a developer who handles PDP will take extra time to work on any other page in the application. Analytics are not standardized across pages. Product managers are the one who defines the analytics requirement and the same is implemented by the developer. Like developer, product managers are also dedicated to the page, hence contract of analytics is different. Feature parity across platforms. As each of these platforms is handled by a different team, aligning the timeline would be difficult and requires prioritization of features over other tech improvements. Any feature would take 3x implementation before go live. Mobile, Android and iOS, and mWeb and desktop. There are 4 main pages in an e-commerce app. Home page, product list page, product description page, and checkout page. All of these pages are nothing but a collection of widgets and shared widgets such as banner, carousel, slideshow, product, etc. There is no need of any specific handling at page level. Given the challenges and the user flow of our app, we built a framework which helps us overcome certain challenges and enforce certain principles on our platform. It's called the layout engine. A framework that defines a standard protocol for UI contract between front-end and back-end across features on UI platform. It's a framework on which developers are building features across platform. We have 2 parts to this. Front-end, which contains page broken into multiple widgets. Back-end, which forms this widget from various microservices. To solve various common application use cases in more generic way with lots of benefit, which we will see in the upcoming slides. Server will send the widget response to client and that will be rendered using layout engine. Widget response includes the data required to render the widget. This framework is implemented in React Native, and it supports React Native Web, and it's powering Myntra PWA. This diagram represents a very high-level overview of layout engine framework. User requests for a page, and the application gets a page URI from the link and passes it to the layout engine framework. What is page URI? Page URI uniquely represents a page. For example, Myntra.com/home is represented as a home page, and Myntra.com/Nike is represented as a product list page. Then the layout engine framework makes a network call to a layout engine backend with a page URI. Then the backend identifies the page based on the page URI passed and sends the corresponding widgetized response and the layout details back. Using the layout detail and the widgets returned from the server, the layout engine front-end framework render them on the UI. Why we need layout engine? Standardized API contract between all the client platforms and the backend. All the pages are going to fall under one umbrella, which naturally standardizes things across pages. All the common infrastructure necessary to build a page has been extracted into a framework. Network call, page loader, screen load analytics, error view when the API fails, pagination, page performance metric, API load time, page load without network, etc. Next is no page specific code. App is page agnostic. There is no front-end route mapping defined. Any page will be directly identified by the server, and server decides what page it is and serves the content. The page will not take any responsibility for the widgets, like data sharing between widgets, actions, etc. All those are enforced at the widget level, which improves the developer code reasoning, thinking into widget rather than polluting the page. Server controls page layout, navigational action, business logic, analytics, A/B test, feature gate, etc. Business gets complete control on the page content without app release with the existing widgets or page functionalities. Adding or removing widgets on the fly, changing page layout on the fly, changing widget actions on the fly. There is no special handling required for older version of the app once the A/B test experiment is concluded. Offloading business logic to the server makes the client more bug-free, lighter, and predictable. Increase the widget usability across pages by sending different analytics and click actions based on the page requirement. Reduce developer efforts to roll out new feature or page across platform. Onboarding developer become application instead of specific page because now it's one rule to follow. No time to spend in solving common infrastructures. Just focus on your features. Reduce the size of the code and maintainability over time. Eliminates boilerplate code on creating page, analytics functions, state management, paginations, loader, response caching, etc. This diagram represents the overall front-end and back-end architecture. Starting from the layer 6, which is the Myntra application layer, the first component is layout engine page. This implements the common page infrastructure and integrates the layout engine framework. What does this common page infrastructure contain? Extracting the page URI from the page route, page load status, pagination, action handler and analytics handler, etc. This also integrates with the layout engine core and then layout engine renderer. We will discuss this when we look at the layer 5. React navigation. At Myntra, we use React navigation library for the routing. Analytics handler. The application implements the analytics handler to handle widget actions that are driven by server. Navigational actions. Analytics handler. The application implements the analytics handler to handle the widgets, click and impression events. Layout engine framework contract is not enforcing any structure for actions and analytics, since it's all part of the widgets property, where widgets are completely owned by the application. Network and storage implementation. The application can choose to use its own network and storage layer based on its need. The implementation will be passed to the layout engine core. That layout engine core will use to make network call and then storage purpose of the page response. Redux. For application state management, the application can use other state management solutions also. There is no enforcement from the framework. Myntra application widget library. These are the application specific layout engine widgets, which are entirely written by the application. The layout engine renderer will resolve those widgets based on the widget type. And the layer 5, which is front-end framework. Layout engine core. This module is responsible for storage interface. Will be passed by the application where layout engine core can store or retrieve the page response. Network layer interface will be passed by the application where layout engine core will make API calls to get the page response. Pagination. Merge the pagination page response into main page response and update them in the cache. Caching strategy. Checks for the page freshness. If the page response freshness is expired, returns from the network, otherwise from the cache. Delta merging. To optimize the subsequent network bandwidth, if the widget data does not change, then the server will not send the entire widget data. Instead, just send the widget placeholder, where these placeholders are replaced with actual widget data from the cache. LRU caching. Cleaning the page response stored over time to free up memory usage on the user device. Layout engine renderer. This module is responsible for grid layout. Support linear and staggered grid layout out of the box. Page level widgets. Widgets that are rendering as a page header and footer. Widgets that are rendered as a page content other than header and footer. Layout param resolver. Server-driven style properties such as background, span, margin, padding, border, which will get applied to the widget. Widget container, logical grouping of widgets to achieve a more complex page layout. These layer 5 and 6 are implemented in React Native and can be used on web via React Native Web. And the layer 4, user token management to authenticate the user request. And the layer 3, which is layout engine framework backend, the component page and layout identification. It identifies what type of page based on the page URI passed from the front end and various rules and conditions. For example, serve different layout for product list page based on the article type. If the article type is beauty personal care product, then we'll go with the single product widget in a row. Otherwise, 2 product widget in a row. Based on these rules, it fetches a list of widgets configured for a specific match. The next component is scatter gather. It goes over the list of widget and its configured data provider at the time of page configuration and calls downstream service via service proxy to get the data for the widgets. Service proxy will be implemented by the Myntra application backend based on the widget and downstream service. Componentization. Once scatter gather gets all the raw widgets data from downstream service, then using transformation layer massages the data to widget response using the widget model. The transformation and the widget model are implemented by the application layer for each widget type. Any modification or addition of widgets will record code changes in all the components of layer 2. The layout engine framework can be used by any other application by replacing other layer except L5 and L3. Layer 6 and 5 can be replaced by any other UI platforms and frameworks. We can re-implement the layer 6 and 5 in Flutter without modifying any other layer because our API contract is platform and framework agnostic. This diagram represents the flow of layout engine page load from front end to back end. Step 0, request for a page. And step 1, get the page URI sent by the client. Step 2, based on the page URI, it identifies the page and its widgets configured from the page service. Page service contains the page configuration for the page URI, which is configured by the product manager via the admin panel. Step 3, calls data provider for each configured widget in that page for the data. Step 4, data provider then calls corresponding downstream service via service proxy. Step 5, downstream service returns the actual data. Step 6 and 7, then transformers massages the raw data into widget model. Step 8 and 9, once got all the widget response, then page handler adds other page level contract and return the widgetized response back to the front end. The widget schema repo is the one store all the widget model, which will be in sync with the Myntra frontend and the backend application. Myntra homepage on the layout engine. Myntra's most critical and dynamic page, serving personalized user experience for over 10 million users. This is our homepage on all 3 platforms, iOS, Android, and PWA. All these 3 platforms are same React Native code base. Using React Native Web, we are rendering in the web. Layout engine impacts. Increase widget reuse across pages. All the layout engine widgets are not only created just by keeping the specific page in mind. So it's reusable across pages. We have widget collections for Myntra app. Those widget collections are the one used across teams. Starting from, UX team will share mock for the new feature by referring to the widget collections, and they are the one who adds a new widgets to the widget collection. Developer will implement those widgets and add it to the widget collection repo. All this increase the widget reusability across pages. Standardized developer process to introduce a new feature on any page. One standard principle followed by all the developer. Developers keep improving the framework instead of just a feature. No need to re-implement the same common infrastructure every time. Any new use case will be solved in any new use case will be solved in a generic way by the framework. As an onboarding more pages to layout engine framework, we are solving more use cases in a generic way. Eventually, our framework will be more matured. It works great with the pod team structure. Now, any number of independent team can be contribute to the same repo because now they need to follow single principle defined by the layout engine framework. Today, we have multiple teams spread across different verticals, such as category experience, search, merchandise, and monetization, checkout experience, etc. All of us today follow this single principle on most feature we build. We have noticed that this has started helping us immersively. We started to see better reusability of code, less code coupling with specific feature, and better developer experience, easy to contribute outside of the pod. Feature parity between native apps. As I mentioned earlier, our Android and iOS platforms are written in React Native. All our UI platforms are in JavaScript. So UI developer now develop any features on all three platforms in the same timeline. Now the way forward for layout engine. Migrating more Myntra's critical pages to layout engine, product list page, product description page, etc. Our framework is getting mature use case by use case. So migrating more pages to layout engine will help improve the framework. Building a DSL to further reduce JSON deserialization time. Our layout engine page response is higher compared to normal API response because server sends analytics, action, layout params, etc. Admin panel to dynamically configure the pages by drag and drop the widgets and enable full stack development and bring desktop into the layout engine and seamless developer experience when building for multi-platforms. And finally, open source the entire UI platform. Thanks for listening. We at Myntra hope that we helped all of you take something back to your team from this talk. We will really be happy to hear your inputs or ideas to grow this framework. And this is our layout engine core team. Then next, Vivek will be talking about React Native Web and SSR. Thank you all.
Thanks, Sridhar. Hi, everyone. It's really nice to be here at React India. I am Vivek Soni, working as UI Tech Lead at Myntra, having 7 years of experience in web development. Back then, when I started my career, server-side rendered web pages using JSP, PHP, WordPress was the manifest. They were the obvious and default thing. And WebView was the only cross-platform option for platforms like web and mobile apps. But now things are evolved. We have traveled from SSR to CSR and back to SSR again in good way. We have decent options to choose from in case of cross-platform UI development like Flutter and React Native. And so in this talk, I'm gonna talk about how we at Myntra transition to write once, run anywhere model for our multi-platform user interfaces like Android app, iOS app, and mobile web. So let me share the agenda of today's talk. So I will be discussing first the previous state of UI at Myntra and the challenges we face while developing the UI with the existing solutions, and then I will be talking about journey towards React Native for web migration, and we'll be talking about SSR server-side rendering and challenges we face during RNW migration and server-side rendering of RNW rendered components. And after that, I will be showcasing the performance and benchmarking of React Native for web rendered pages and server-side rendered pages. So let's start with the previous state of UI at Myntra. So at Myntra we have mobile apps and we have web apps. And for mobile apps, like most of the screens and UI logic is written as React Native component and as JavaScript functions. And this React Native code base is then further imported into Android Native and iOS Native. So Android Native and iOS Native have like some native functionalities implemented as bridges, like for making API call, for displaying the images, and for like dealing with the storage and this sort of stuff. So that is there in as native code. But most of the like UI logic and screens, the business logic is written in React Native code base, and that is shared across iOS and Android Native. So for web it is again different. Like for mobile web we again have the implementation of screens and UI logic again in React DOM code base. And for desktop also we again have a different code base for screens and UI logic written in React DOM code. And there are some things shared across these both the code bases, like UI components and like components and common libraries. So those things are shared across these code base, but it's still like 80% of the code is different for MWeb and DWeb. And this is the like current previous state of Myntra UI. And the problem here is like whenever we have to implement any feature, we have to like write code again in React Native code base, and again for MWeb code base, and then again on desktop code base. So and like for MWeb and React Native, the UI looks exactly the same, and functionality also is always, most of the time it is always same. So but we end up implementing it like twice, and there are like sometime there are bandwidth issue, and the MWeb ends up like not having that feature, and there are like feature priority between MWeb and mobile apps. So there were lots of issues happening around because of having this multiple code base for same sort of UI. So to get rid of the challenges, we decided to explore React Native for Web. React Native for Web is developed by Nicholas, and it uses React DOM API to render React Native component in web browser. So basically React Native for Web provides the implementation of React Native components like view and text and other React Native components. It provides like a web portable React DOM component definition for those components. And React Native for Web supports like modern React API, like including hooks. And React Native for Web was like it's widely used in production by Twitter and Flipkart and Uber also. So it was proven, and like that's why we thought of giving it a shot. And React Native for Web also supports server-side rendering, so that's also a big plus. And it supports Preact also in case like if you have lighter pages where you want to have lighter assets, so you can use Preact instead of React DOM, and React Native for Web rendered component will work just fine. So as I explained earlier, like we had React Native code base which was used by iOS and Android apps. So we wanted to utilize the same code base for MWeb also, and we wanted to provide like network level bridges and storage level bridges for that. And so we ultimately wanted to use the same code base because the UI user interface was the same for apps and mobile web also. So for that, like we took help of React Native Web, and React Native for Web provided the implementation of React Native components, and we were able to port those components into MWeb React DOM rendered web pages. So React Native for Web helped in like porting those components, porting React Native code base, and it also provided a style resolver where like so whatever styles we have written in React Native components, inline styles, object styles, so React Native for web also convert them into CSS and make them work fine in web browsers. And React Native for web also take care of the interactions like responder and click and focus. So it take care of all these API, and these API will just work just fine on web browser also. So that's how like React Native for web help us in porting React Native code base to web browsers. And to discuss in more details, we have this high level diagram where you can see like we have this MWeb code base which is written in React DOM, and we have this React Native code base. So we wanted to have the incremental migration. So we wanted to have some of the screens in React DOM, and we wanted to have some of the screens from React Native code base. So that's why we are keeping both the routers. We are using React router also in React DOM in MWeb code base, and we are using React navigation in React Native code base. So like whatever screens we are there in React DOM code base will be served from React DOM code base only, and the screens which are to be served from React Native, we will be like identifying them here in React router, and then we will be like making API call for data fetch and all, and module injection, and then we will be redirecting them to not redirecting, like we will be like passing them to React navigation rep components, and then React navigation will decide based on the route like whether to render home page or studio page or Myntra mall page. And to support all this like React Native code base, we had to do some webpack config changes like React Native to React Native aliasing and some custom aliasing, like so some of the React Native components or some of the modules were not supported by React Native web, and we had to make some fake components or dummy components. So for that, like we had to have these custom alias and then we had to have .web extension priority, like for there were some component like which were not working in web, or which we wanted to make work differently in web. So for that we were having like .web extension, so that when we are building it for MWeb, we will be picking .web file first, and if .web file is not present, then it will fall back to .js or like simple file. So there were some like extension priority list is there. So it is first web, and then Android, and then iOS, and then .js, plain .js. So like that it was. And coming to the bundle size comparison, so we divided these bundles into two categories, like one is vendor and one is app. So vendor has like all the like libraries and third-party libraries like React DOM, and if we are using any slider library or anything, so that will fall into vendor category. And app category, app has all the code which we have written, like the custom app code and business logic and UI logic, so that sort of thing. So vendor, as you can see, like the vendor and app, both the code base has gone up by twofold, at least 2 or 3-fold. And because like we are maintaining like both the routers for React DOM and React navigation, and there are like some boilerplate code which needs to be initiated for like old React DOM, and there is some boilerplate code which needs to be there for React Native app also. So that's why the JS size has gone up. And so because of that increase in bundle size, there was a hit on Lighthouse score. So as you can see, this is the Lighthouse score benchmarking which we have here. So here, like overall performance score was gone down by 1 point, and you can see that LCP is gone up by one or 2 second, and other things are almost same, but LCP took a lot of it. And so that's why we decided to go for server-side rendering, to like to have this lighthouse score in previous state or in improved state. So for server-side rendering, so React Native for web by default supports server-side rendering, and we were able to decrease the largest contentful pen time by 50% because of server-side rendering, and there is like enhanced user experience in lower segment of mobiles, where when for the people who are on limited CPU mobiles and they are on slow 3G or this sort of network speed. So for those users, they seen better user experience. So let me play the video of both the client side rendered and server side rendered pages. So yeah, so let it play. So as you can see, like in CSR, it was displaying the loader first, and then it was fetching the assets meanwhile, and then it started displaying the pages. But for SSR, it got the full the layout of first fold HTML from server itself. So it started displaying the layout itself instead of displaying loader. So it was a very good user experience, and user was able to see some details instead of just seeing the loader, and it increased the LCP, it decreased the LCP time, and after that the lighthouse score has been gone up by 20 points, and the LCP time has been gone down by more than more than 50%. So now coming to the challenges we faced during the migration of React Native Web, there are some library in React Native which are not yet supported in React Native Web, and there are chances there are some of the library you might be using in React Native which won't work in React Native for Web. And in React Native for Web, media query is still not supported. Like there is no way you can target screen sizes and other than JavaScript tags. So media query support is not there. So you may have to use JavaScript logic if you want to support multiple screens. And the image component of React Native Web is bit outdated. It won't have support of SSR. It supports SSR, but it's not that SSR friendly, and you may end up using some other image component provided by some other writer. So that happens with us also, and we had to write a lot of Babel plugins and Webpack configs to make it work with our existing React DOM code base. So yeah, these were some of the challenges I could remember as of now. Yeah, so that's it from my side. Thank you for listening, and if you guys are looking for opportunity in tech, there are lots of opportunity open in Myntra. Please visit careers.myntra.com, and you can find me on Twitter under Vivex_JS Thanks for listening. Feel free to pose the question if you have any doubt or any question. I would be happy to answer those. Yeah, that's it. Bye bye.
Thank you, Sridhar and Vivek. That was a really great talk. So we have a few questions here, and we have the time for it also. So, okay. So our first question is: have you used Expo for React Native in Myntra?
Yeah. So currently we are not using it. Yeah, but actually, to our current state, right? As each developer has started using, contributing to all three platforms. So we are also wanted to improve our developer experience. So
Okay.
maybe we might explore in future, but as of now, no.
Yeah,
Okay.
but as of now, the thing like we haven't considered it like there are like app side issue with Expo. Like it comes with some boilerplate, and we want to keep our app side lean, and we want like full control over it. But Expo gives lots of boilerplate code, and there are like lots of magic happening, and it has limited like some certain force things like we have to like on notification service. I don't know like it's still there or not, but regarding push notification service and all, so that's why we have avoided it as of now. But yeah, we can explore. We are planning to explore, and we'll see like if that fits our use cases.
Okay. I guess that answers the next question as well. Yeah, that
Mhm.
whether you find it worth as per the current state of Expo,
Yeah.
right? So
Right.
apart from that, okay, one last question is how much time does it usually take you to create a new page, including layouts and widgets with your new
Okay.
framework?
Okay. Yeah. So as I mentioned right in the talk, basically this framework is just getting basically getting matured use case by use case. So currently we are successfully migrated our homepage. So yeah. So basically two parts to look into it. Like let's say whatever the page or feature that you are want to create, that if all of this already existing in the layout engine, basically the widgets, all the layout support, all the features which is required for the feature, which is already available as part of the layout engine framework, and it's solved, where it is just matter of just configuring it from the backend, configure it from the backend. Otherwise, you just need to develop these things like no widget, whatever things needed for your particular page or feature to. So, but it is comparatively very less if you compare to very normal way of non-layout way of developing the page. Because non-layout way of developing page, you need to write lots of boilerplate to
Yeah.
address few common infrastructures. Like no, all those things is going to be cut down here. So yeah, hope
Okay.
that answers.
Cool. So that's all the time we have for Q&As. Sridhar and Vivek will be available in the lounge area if you have any more questions or if you just want to talk with them. And I would like to, just mention our sponsors real quick. Our gold sponsors like Antstack, Gupshup, and Lab 49, Saloon, and Native Base. They have helped us a lot, and we really, really thank them for providing us the support to have this conference. So, guys, thank you everyone for showing up, and I'll see you in the next session. Hello and welcome. We have Ragul Nagendran here with us. He's an associate software developer at Condé Nast. Ragul is a very great, front-end developer, back-end developer, and even a data engineer. He does a lot of great things with data visualizations, and that is what he is here to, share with us how to create performant data visualizations. Apart from coding, Rahul is also a big anime fan. He really loves Attack on Titans. Yeah. So that's all. Rahul, so we can
Yep.
get
Yeah.
started.
Let's get started.
India.
Hello everyone. So my name is Rahul, and in this talk we will decode how we brought the initial load time of one of our data visualization components from 28 seconds to around 1 second. Impressive, right? But first, a little bit about myself. So I'm a software engineer at Condé Nast, and I've been working at Condé Nast for nearly 2 years now. Condé Nast, for those of you who might not know, is a publishing company with a global presence that houses many cool brands like Vogue, New Yorker, GQ, Wired, and so on. Our team, which is the data visualization team, gets to work with all these brands and develop super cool and engaging data visualization and web experiences for them. And to build these uber cool visualizations, we make use of React and D3. D3, for those of you who might not know, is a library that helps us build data visualization with a fine grained control. So, moving back to the topic, our case study. So our team has brought many cool visualizations to life. One of them being our internal year-end storytelling visualization. So one of the components that actually went into that was the deep look section that you're currently looking at. So it's a custom cluster chart which has a large number of data points to be displayed. We will be going through the major versions of this component, how we build the version, the metrics, what were the performance issues that came up in each version, and how we address them in the next version. Some key things to note before we go into the case study. So if you have no knowledge about D3, it's completely fine. You don't need any knowledge of D3 to follow along this talk. And one more thing to note was to pinpoint the issue in the each version, we debugged the app in each version using React DevTools and Chrome DevTools. To make sure it's easier to follow along in this talk, only the performance metrics from the Lighthouse tests have been included in the slide so that it's easier to follow along for the rest of you. So about the case study. So our goal was to build a cluster chart that animates between three views, as you saw in the previous slide, category 1, 2, and 3. So the viz would contain circles, which would either group itself in clusters or position itself as a line chart, depending on the view it is in. When switching between these three views, the circle should animate gracefully between the positions. We would be rendering the visualization using SVG with the help of D3 to figure out the position and size of the circles. So let's start off with the version 1. So the version 1 of our component was the very first iteration of what a component would look like with the data. Main goal here was to find out how with the like for the case, we enable the set deep look component alone, and as you can see in the demo, now you can see that we've started loading the website, but it's still loading. As you can see the video controls down here, and we are like 10 seconds in and the viz is still not rendered, but just the category 1, 2, 3 have been rendered, and it's still going. And yeah, so as you can see, the website, the component actually takes a really long time to load. So under the hood, this is what it looks like. So we have a viz component that has like 3 categories as an individual component, which gets conditionally rendered using the chart type that we set using these buttons. Each viz that we show, this is what it looks like. So you can see here it's a functional component, and then a lot of data processing is being done on the body of the functional component, and nothing to go inside, but then the nodes is the data that we are looking for. So it has all the circle properties and the values that we need to render it. So we'll be using that to render it using React. So moving on to the metrics. So we'll be talking about 2 metrics for each version. So the first one is the first contentful paint, which is also known as FCP, which is a measure of when the browser starts to render the website on the browser. Second is time to interactive, which is a measure of how much time it takes for the website to become fully interactive. That is, the user can start interacting with the website. For a version 1, if you see, FCP was around 7.5 seconds and the TTI was around 15.2 seconds, which is definitely not good for any website. So why did this happen? To start off, the bottlenecks and issues. So since this was just to explore the data, the three views, that is the category 1, 2, and 3, were structured into separate components. So when switching between the components and views, we actually switched the components, but we needed to animate the circles between the views. So we needed to bring them together in the next version. That was the first issue that we noticed. Second one was, it was a really huge data set and it was unfiltered. So we had about like 25,000 data points, which means we also had like 25,000 nodes to be rendered on the DOM. Rendering such huge number of nodes would not be good for browser on any medium or low end devices, and even in some high end devices it might cause some issues, because our goal was to animate the circles between the views, and animating them is much harder with those many nodes. Third one we noticed was, so a little look into the React dev tools told us like each of the three components were re-rendering and recalculating the data a lot of times unnecessarily. What is the culprit? So the code that calculated the position for the circles was doing its calculations on the body of the functional component that we saw, the component 1, 2, and 3. So the fact that the computations were actually a bit time consuming was not also helping. So that was where the major issue was. Fourth point that we noticed was like switching between the views also takes a long time, because when we switch to a new view, that is like, let's say category 2 also does similar categorizations that category 1 did. So hence the delay. So now we knew what we had to do. We go into the version 2. The main goal of this version was to build an interactable visualization that overcomes the issues and bottlenecks of the previous version. So what we did in this version was, first we addressed the animation issue that might come up. So we merged all three views into a single component called deep look. So and then the second thing that we did was we split the data, that is 25,000 nodes, data points based on months, and put that up as a filter. This greatly reduced the number of circles from like 25,000 to approximately 2,000 per month. Third thing we did was we wrapped all the computation inside functions and called them only inside UseFX, so that recalculations will decrease. We also stored the data in states using useState, used a lazy state initialization for better initial load. And then the fourth thing we did was we calculated all three views, the data for all three views were calculated inside the deep look component itself. So the switching was instant. We also got started on animation by animating the properties of X, Y, and opacity of the circle element using CSS transitions. And this gave us load with like 3 views and 1 month filter. So keep track of the video's timestamp to understand how long it takes to load the page. I'll be keeping moving the mouse so that the control is loading. We wait. Now I try to load, let's say I try to load February's data, and we have to wait for a while. And we have the February data loaded now. And now the transitions are working as expected. So what did this give us? So this gave us this, just a second. So numbers wise, it looks like this. So the FCP is around 11.3 seconds and the DTI is around 18.2 seconds. What? How did it get worse? Actually, what happened was it was actually expected. In the earlier version, we computed the position and did the processing for one view alone in one component. But here, we were doing the calculations for all three views in a single component, and hence the increase in FCP and TTI. Because of this delay caused by the computation, it would take around like 5 to 10 seconds every time we switch between the months, which was not a good user experience. Because for a given month, it would calculate the positions for all three views in one go. When the month changes, it actually recalculates the position for all 3 views for that particular month and then renders it. Another thing that we noticed was the third point. So we were actually using a really simple transition all to animate the circles. Somehow the animation would be slow in some low-end devices and mobile devices, and in some the animation was really choppy. Animating 2000 nodes on a resource demanding website might be part of the problem, but then it needed more inspection. So knowing what to optimize, we went on to the next version 3. So the goal of version 3 was to come out with a good end product that closely resembles an MVP, sort of. So what we did in this version was, firstly, we looked into the data and took a decision to remove months filter and just showed top 1000 data points for the whole visualization. This decision was made because of 2 major points. One, this was not a dashboard, so it just made more sense from a data visualization aspect to let the users explore top end data points alone with peace. Second point, this also helped us boost the performance of the app. Animating just 1000 nodes instead of more than 2000 nodes was definitely helpful in decreasing the load on the browser. Second point, in version 2, so each time the user positions for the circles and used to switch from, let's say, January to February and then back to January, we would still be calculating the position for 3 views again. Like, we see that the January has happened twice, but then we should be calculating it only once, right? So in this version, the data for all 3 views are computed once and memoized using use memo. So when the user actually switches from category 1 to category 2 and then back to category 1, there will be no computation performed. So you can see here, all the first 3 categories are memoized, and then we just use a single data and just change it when the chart type changes. Third point, before we dive into why the animation was slow and janky in the last version, let us have a quick overview of how browsers actually renders any website. So the browser rendering pipeline. So to display a website, the browser does the following steps: style, layout, paint, and then compose it. These are the 4 steps it follows. So if you look at style, the browser calculates which styles to apply to which elements. The layout step involves the browser calculating where each element goes and how much space it occupies. The paint step involves the browser filling out the pixels on the screen with colors, borders, images, etc. across many layers. And then for the composite step, the browser gets the layers from the paint step, combines them into one layer, and then draws them onto the screen. This is called the browser's rendering pipeline. So each CSS property goes through these steps to get displayed as what we see on the browser as a website. But then not all properties go through all steps. So let us take an example. Let's consider width, CSS property, that is width. So width changes the space of an element it occupies. So it affects the layout of a website, which is step 2, which makes the browser recalculate paint and composite steps, which are step 3 and 4. So 2, 3, and 4 step gets recalculated. So if we animate width, browser has to recalculate 2, 3, 4. That is 3 steps it has to recalculate. Consider opacity, which is also a CSS property. So when we apply opacity to an element, the browser actually creates a separate layer for that element. So when we animate opacity, only the composite step gets triggered because only that layer will get affected, and hence the 4th layer alone needs to be recalculated. Which means animating opacity is actually less work for the browser than animating width. So we found out that transform is also another similar property that only affects the composite step. So we actually refactored our entire animation to work only on transitions of opacity and transform. So you can have a look here. We do the we set the transform translate using x and y coordinates, and then we set the opacity, and then those alone get transitioned using the transition property. Another thing to note was we looked into JavaScript library animations like React Spring, but then realized that we were already doing some heavy duty calculation on the main JavaScript thread and did not want it to overload with JS animation. Since CSS animations are handled on a separate thread by the browser, it was the best option. So how did this look? So here we go. We've started loading the component. So it's somewhat here, and then right off the bat, you can see that we didn't have to wait as long as we had to in version 1. And we can also see that this super smooth animation of the circles when we switch the view. So yes, numbers wise, it looks like this. FCP is 8.3 seconds and TTI is 9.3 seconds. From 20 plus seconds to under 10 seconds is really nice boost, but then it's nearly not nice enough for a good user experience. A bit more digging into the dev tools and we got this. Very obviously, the main issue was still the time it was taking for the initial data calculations for the 3 views, like the category 1, 2, and 3. Those are still the most time consuming calculations that need to be looked into. Second part, so this was one of the many components that was going to be up in our website. So it comes up as the penultimate section, but then we most definitely can't have this section alone clogging up the main JavaScript thread for 10 seconds because it would make the website unusable for the first 10 seconds, which is not a good user experience. So once again, we knew what we needed to do to optimize it. We just needed to find out how. Moving on to version 4, it was time to bring out the magic sauce. Before I talk about what we did, here's a look at the metrics. First content to FCP is around 0.8 seconds and TTI is under around approximately 2 seconds. The user sees the content in under 1 second and the user can interact with the website in under 2 seconds. You must be wondering, oh, seriously? Well, let me just show it to you instead of telling you. So here's the demo. So you start loading the website right here and instantly you can see the categories and the labels appearing, and then a few seconds later the circles animate. And clicking on each view changes the dots respectively, and we have a really good component at our hand. But how did we achieve this? So yeah, starting off with the most easiest part. So we removed unused code, data files, and reduced the image sizes using compression techniques. And then we also broke down our package.json, removed the unwanted dependencies, and reduced the overall bundle size. So a lot of tree shaking and the standard stuff. That was one. And then second one was as you might have figured out, our major problem was that we were calculating the data for the 3 views in a sequential manner in the main JavaScript thread, which was blocking the rendering of our web page. To solve that, we would have to render initial dummy circles, perform recalculation somewhere else other than the main thread, get the data, and use it to render the updated positions. That's where web workers come in. So web workers are actually a simple means for websites to run scripts in the background threads. The way it works is you create a new worker thread, perform your calculations there in that thread, get the data, and pass it on to the main thread. And then the main thread uses it to render the data. So in code, like how it looks is to spawn like 3 worker threads for our 3 views calculation, like data calculation for the 3 views, we made use of a package called Workerize Loader. So what it does is you create a worker instance here, and then you pass the data to that worker thread, and then let it compute, and then add an event listener to that worker thread, get the data back from the worker thread, and then set it as a state, and then use it to render your component. So this was one, and then the second major optimization that we did was lazy loading the deep look component. So deep look component was one of the last sections on the website, as I told you. So it didn't actually make sense for it to load at first along with the rest of the website. So yeah, when the website loads, you actually just need to show the header section to the user, and maybe the first section to the user, and the remaining sections can like slowly load in the background. This would reduce the initial bundle size that the user would load, which would ultimately result in faster load times for the user. So this was made possible by splitting the code using lazy loading and suspense, which are the features of React. So how this works is, in our app, as you can see in the first image, you can see that the browser is making a request for two big chunk files, main.chunk.js and 0.chunk.js, which take about like 50 milliseconds each to get served on a local host on a fast internet speed. In the second image, you can actually see that after we've split up the code for the deep look is actually located in 1.chunk.js. So as you can see, the time here, main.chunk.js takes 17 ms, and then 0.chunk.js takes 29 ms. But then the deep look, it gets like called after a while, and then it takes separately 37 milliseconds, which happens in the background. So in real-time scenario, when the project is deployed on the internet, it would like make a huge impact. It also helps us display content faster in devices that are connected to slower networks. Implementation wise is pretty simple. So there are two parts to this setup. One is the lazy that we import from React, and the other one is the suspense component that we also import from React. So React.lazy helps us separate certain components into separate chunks during build time. It's a simple import that it gets a simple function that has to have a default import. Second component is a suspense component. So we wrap our lazily loaded components inside suspense. The suspense components helps us show some fallback content also while we wait for the lazy component to load. So one thing that can definitely happen in this setup is the browser might request for the main chunk, but before loading the 1.chunk.js, that is the deep look component, there might be some network issues and it might break our app. So to prevent that, we brought in error boundary to handle such scenarios so that we have a graceful fallback for when such errors happen. So this was the version that went live and worked very nicely with other components of the website. All these optimizations are fine, but was there something that we could have done more beyond version 4? So what about Canvas API? So yeah, what if using Canvas API will drastically maybe decrease the number of DOM nodes that we have rendered on the website, but then we would also have to rely on JavaScript to make the circles animate. So I'm not sure. So that is one part that can be and should be explored further. So what have we learned? To sum it up, so to reduce wasted re-renders and avoid unnecessary recalculations is the first step into optimize any React app. And then if you want really high performance CSS animations, then animate only transform and opacity. One major thing that you should not do is you should not block the main JavaScript thread by super heavy computational functions or stuff like that. Use web workers if you have anything like that. And then lazily load components that aren't immediately required by the user so that the user has better user experience in loading the website. But also remember this. So do not prematurely optimize your React app. So get your website up and running, run tests on it, find out bottlenecks, and then fix them. Fixing problems even before they come up has always given rise to more problems. So never prematurely optimize. Second thing is there is one major thing to keep in mind. So use memo, React memo, or optimization, stuff like that are not the solution to every slow React app. So there is no universal solution for performance issues in general. So each project is unique on its own. So you have to run, test, analyze, find the bottlenecks, and then fix them. have a look at like Brooks, who managed to bring his app render time from like 13.4 ms to 3.6 ms by just restructuring his code and doing nothing of the sorts of like memoizing or something like that. So just restructuring will give you such a huge performance boost. So that's definitely the debugging part and the analyzing part that helped him achieve this. So go through that, do that first, and then start optimizing. So yeah, and that's it. I hope this talk helped you get a deeper look into what goes into optimizing in React App. See you all at the question and answers.
Okay, so we have just enough time for just one Q&A. So let's go with why do we require workerize loader?
So when you are using React, you can't use worker threads like you normally do in a JavaScript project. So Workerize Loader helps us. It's just a package that helps you like easily get the worker threads started and get the job done. Into it and are more.
So thank you, Rahul. Really great talk, and I really enjoyed that. I also come from a data visualization background, so I'll definitely try what you have shared here. Guys, everyone, please reach out to Rahul at the lounge area for any more questions you might have. And Rahul, I'll see you around. Thank you so much. Thank you, everyone. See you in the next session, which is a panel discussion.
See you all. Bye.
Hello, everyone, and welcome to this panel discussion on how to build your ideal stack. We have some great panel members here with us. So let me just introduce them. We have Pratik Bhatnagar, Siddharth Chatterjee, Kashyap Kondamani, and Darpan Kakadia. Hi, everyone.
Hey, everyone.
Hey.
This
So
is
I'm
Pratik
going.
Bhatnagar.
Yeah,
Sorry, go ahead.
I'm going to get off the stage, and you guys can carry on.
Awesome. Great. Hey, everyone. This is Pratik Bhatnagar. I am an engineer at Uber, and I'll be your host for this panel discussion. I have some great friends with me. Let me introduce them one by one, and I'll give them a chance to introduce themselves. Starting with Darpan. Darpan Kakadia is a staff software engineer at Scalable.
Hey,
Hi,
Pratik.
Darpan.
Yeah, nice to be here, everyone.
Then we have Kashyam Kondamudi. They are a software engineer at Flipkart, working on all the front-end, fancy front-end stuff, as I hear from others. And then we have the new Sid, the Sid for 2022, Siddharth Chatterjee, who's a staff software engineer at Gatsby. Hey. Okay. All right. Do you guys want to take one-liners about yourself, what you do?
Sure.
You want to start,
I can.
Darpan?
Yeah, sure. Like Pratik said, I work at Scalable, and my day-to-day job is making sure that the broker platform that we have for trading is up and running every day. And yeah, I basically look after the whole front end and the engineers in the team and mentor them. And yeah, that's it. Apart from that, I talk about photography and coffee.
Awesome. Okay. Next, Siddharth, do you want to talk about yourself briefly? Hey, Sid, can you hear us? Okay.
I don't think he can hear you
Sure.
specifically.
Yeah, I can hear Kashyap and Darpan just fine. For some reason, I can't hear you, Pratik.
Very weird.
Okay.
Do you want to try muting and turning back on, maybe?
Hey, can you hear me now? No. Wow.
I can see your lips move, but I can't hear what you're saying.
Okay, let's give Kashyap a chance, and meanwhile, I'll just quickly reload, switch off, and switch on.
Sure. Hey everyone. So my name is Kashyap. I work in Flipkart as kind of a platform plus web engineer. It's kind of a mixed bag these days. So yeah, that's about it, pretty much. And I think Sid, so this is basically intros going on. So Sid, maybe you can go next.
Sounds good. Great. My name is Sid. I work at Gatsby as a staff software engineer. Been here for a while now. And yeah, I'm excited to talk to all of you. And hopefully I can hear Pratik. There you go. I hear you.
Awesome. Yes. Great.
Good.
Okay.
Great.
So for everyone who's listening, this panel discussion is about building your ideal tech, or at least getting knowledge how people are building their own stack at big companies in open source frameworks, in open source space. And so the way that we are going to go around around this particular discussion is that I have a bunch of questions, and I would love to hear aspects from all of you, because you come from very diverse background: e-commerce, finance, and then obviously open source, which is all horizontal and there's no specific to it. So let me start. My first question is that a lot of companies, like I've been to at least 4 or 5 companies in my employment, so I can say that a bunch of companies start and thrive with open source solutions. Like I've seen a bunch of so-called unicorns now, to start with Next.js, to start with Gatsby, and whatever was their Angular CLI at that point in time. But then they grow up and they someday mature to build their own stack. They someday eject themselves, or they someday decide that, hey, we should be having a platform team, or we should be building our own stack. So what are like some of the factors that you guys have seen that basically leads to this discussion? Like why can't we just use Gatsby or Next forever? Darpan or Kashyap, do you want to start?
Yep, sure. So at Scalable as well, we have our own platform, which is built on top of Next.js. And initially, when we started, it was just Next.js. We did not build a platform out of it because, we did not want to invest. We did not know if we needed that. And initially, in those days, we had a monolith front end, so everything was in one place. So we did not need a platform team or a platform specifically for ourselves. But then we started making micro frontends out of it. So sign-up process is a whole separate application, and then we have 2 sub-applications after the user signs up. And all of them are different repositories. So that means that we would need the same things across all of the applications. And not having a platform means that you do the same thing everywhere and kind of repeat yourself. And that's a nightmare, because if you have to update things, it becomes a huge overhead. And that's why we kind of decided to build a platform, because it's not just Next.js that we use. We use Material UI, we use React, we use Apollo, not React, but Apollo. So integrating all of that and creating a wrapper out of it so that we can update it simultaneously at all the places. So that's my take on it.
Right. So that feels like more of a organic growth from having an open source or whatever is in the market, available in the market, and then maturing yourself out of growing on top of it. Is that correct?
Yeah, that's correct.
Kashyap, do you want to take this one as well?
Yeah, I think our decisions also have been pretty much similar to what Darpan mentioned. We've started off like long back in React. I think, it's sort of that was the period where like React was getting famous, and we implemented the M-site and desktop, redesigns and rework or whatever re-architecture. On top of that, and it slowly started. It still is the same code base to a certain extent, and the way that they evolved is kind of, we went from a place where we were choosing like what libraries we want to use to a point where we are thinking about or requiring or needing to be building tools to support all of that infra. Be it simple Babel scripts, build tooling, Webpack Webpack plugins, and things that do like very specific optimizations for that specific use case. And we still a long way to go with all of that. And I think if a lot of people here might have been there yesterday also, and a couple of our team members talked about how we are kind of using the same code base across all the mobile devices, Android, iOS, and web, which means that most of that frontier, it's kind of a very new frontier to a certain extent. And to make it optimal, we are kind of running into speed breakers everywhere. And to get over that, we have to build a lot of tooling, and there is no escape there. So I think like if you have the ability to start today, I think a lot of these things would change. Right now the ecosystem is like very rich with a lot of tools that let you build a lot more. Like Next in 2018 is completely different from how it looks like today, right? Same goes with React for that matter. To be honest, you don't need Redux for that, like to 90% of use cases. So I think like it has changed a lot. But I think you should be open to that idea, because you don't want to rewrite everything every 1 year or so whenever someone decides to release like a super great solution. So I think it's more organic, like what Tarun mentioned.
Okay, cool. Siddharth, I'll let you speak to this question, but I have one more thing to add to this question before you take the stage. So as framework authors or as framework contributors, we often see companies, we often see people who started with our solutions, or who started with solution to whoever we contribute to, but then they move away from it. So like, yes, this is something that I would like to hear. Like, what are the factors that these people often go to a homegrown solution? But also, what would you advise? Like, how should they see that they're not doing a premature investment into this? Because platform teams are huge investment. There's a reason why Gatsby. There's a reason why I don't know about Nux, but at least Next. These are like people, companies with huge amount of capitals, right? And if you do a platform team, then you're basically on the same path. So how do you avoid a premature investment into such efforts?
So I think the first thing to note is that as a framework author, and most people will tell you this, when you're building an open source framework, you're trying to build something generic that can be useful for a lot of people, right? And when I say a lot of people, I mean a lot of different nuanced use cases. Often starting out from that is great, because it lets you get up to speed quickly. You want to focus on building your product, and that's fantastic. But at some inflection point, most teams, like both of Darpan and Kashyap have mentioned, will reach an inflection point where they want to do things that are hard to do in this framework, right? And then you start feeling like you're fighting it. So in many of those cases, it makes sense to then say eject and build your own thing.
Right.
However, remember that that's a lot more code that you're going to maintain. That's a lot more tech debt that's eventually going to come back and bite you, right? So ideally, don't do that till you absolutely need to. There are obviously use cases where you would need to. I've seen people, like Darpan mentioned with micro front ends, or I've seen people try to, in companies like Facebook will have entire platform and infrastructure teams to build out custom solutions to be able to serve what they're building. And that is really useful in some cases. But for most of us, we probably don't need it, right? In which case, it's nice to get what frameworks give you for free. I think it's easy to think you're at that inflection point early when you're not. In my opinion, the best thing to do is push that off as much as possible. You want to be focusing on building the product and what you're good at. You don't want to build from scratch. I don't know if that makes sense.
Yeah, that totally makes sense. I guess that answers the question pretty much. Okay, if there's anything to add to that sub part, Kashyap or Darpan? Otherwise, we can move to the next one.
I totally agree with what Siddharth said because ours was the same experience that we started the first micro front end. And at that point, we did not build our platform. We just started working on it. And once we had that, and when we started working on the second app, we realized, okay, now is the time we need it. So that's when we should do it. And then we did it.
Okay, cool. Awesome. My next question is something that I've seen on and off debate on a lot of platforms about. So, but this is also related to that framework. This is directly related to the framework layer. So I'll ask pretty much to you guys. So frameworks are like more or less frameworks are the bridging gap. What the platform gives you today versus what the developer experience need or the user experience needs. There's no doubt that there is a gap. There's a significant gap between these two. And it will always be a catch-up game because first comes the request, first comes some pattern has caught up, and then basically we need to go back and build it in the platform. Also, because putting something in the platform, be it web, be it Android, be it iOS, is a lot more work than just building a custom-based solution out of it. So frameworks are often seen that glue layer that, hey, this should provide me certain components, certain capabilities, which I want, but the platform is not there yet. So what are, in your opinion, in your experience, more per se, like what are these capabilities that you see as of today that should go away from frameworks, go away from Gatsby solutions or Nexus solution or Nuxus solution, and basically should go sit in WebKit or Chromium and so on, right? So for example, there are a lot of components that all of these frameworks gives for images, for performance monitoring, for data fetching. So what would be your top two if you have to pick? I'll let Kashyap take this one first.
Yeah. Hey. So it's true. I think but I think there is also one small nuance that frameworks themselves by design have the problem solve the case of giving a lot of primitives, and like Siddharth said, for solving a very generic problem, it becomes like bloated by default, and that's a huge issue in JavaScript. As it is, like we've seen that with like a lot of older frameworks where you get the same primitives that you get today, but it's kind of in a very different situation. So I think like and we also have like written a lot of these kind of like small reusable components that end up being somewhat similar to what the primitives that a framework would give. Like for example, if you look at our API API calling layer, it looks somewhat similar to, let's say, Next.js, the open source SVC. Was that SWC? One of these fetch wrappers that end up being built like actually.
Axios?
No, it was something else. This was more around Next.js itself. SWR, yeah.
Sure.
Thanks, Funnel, yeah. It resembles somewhat similar things. When we saw that announcement, it was like, this is like what we have, and this is like there is some gap that was there, but we wanted to use that. But again, like a dependency, we don't want to include it. That kind of things.
Okay.
So I think like for us, like it has always been, don't include a module if you can avoid it,
right?
So we kind of wait for all these primitives to go back to the browser as much as possible. I personally would like to see how the web components thing future will pan out, especially now that even we see that WebKit also has been actively being more open about the changes that they're doing, and like adding new features. Just like if you have seen the latest Safari, the developer thing, they've added like quite a few new features that were there in the recent Chromium release as well. So I think it, especially like images, I like the way that whole the async thing panned out. It's really nice. It solves like 80%, 90% of the use cases very well, very simply. You don't and the aspect ratio bits. A lot of these are going. I think like images.
So what would be your top two picks?
For me, like definitely a very performant, let's say, the reconciliation, or like let's say some primitive on top of like I said, the Polymer, or more like the lit HTML kind of like wrappers over the native web components. I think that's something that I'm really looking forward to see how it evolves. And then the second one would be, I guess, images, more control over images and stuff. Like for us, like images are the major use case pretty much.
Right, exactly. Okay, cool. Darpan?
For me, like if I needed two things in the browsers instead of the frameworks directly. So one thing is already, which already Kashyap mentioned, images. Images would be like a huge boost to that. It would improve a lot of things for everyone. The other thing that I can think of is maybe having a bit more insights into performance. Although, like the current performance analysis which Chrome gives you is already much better than what it used to be there. But currently, if you see something like React Dev Tools and everything, that gives you a lot more insight on why something is re-rendering and everything. And yeah, it would be nice to have some good support out of the box from the browser.
Okay, sure. Sid, do you want to go next?
Yes, absolutely. I've been waiting. I think your question's interesting. I think of frameworks as building blocks, right? Like most things. And some of those building blocks make sense to sort of build back into the platform, some don't. We've seen good examples of this, honestly. I think native lazy loading in Chrome was a great example of this, right? We had Gatsby image, where you'd get all this fancy fancy lazy loading, where an image would only get downloaded if it was in your sort of visible portion of your window and so on. And now with Intersection Observer, and that's how we built it. But today you don't have to do any of that. You have native lazy loading built into Chrome. That's a great example of how far we've come. Two of the things that I'm really looking forward to, and I don't know if it'll ever happen, one of them is already almost here, is a web where a sort of web that doesn't require the kind of tooling for bundling that we have today, right? With ES modules, I think we're finally getting back into a world where you can have hot module replacement, and you can sort of build sites without having this dev server running with bundling and so on. That is a future I'm looking forward to. The second one would be virtualization. I think something that is very common for large apps with tabular data or whatever is only rendering stuff that's visible in the window, right? This stuff is still really hard to do today.
Yes.
I mean, no one's writing this on their own, hopefully. If you are, don't, right? And I would really like to see us move towards a place where, Chromium, etc., build in some semblance of virtualization, where you don't need, say, React virtualizer, React window, or even if you're not using React, whatever you're building with, right? That's something I'm looking forward to. Again, these things take time.
Yes.
There's standards in place. These things take time, so it's perfectly reasonable. But yeah, interesting question. I love the question.
I actually personally want to add one small thing to this. Like, I'm aware that there have been attempts by the browser vendors to do the virtualization part. It's very interesting that you brought this up, because it's a super tough thing to do. There is an accessibility point of view that, hey, if we don't render, will they be still able to at least find it?
Exactly.
Are they not on screen, or are they not literally in the DOM? And I guess there have been attempts. I'm sure there must be an ongoing as well. But yes, virtualization is something that's, if this question would have been to me, that would have been my first answer as well. Like virtual lists or virtual scrollers for long things.
Yeah, as we get more ambitious in building web apps, I think that's something that's come up more and more often, right? You want to build larger apps that render more things and render more complex things. And a common sort of problem you'll hit when you try to do these things is that you're rendering too much and things take too long. But yeah, I'm really looking forward to see web browsers go in 10 years from now.
Same here. Okay, back to more of choosing stuff in our tech stacks, testing has been one thing the tech stacks has not been super opinionated about. There have been multiple flavors of testing. There have been number of ways of testing, and then there are levels of testing. You do testing, and it's a lot for someone to comprehend, and then it's also a lot to form a strong opinion around, right? So that's something like I would love to hear. How do you choose your tools here in this section? Because it's not you type something, then you get on the screen and you get the work done. It's more about how much to do, what all to do, then comes like which tool to use. So it's particularly hard to choose the tool here because you also don't know how much do you want to do. Like how do you build and opinions around this part? Okay.
So yeah, this is kind of this brings back so many discussions that, I wish I had like better answers there, like, went on for years and ages. But, I'm sure like everyone here in this group and also in the audience might have stared at a snapshot that's like 1,000 lines long, right? And you don't know what to do. You do you push it and like, like, fine, it's fine. Let's see what happens.
It worked,
right? Like, and then there will be a regression 2 weeks later, and then you have to revert that 1 week wala code and then do all of that. I think so. Choice is great, to be honest. I think that the fact that we have this kind of variation in the use cases actually lets us like, React components can be tested in an isolated fashion, which is great. Like you can now run tests that are super fast, reach out to the file system or, run the database or whatever. But on the other hand, you might want to have an integration test suite as well. But then the choices are, multiple choices are. I think it's good. It's good that we don't like, be opinionated when we don't have a proper abstraction or we don't know what we are solving, in fact. And there is a really good talk right after this panel discussion around like what we have been doing internally, and like, doing things like UI testing is a mixed bag of things. Like I have seen it work sometimes. I haven't seen it work in some cases. But I think like choice is great. In general, I personally would want to like, leverage as much as unit tests as possible, but define unit as another, 1 hour long discussion that I don't want to be in. You just write like something that, lets you confidently change that code. I think that's the best, thing that I probably could come up with. And that's what we use. That's what I try to, make sure that we use internally. So we don't have a debate there.
Sure. Okay. If others don't have any, super different answers.
No, I have a quick thing to add.
Okay,
Before
great.
we
Yeah,
continue.
sure.
I personally really dislike mixing testing into frameworks, and I'll tell you why. Tests are a pain to write, right? And tests can get irrelevant very quickly when mixed into your framework of choice, right? And that sort of makes it pointless, right? In my opinion, I strongly like integration tests or end-to-end tests or whatever you like to call them. I would write tests in Cypress that mirror user stories and how people use my app. Typically, completely, in a black box, staying away from internal implementation details. I've done this in the past where I've rewritten an entire app, but my test suite has continued to be usable, and I think that's really valuable. That lets you build stuff in confidence, even if you clean up implementation details. Which is why in most cases, I wouldn't even mix testing with a framework of choice. I would just, I don't know, if you're building web apps, use Cypress, or if you're building HTTP servers, just, I don't know, spin up a bunch of tests in Tap that call it. But I like these end-to-end tests that sort of work on that boundary. I don't like mixing them with frameworks. That was the only bit I wanted to add.
That's actually very interesting.
there's one thing that I would add. So even in end-to-end tests, I really like the behavior-driven test. So there's something called Cucumber.js where you just put statements like, when I do this, then this should happen, and this should happen, blah, blah, blah. And I really like it because that way you have a set of instructions which are readable by anyone, even someone who's not an engineer, and even they can write the tests, which is fantastic. And yeah, I love that and we use that.
Cool. Okay. Yeah, we are almost out of time. So I would not throw another question out there. Like, we
Already?
can eat up another
I was enjoying this.
30 minutes. Me too, but we are running too short of time. But I guess after this, we can meet at a table and we can take some questions or even discuss this further.
Yeah, sure.
All right.
Okay. Awesome. All right, over to you, Rajat.
Thank you, everyone. Thank you, Siddharth, Kashyap, Darpan, Pratik. A great discussion. I learned a lot of things. Same question, some things, even we discussed in our teams, and a lot of things have been cleared for me. So thanks a lot. Everyone, the panel members will be there in the lounge area. So if you want to, discuss more things with them, you can head over there. And thank you once again, everyone. Bye.
Hi, friends. So, your favorite host is back with yet another exciting talk. I'm extremely stoked to welcome Varsha Saha, who's a tech lead at Flipkart, and she's hugely popular in the front-end community. For those of you who do not know, she was also the host for the first version of React India 2019. And I think since then, the organizers have found a better host in me. So without much ado, I'll call Varsha Saha on the stage, and she'll talk about her journey of making the Flipkart apps more robust with a unique testing strategy. Everyone.
Thank you. Thank you, Ankit. I think they told me that I'm the original MC and no one can beat me. So I'm back here and I'll be the MC for the next couple of talks for you. I'm just joking there. I'm here as a speaker, and today I'm going to speak about something which is very, very close to my heart because this is a project that I've worked on for the last 1 year. And this is my first talk after 4 years. So I'm a bit nervous. But I'm hoping you'll enjoy it as much as I do. I'm just going to share my screen now. Hi. So my topic for today is one code base to rule them all, one code base to test them all. Now, I'm going to get to the point as to why I chose this as a topic. You'll know sooner or later why I chose this as the title of my talk. But yes, this is about integration testing. This is about integrating testing your apps, your web, your MWeb, desktop, everything. Right. So without further ado, let me reintroduce myself. I'm Varsha Saha, and I'm currently working as a tech lead at Flipkart. I love JS. I'm a dog mother, a huge chai addict, and of course, I'm a big shopaholic. Before I deep dive into various parts of the talk, because this context is huge and the scope is huge, I just want to outline it a bit so that all of you understand what I'm going to talk about today. First, I'll explain what I'm talking about. What is this about? Digging a little deeper into context of the talk, what we are doing at Flipkart, what we've been doing at Flipkart, and why I chose this topic to talk about today. Second, we'll talk about how did we prepare our code bases for this sort of integration testing, because we have a lot of legacy code. We wanted to prepare our code bases first, and I'll get to that when I go to the topic. The third one is one code base to test them all. This is something that I'm going to come to later as to why I'm saying this right now. Then we'll talk about the strategies used and what are the various strategies that are involved into creating this one code base that we built. And then we'll talk about the challenges that we faced during building this code base, during all sort of dev work that we've done. We've come across a plethora of challenges, and I'm going to outline a few of them. But trust me, this 1 year journey has not been easy, but it's been absolutely fulfilling. And then we'll talk about what is the future of this sort of testing at Flipkart and how are we planning to scale it. So yeah, coming to the first topic, what are we talking about? So we at Flipkart started our React Native journey somewhere 3 years ago. And since then, it has been an absolute roller coaster ride. So we've thoroughly enjoyed this migration to our code bases to React Native because there have been a lot of challenges and a lot of learning on the way. So right now, we have Android, iOS, and MWeb that work on React Native, right? MWeb works on React Native Web. And we have a team of 100 plus devs contributing to this particular one code base, right? So when 100 plus devs contribute to one particular code base, you can understand the amount of confusion, the amount of code that is going in every week into our deployments, right? Also, we have sort of these pod structures, which are capable of creating their own widgets, as well as changing some common widgets we have at Flipkart. When I say pod structure, Flipkart is just not an e-commerce app right now. We have flights, we have gamified challenges, we have games, we have grocery, we have hyperlocal, we have a lot of things on the Flipkart app itself, right? So you can understand why the team is so large and why do we have pod structures. Now, having said that, there are a lot of challenges with these sort of structures, right? Given that we have a huge code base where everybody's contributing. So let's say that a dev X changes something on a core widget, right? And similarly, a developer Y also changes something on that core widget. Now, who's the baseline? Who is the source of truth? So I'm talking about these sort of challenges. I'm talking about exactly these sort of problems: lack of stability, core components changing, and infusion of baseline, right? Because I don't know who's the source of truth. Somebody says this is how the widget is supposed to look. The other person says, hey, this is how the widget is supposed to be look. And then, what is the baseline? What is the thing that the designer actually told? That is lost in translation. So this was one of the major challenges that we faced, along with the stability challenges that I'm talking about, because there is so much code going on every week. We do not know, if the system is really stable. And hence, testing framework became the need of the hour. It was not just about doing doing things right. It was also the need of the hour. We were desperate to have a testing framework which could rescue us from all these problems. But testing framework comes in later, right? As I told you, we started with a React Native journey 3 years ago. Now, there's a lot of legacy code that is already there, right? So how do you even ask this legacy code to come on board to the new testing framework that we were creating? So, before I get into what we chose, let me talk to you about how do you do testing with your React Native apps and MWeb. So there's something called as test ID, which you include in your view tags or whatever tag that you want to kind of get, right? So in JavaScript, equivalent is get element by ID. It is similar in testing world as well, where you get a certain element by ID or XPath or class name, right? So you have to associate your views with the test ID. Now this test ID works for Android and MWeb, but it does not work for iOS. For iOS, you have to specifically put an accessibility label in order to make that view testable, right? So this is a brief about how you prepare your code base in React Native. Now there are two ways. We were faced with two ways that we could do that. One, we could ask our devs that, hey, in all the views that you see, please go ahead and put a test ID and accessibility label, right? Which is okay for future, right? You can put an ESLint and you can say that, hey, this view does not have a test ID or an accessibility label, and the dev will go ahead and put it, right? But what about the code that has already been written? Do you do a manual work of kind of putting everything that you have to test ID and accessibility label, or do you automate it? And of course, automation is the only answer, right? Now, automation has one more challenge. If a dev is doing it, you are free to decide what is the accessibility label and what is the test ID. But in automation, you have to choose a dynamic test ID which is stable enough. It's something like it has to be dynamic, but it also has to be stable. Why does it have to be dynamic? If you choose one test ID for all these elements, right, the point is lost because you want to have different IDs for different elements that you want to test. So dynamic is something that you cannot really let go of. Why should it be stable? Since it's an e-commerce website, right, and the pages keep on changing, your components keep on changing, right? If you do not keep it stable, your testing framework is basically redundant even before you allow it, right? So it has to be dynamic in nature as well as static in nature. And I'm coming to how we did that. But before that, this is a snippet of the code of how it looks like, how it looked like in our code bases. So you see a view with a certain style with some children, right? We created these automated dynamic IDs. So if you see this method, it's called create test ID. We tried to choose, we saw the responses of each of these widgets that we were getting. In each of the widgets, we had certain unique parameters which we could use to create these dynamic IDs. So one is your type, the other could be your screen name, the other could be your screen type, and so on, right? It can totally depend on your code base and your response structure as well. But for us, this unique ID worked for us. It was unique, it was dynamic in nature, and we did not have to do anything. We just had to use this function and create the dynamic IDs, right? But dynamic IDs also need to be attached, right? So you need a wrapper class, which is nothing but a React fragment, which kind of passes this created, test ID and passes it to the child that it has wrapped onto. So as you can see, it's a React fragment, and we have a React child inside of it. And once you create this dynamic test ID, you simply pass it to the child. So it's a fragment. It does not break the CSS at all. Your code base still remains proper. Then comes the next part. How do you even attach it, right? So we were faced with two sort of options. One was Babel, Babel code mod. Until then, we had not explored JS Code Shift. So we tried Babel, but it was very tedious and very long to write, right? And you had to understand a lot of nitty-gritty to come up with a right Babel code mod. Also with Metro Bundler, integration of this Babel plugin was a little difficult because we want to integrate it in apps as well. We want to integrate it in MWeb as well, right? So it became a little difficult and things were looking a bit shaky for us. And writing that was really tedious for us. And then we saw this JS Code Shift. And it was like out of the box. It had so many things. You could really understand what was going on. And this snippet, by the way, you need not go through it completely line by line. This is just a snippet, a brief snippet of how we use this code mod to attach the previously said wrapper class above all the views or all the tappables that we wanted to target. Then comes the next part. How do you integrate it with build pipeline? But before that, I want to tell you that in iOS, as I explained, you are using accessibility label, which is a strict no-no, right? Because it has a specific purpose. You cannot just use it for random testing. So what we did is we separated out the automated testing pipeline from the main Flipkart.com. So at any given point of time, you will not see these test IDs or accessibility labels on the Flipkart app or on MWeb. It is all on a different box. It is outside of your production environment. It is a completely different automated environment. And this is a snippet of my local system, but this is exactly what goes on with our build pipeline. It kind of sends all the files. And just a second. So if you can see 0 errors, 1306 unmodified, 1418 okay. Which means I've just changed 1418 files right now, right? Which is really cool to do with the JS Code Shift. So this is the first part. This is how we prepared our code base. And this is the after snapshot of how the code looks like. The test IDs are automatically attached to the views, right? Now comes the testing framework. One code base to test them all. Why? Because we chose one code base to code them all. We chose React Native for MWeb, for Android, and for iOS. We wanted to kind of put the same thing out for testing as well. Why have triple the effort when you can test with one code base? Why write so much code for all the three platforms when you can target all three of them with just one, right? And hence we knew our obvious choice had to be Selenium, because Selenium is brilliant in terms of the amount of drivers it has. It has WebDriver, it has Android specific driver, it has iOS specific driver. And that became the obvious choice for us, right? So we as in one SDET and a bunch of devs, we created this framework, but we chose one thing, that whenever a QA has to write these tests, or even a layman has to write these tests, right? They should be abstracted out from what goes on inside. If I'm targeting 3 channels, our QAs or anybody else who's onboarding with us should not care about targeting 3 different platforms. They should be writing simple English language to test their code, right? And hence abstractions became the need of the day, right? But the core instructions still remain the same. It has to be the simple English language. So how does a manual QA test your sites? Today, she goes to flipkart.com, she scrolls, she selects the 4th banner, and she sees if the landing page is fine. And this is exactly how we wanted our testing framework to work, right? So you have to give them simple instructions and let the framework do the job. Now, here we'll talk about the strategies, as in what I just spoke about. How do you write these abstractions, and what we did in the framework so that everything became like a simple English language instruction. Those are the strategies that we targeted. So let's go ahead and build some abstractions. This is a very simple test case that I've put here, and I have not cheated anyhow. This is exactly how the code is in our testing framework right now. Yeah, you can see a Jira ID associated there as well. So basically what I'm trying to do is verify the cart screen with physical item in cart, right? And the step is passed if it is added. And you can see with 4 lines of code, out of which 1 is 2 are assertion and 1 is an if condition, there's just 1 line that anybody has to write in this code, which says add an item to cart and go to cart page. And that's it. That's the simplest English form of what we could give to whoever was writing these test cases. How did it happen? We built those abstractions. We said that add item to cart will get the cart item, check the driver utility that it is using, and see if the element is clickable. Go ahead and click it. Right? Similarly, go to cart also has similar sort of steps. And if you see this add to cart, the X path or the ID that I'm using is exactly the same that my framework had generated earlier, that the code mod had generated earlier. So it is a combination of some sort of screen name, some sort of type, right? Cart, add, multi-widget page, which is unique, which is dynamic and stable, right? So you could easily target that. That's how we build abstractions. So if you can say, you just have seen that our QAs or anybody who's writing the test has to write very, very simple English language instructions, and the driver utilities and the base classes that we've put will handle everything. So the drivers change depending on the platform, but the strategy and the core instructions still remain the same. The next strategy that we targeted was called record and replay mode. What is record and replay? So we have a very dynamic e-commerce website. It's not like the same products are listed every day. The same products are not even listed every hour. You open our homepage, it's going to change every 2 hours. It's that dynamic in nature. So of course, we could not hit the real server APIs and get the responses back. We had to find a way to proxy those things, right? And MITM proxy became our default choice for that. We use MITM proxy to intercept all the requests that were going on, whether it was get, post, put, everything. And then when the responses come back, we store it in our system. And we use some pattern to pick the right response. Now, this was one of the most challenging part of what we did, picking the right response. And I'm going to tell you why this was very challenging. So, if you look into this video, all the calls on homepage are fetch. If you go to browse page, all the calls are fetch still. If you go to product page, again, all the calls are fetch. How do you differentiate between each other? So you have some parameters, right? You have some request payload that goes on with it. You have location context, you have page context, you have page URI, right? So we found, since all these requests were basically fetch requests and we had no differentiation, what I said earlier would have really failed, right? Sorry. What I said earlier would have really failed, right? Because all these calls are fetch requests, and if we do not find a unique key to pick these responses, which really happened with us, so we kind of always started picking the wrong responses. So for, let's say, homepage fetch request, we started picking cart page fetch response that we had marked. So we had to find this unique key, which was a combination of page URI, location, and whatnot, and then we started storing it in our system. So if you see here, there's an example right here on how we stored it. So if you see, it says test 11, add item to cart, which channel it is targeting. If you see, we are kind of using every request. We have get, we have post, and in post, we have separate calls as well, where, add to cart is one call that is going on. So this is the unique key that I'm talking about. We kind of found out what works best for us in terms of picking the responses, and we stored it that way. So now this key is used to match the response that is coming in. And once we have that, we push the right response back from our proxy. So that is how proxy intercepts the requests and pushes the right response back without having to interact with the server in replay mode. And hence there are two modes, record and replay. In record mode, what you could do is you could hit the real API server, you could hit the real APIs, get the response back, store it in your file system, and in the replay mode, you can stop these calls going to the server, put your proxy in between, intercept those calls, and then push the right response. So this is simply what a QA or anybody who's writing the test will have to do. You just have to change the value to true and false, and voila, your record or replay mode will be changed accordingly. So in true, it is record mode, and if it's false, it's replay mode. Next, we come to assertions. Assertions are very, very crucial to any testing framework, right? And typically, how do we do assertions in our code bases? we typically use text-based assertions, right? But there are certain problems with text-based assertions, and I wouldn't call them problems. I would say that they're very tedious to write, and I'm very lazy to write text-based assertions. So I wouldn't have pushed anybody to do that for me. So when you test anything and you want to assert it via text-based assertions, what you would normally do is check the title is this, check the subtitle is this, check if the price is this, right? And for one test case, you have to write like 5-6 assertions. And then if all of them pass, you mark the test case as success. Otherwise, it fails. So these 5-6 assertions are truly a waste of time, and I do not want to write them. Another problem with them is that CSS and adherence to design is a must for any UI, right? How do you do that in text-based assertions? Like, you could probably check what is the value of padding and margin, but again, that's too tedious to write. So what did we do? We started clicking page level screenshots and widget level screenshots. So screenshot is the way to assert. And I'm sure that, even in web tech, everybody is doing that right now. Selenium gives out of the box driver, which clicks screenshots for you. So clicking screenshots is not a problem. It's there. It's already there. So you just click the screenshot. You have the screenshot with you. But I'm coming up with some challenges that we faced with clicking these screenshots. Challenge number 1, blinking content. So you see a login page here. Now I said there are 2 modes, record and replay. Let's say in record mode, in this text field, there was a cursor. And when you click the screenshot, the cursor was still present because it blinks like that, right? So it was present there. But in the replay mode, when I went ahead and clicked the screenshot, the cursor was suddenly, I clicked the screenshot at a time when the cursor was not there. The 2 snapshots failed in comparison, right? So how do you avoid that? You identify what are the elements that are going to be animatable, that are going to move on the screen, right? And you put an overlay on that. So we found out the position of all such elements on the screen, and we started putting overlays on that, because that's not what I'm testing. I'm testing the rest of the content. So this is one of the abstractions that we put. We said capture screenshot with ignored elements. What it would do is, to the image comparator that we have, it will find the list of elements that you want to ignore. It will pass it to that and ask it to click screenshot accordingly and put overlay on the rest of the ignored elements. We also found out some core elements which were moving on the page that we always wanted to ignore. For example, this edit text we always wanted to ignore, right? The blinking cursor. There is some banner carousel on Flipkart.com that comes on the home page that moves on and on. We wanted to, put a black overlay on top of that. So we identified some sort of key elements that we wanted to ignore and did that. The next challenge in image clicking is scroll and click, and that is one hell of a challenge. So this is just a video of, this is actually real automation. So this is how it's moving with automating, right? And then you click these screenshots. What is the problem here? In record mode, let's say it was let's say at Y pixel. You click the screenshot at Y pixel. But in replay mode, you click the same screenshot at Y + 1 pixel. So this 1 pixel could be really, really damaging to us, right? Because when you compare these screenshots, it's of course going to fail. So what is the solution that we put here? We did this thing. In record mode, we clicked only 1 screenshot. But in replay mode, we started clicking screenshots Y pixels above and Y pixels below. And the right threshold for us, I think, was 2. So we clicked 0, 1, 2 and -1, 2. And if any of the screenshot matches with the original screenshot, we mark the test as success. This was, again, a challenge which we spent days on, finding a good image comparator. Now, this was very challenging because, at least in Java world, plus I'm from JavaScript world, so I do not even know so much about Java. But we could not find a good image comparator which could really, fix the anti-aliasing of pixels and could give us, shinier, brighter results on what the difference look like. Sometimes to our eyes, the images look exactly the same, but the Java image comparator used to break it. And no matter what we did, we were not able to fix it. The test framework itself became very unstable. Then somehow we came across this amazing library and it's written in JavaScript. It's called Pixel Match. And kudos to the creators of Pixel Match. It was a lifesaver for us. It's a very small library, and it features accurate anti-alias pixel detection. And the thing is that it is actually built to compare screenshot and testing. And this is exactly what we used. But the best part about Pixel Match is that it comes with a binary that works with PNG images. So even in Java world, we were able to use this JavaScript library, put the binary in our Java code, and then use it seamlessly. So if you see, this is exactly the code that we had to write to integrate Pixel Match. We just said Pixel Match, expected image path, actual image path, where should the diff be? And the last parameter is called a threshold. Now this threshold is important, and it will totally depend on the sort of comparison that you want to do. We wanted our baseline to be at around 0.55, where if largely some icons have moved here and there, we wanted to break the image comparison. Otherwise, we were fine with it. A little shaky or something like that is still fine. This is how Pixel Match works. So if you see, the F-assured icon on the first screenshot is slightly towards your right side, whereas on the replay mode, it is slightly towards your left side, right? And the difference has been caught by the library. It says that, hey, this is what the difference is, and the test case failed, right? So if somebody changes your core widget, you'll automatically get to know about it. Other key challenge that we faced was of dynamic pages. Now, as I said, we have so many devs, we have so many pods, we have so many people changing our components, right? If you start clicking page level screenshots, does it really serve the purpose? So what I'm talking about is, let's say X team changed the deliver to Bangalore widget. Like the delivery pin code widget has been changed by X team. But all the screenshots that belong to Y team has broken. Why? Because we were clicking page level screenshot, and clearly the entire page broke because some of the design changed here, right? We did not want that. We did not want our testing to be that unstable. So again, keeping stability of the testing framework in mind, we decided to go ahead with widget level screenshots, right? So we tried to find the accurate widget X and Y, how much screenshot we have to click. And then we posted that only to the image comparator for the image comparator to click only that part. So now if widget Y, if team Y has a certain widget on a certain page, even if X widget changes, they have nothing to do with it. Their test case still passes, right? We do have page level screenshots, but those are just sanity, right? So if it breaks, it's okay. We are going to update the baseline images. But at least 10 or 14,000 of our test cases aren't breaking because we have decided to click page level screenshots. That is it. I think there were a lot more challenges to what I'm talking about. This has been a one-year journey of finding the right platform, finding the right framework, doing a lot of things, a lot of challenges involved because we had 3 channels to target: Android, iOS, and web. And it's not easy. Android has its own challenges, iOS has its own challenges. But for the sake of time, I'm not going to delve deeper into it. Maybe if you want to catch up with me later, I'm going to talk more about it in detail because I have clearly spent a lot of time to discuss all of this. And I don't want to waste your time right now. But this is what the future looks like for us at Flipkart. We want to attach this testing suite in our PR pipeline. We are also going to create a smoke suite. A smoke suite is something where you have like 10 or 15 cases, important cases that you want to execute with every PR, because our sanity has around 4,000 cases and our regression has around 20,000 cases as of now. So it's not possible to run that for every PR. We also want to build an infra to support this. Right now, we have procured 3 Mac Minis and running Android emulators on that and running these test cases, but we want to do something similar for MWeb and iOS as well. Also, we want to reduce a bit of our testing time because, as I said, we have a lot of test cases. So we are trying to reduce the amount of time that is spent in executing these tests and get down to a threshold that we are targeting this year. So that is how the future looks like. And I think you can see it in action now. This is completely automated in an emulator. This is the instruction I'm passing, clicking screenshots on the way and doing what I have to do. So if you see the page being stuck for a certain time, it's only because it's taking a screenshot. And if you see this bestseller thing, right, it's animating the silver line that gets blocked. that has an overlay when you click the screenshot. So yeah. The awesome team. Of course, every project is a team effort. It's not just an individual effort. I'm a spokesperson here, but my team was really great, and we had really fun doing this for the 1 year that we did this. So just a quick introduction: Siddhant Soni. He is an SD2 from Android team. Hemant Jain, he's from Central Flipkart team. He's a tech lead and he's an SDET. And Saicharan, who recently joined us in 2020. SD1 iOS. So thank you team for making this possible, and thank you everyone. I had a great time talking about it.
Thank you, Varsha. This was an amazing talk, and I think the audience loved. And there's so many questions for you. We'll take one question.
Sorry, Ankit, I am not able to hear you at all.
I think we'll take the Q&A.
Maybe you could come here, given that you're just here. So maybe we can interact in the same room.
Right. I think we'll take this to the lounge. Thank you, audience. At this point of time, Varsha will be available in the lounge, and please go there and get your questions answered. Thank you, Varsha. Okay, that was an amazing talk. At this point of time, what I want to do is I want to thank our gold sponsor, Gupshup. And because of them, we are able to get such high quality content talks delivered right to us within the comforts of our homes. And I would also like to invite Pankaj, who's the director of AI and analytics. He has over 20 years of work experience with deep expertise in cloud big data, data science, and machine learning. He specializes in developing and deploying machine learning solutions, computer vision, natural language processing, and structured data using latest deep learning and cloud technologies. So over to you, Pankaj.
Hello, everyone. How are you doing? It is a pleasure to be speaking to you all. What if I told you that your apps can have a very smart assistant with very little effort? My name is Pankaj Bisen, and I'm Director of AI and Analytics at Gupshup. And today I would love to talk to you about how to engage better through conversational messaging. We are in the midst of some really exciting things around application development and user engagement that I wanted to talk to you all about. We are thrilled because we at Gupshup have been able to help hundreds of thousands of developers and businesses succeed. And it is a story that I'm sure will resonate well with you. As developers, you all are well aware of challenges in making an app and success. You have a great business idea, be it a new app altogether or a feature in an existing app. So you build a great app with hard work and lots of investment. You have a web version of your app and a mobile version for Android and iOS, etc. Most of the users are not on laptops or desktops. So what do you think is the hardest part of it? Obviously, getting your users to use it, right? Now, for example, as an end user, all of my desktop time goes in work-related apps and websites. I don't have time for other websites, even if they could help or add value to me. Now, this is a very tough and inevitable conundrum that every developer has to inevitably come across. Rest of the time, when I am at my mobile, although I could benefit from your app, already I have dozens of apps, and downloading yet another app, even if it is a progressive web app, feels like a commitment. I can't even recall how many apps I would have just passed on just because of this feeling of commitment, right? So this is the conundrum. So how do we? So I'm excited to tell you that we have been able to help hundreds of thousands of developers and businesses with this very conundrum. So how do we crack this conundrum? Through our rich and comprehensive conversational messaging platform. So when these developers and businesses had a great idea or a new feature in their existing app, they did not have to go through the rut of an expensive app development and then excruciating wait to get user attention, right? They use our conversational experience platform to engage with millions of users across 30 plus channels. You see, almost all users have at least one of these 30 plus messaging apps like WhatsApp, Instagram, Facebook, Slack, or Telegram, right? There was no commitment barrier for users to install a new app. The developers and businesses did not even need to write code necessarily to build a new user experience. Now, you might be wondering, how rich of a user experience can you possibly deliver over conversational apps? To which I say, a lot richer than most people imagine. It is not just about OTP confirmations, approvals, and reminders. It is also about flipping through product catalog for e-commerce, operating your bank account, payments, appointments, delivery, logistics, education. Come to think of it, there is very little that a conversation user interface cannot deliver. One of the on one hand, these businesses and developers got breadth and depth of reach across their user base. On the other hand, they also got pre-built user engagement across entire customer lifecycle, starting from promotion to lead generation and all the way to support and loyalty. There was no need for these developers to develop any of these features in iterative manner over a period of time and at great expense. This is where rubber hits the road, our APIs and services. So how exactly do you go about delivering such user experiences? That's where our APIs and services come in. So you use one of these three pathways to get quickly started: no code, low code, and yo code. So pick your weapon of choice. Pick no-code tools with list of pre-built templates and customize to your needs and instantly publish a fully functional conversational experience in minutes. You benefit from a mature ecosystem of pre-built domain-specific AI models that are continuously getting trained on the billions of messages that flow through our platform. That brings us to low-code AI, and it is a conversational experience toolkit. If pre-built templates will not suffice what you have in mind, then go ahead and outline a detailed and advanced conversational experience, which is precisely how you like it to be. Use our graphical editor to precisely define every flow, branch, and turn of your conversations. And I hear you. There are plenty of times when you just need to take your Terminator gloves off and get your hands dirty into coding. We got you covered there as well. A full code editor with JavaScript and all the development tools to get you hack out anything you had in mind. Our Yo Code platform supports entire development lifecycle: scripting, testing, hosting, analytics, what have you. The customization capability is not just limited to the flow of conversation. You can also customize the AI involved in your conversations. And this does not require you to curate training data and wait for training models, etc. And that is why we call it NLP on the fly. You can use our NLP or natural language processing on the fly API by just providing a handful of sample statements for each intent. You can have an AI capable bot that can have human-like conversations for your specific intents. Even though you can reach out to your customers across so many channels, but you can also ultimately benefit from channel-specific rich capabilities. Let us take WhatsApp, for example. Gupshup facilitates easy coordination between you and WhatsApp and saves you a lot of trouble. While most of the communication is automated, Gupshup efficiently takes care of processes that Gupshup, for good reasons, has left to human expertise. So you get to use rich media notifications, images, stocks, PDFs, audios, locations, etc. You get to scan QR codes. You automatically get multi-language support and powerful analytics to see the usage of your bots and the return on investment. The opt-in management is automated, so user opt-in and end-to-end opt-in management is available. And remember when I said there is a little that a conversational user experience cannot deliver? Interactive elements help you do that. So with quick replies and call to action buttons, support for interactive elements is just keeps getting better day by day. So with carousels and scrollable and searchable lists, etc., that are on the cards on a lot of these channels. So it's just getting better day by day. Another example is our Instagram API. You can use this to have richer two-way conversations with followers on Instagram. You can leverage text, rich media, quick replies to build more meaningful relationships with customers. One of the great things about this ability to reach millions of users across 30+ channels is that none of this requires an upfront investment or commitment. We have a pay-as-you-use model where you only pay for the messages you send and receive. So load up your wallet and you're ready to go. So let us join forces and start building something great. Last but not the least, please take some time to visit us at our booth. We have exciting programs like extending credits to startups, etc. We would love to speak to you about how best we can help you succeed. So happy coding.
Hey, hi everyone. Welcome to the second day and the second half of the second day, actually, of React India 2021. A very warm welcome. I'm Anushri Subramani, and I'm going to be the host for the rest of the day. So, my personal motto in life has always been to learn, grow, and just be better than my version of yesterday. And I think today just presents such a great opportunity for learning a lot of cool new things. So let's just jump right in. Let's welcome our very next speaker, who is Nikhil Sharma, onto the stage. Hi, Nikhil.
Hey Anushri, and hi everyone who have been attending all these insightful talks. Super excited to have you guys here.
Awesome. We are equally excited to have you here. We know that your love for accessibility, performance, and all of that. But I was really fascinated to hear about your love for singing.
Okay.
So what sort of music do you sing? Is it Carnatic or is it Western? What is it?
I'm from North India, and it's just standard Bollywood songs that I usually sing. Not a professional singer, by the way. I don't. I'm not too good at singing. It's just my hobby that I do to relax myself. So yeah, that's it.
Do you think you can sing a little bit for all of us? Our audience would just love it, honestly, and we're just very supportive and friendly audience.
Okay.
So if you're okay with it, please.
Yeah, sure. So I'll just sing one or two lines so that people don't leave out the conference because of my bad voice. Okay.
I'm sure you'll be great.
All right. Yeah. So. हाँ हंसी बन गए, हाँ नमी बन गए, तुम मेरे आसमां, मेरी ज़मीं बन गए. Thanks a lot. Not much like that.
That was beautiful. I think if you check the comments, I'm pretty sure there'll be a lot of love and support for you. So thank you for sharing your gift with us. It was really an honor to listen to it. So with that, I think I'm going to hand over the reins to you, Nikhil. All the best.
Thanks for that.
Looking forward to your talk.
Okay.
All right.
Yep. Thanks, Anushri. Let me just quickly share the screen. All right. Okay, so hey everyone. Thanks a lot again for joining in all the insightful talks. I'm super excited to have you guys here. So in this particular session, right, I'll be talking about how we can make our product, how we can make our React product more usable and more reachable towards our audience with a very simple tool called accessibility. So let's quickly dive into it. So for the ones who don't know me, a quick intro from my side. Hey, I'm Nikhil. As Anushri had already mentioned, so I'm a software engineer at Postman. I mostly handle stuff around Postman on the web, Postman is just a platform, and the design systems at Postman. So I mostly love to talk about design systems and performance in general. So if you guys would want to have a chat, I'd love to have you guys. Here's my Twitter and GitHub handles. So yeah, come say hi. It will be a great chat. So before diving in, let's quickly start things with a very simple analogy, right? So let's imagine things in the view of a constitution. So if we talk about the Constitution of India, right, it guarantees us some form of rights, right, so that everyone is seen on a very on a single plate of equality, right? So for example, there's right to education, where everyone has the right to gain access to the education, get a job, get degrees and stuff like that. There's right to religion, that everyone in the country can have, they can choose any religion and they can worship it of their choice. There's also right to expression, so that everyone has an equal say and they can raise their opinions or concerns in the country. So if we take a gist out of that analogy, right, what we can see is the Constitution actually guarantees us equality, and like it treats us under an equal roof of stature, regardless of seeing that who that person is, or what's the current, what's the gender, what's the race, what's the ethnicity, or what's the religion, stuff like that. It does not see, like it does not differ people based on those foregrounds. So, like taking this example a little further, this is how that is analogous to accessibility. So similarly, like Constitution, like how it guarantees us an equality of stature, accessibility guarantees that there is an equality of people in terms of consuming a user interface or service or a product, regardless of any sorts of disability that any other person have. And that is the most crux of, and like that's the beauty of accessibility. So like you can call it accessibility or A11Y. The 11 is like just the number of the count of the characters that's between A and Y. So and like that's mostly the crux of accessibility. Simple put is anyone should be able to access your service or your product regardless of any sort of disability that the person would have. In our case, we'll be sticking our talk mostly towards web accessibility. So like for having accessible, for like making a product accessible, we use things like having screen readers who can read aloud our information on the web to the people who cannot see, like who are blind. We use keyword navigation for people who are having disabilities, like having a motor skills where they are not able to have a steady hand over using a mouse. And also like having alternate text for your images, SVGs, etc. We're gonna have have a detailed discussion towards it, but like that's the gist. So if you see the real world, right, accessibility has been like added in a like a great fashion when we talk about the real world, right? So if there's a person who is unable to walk properly, we have wheelchairs created for them so that they can like move around. For people who are having problem with their vision, we have created sticks for them so that like they are able to walk in safely on the roads. For people who want to like read content like such as novels or something, we have created braille scripts for people who are like visually challenged so that they can access that content too, rather than also the people who are sound visually. And like what I think is like if this has happened in the real world, why not in our React world, right? And like these are these two terms which you are gonna encounter once you like dig into accessibility things. So a quick intro on these. So the left abbreviation stands for Web Content Accessibility Guidelines. It is nothing but a set of standards which have been put together by a set of people across the world, and like these guidelines and like sort of a checklist are the ones which can help developers to go through and follow these best practices to make their content accessible. Going towards the next thing is WAI ARIA, which stands for Web Accessibility Initiative, Accessibility Rich Internet Applications, which is a subset of WCAG guidelines actually. And what it does is to meet these guidelines and checklists defined by WCAG, it exposes a set of APIs, or if you could call HTML attributes, so that you can use inside your JSX and React. For example, I've listed a couple of examples here. So there's ARIA Live, which you can use to let the screen readers know what is the current active section of your SPA, because like we don't have like reloading or like new pages coming up since we have SPAs. We just show and hide content, right? So that is how it is useful. There's ARIA required, which we can use on our inputs, which tells the screen readers that actually this input is a required field and can't be left blank. There is another thing called ARIA invalid, which can help people to know that there is an input field which is right now invalid, and it can give, and like the screen readers can use this information to give people more insights around what's the error actually to the person who are using a screen reader. And there's way more than that. It's a very big library. A very interesting fact to note here is like we are having this conception, right, that all of the HTML attributes are like mostly in a camel case when it comes to JSX. But like that's not the case with accessibility, right? So in the example on the right side, you have to use it as it is, that is defined for the HTML way. So like here I've used ARIA required. So yeah, you have to just use it in the same way, and like not in our old mental model, which is using a camel case out of it. So that's one thing that we have to keep in mind. So why should we care about accessibility? Like, why is there a need to like cater to all these things? Why is there this headache? So the very important thing is that a report says that 15% of the world population has some disability. And like this number is very huge, right, if you talk about it, because the world population and having a 15% of it which might have problems in using your website without accessibility is a very huge number, and you would want to reach out to those users so that your product becomes more reachable and more usable to any sorts of people. Also, secondly, it's a very important thing, and like it has happened recently. So you would want to reduce your chances of getting sued, right? Because if you have an application and that application is like spread across multiple countries, and like different countries might have different laws for people who are like visually challenged. So there is an act called Americans with Disability Act, which guarantees that the products or any sort of services should be usable by accessible for the people who are like challenged in some way. So that happened with Domino's as well, where a person who could not see clearly was not able to access the Domino's website because it lacked accessibility. And guess what? He sued the company, and like he won in the end. So you might want to like reduce those chances of getting sued by like just not adding too much of accessibility, but at least start incrementally with getting the right practices at place. And also, it's a very fun fact that I did a quick poll, and I got to know that most of us across the globe, we think that accessibility is just around using the right HTML, and it's not just the case, which we are going to see in the talk, obviously. So already, although like this poll did not have too much of people involved, but yeah, like thought of sharing it because it's a clear-cut winner that people think that using the right HTML is the best thing to do. Coming on to accessibility myths, these are the 4 myths that you would see that would get busted out at the end of this talk. So first of all, accessibility is not just for disabled people, it's way more around that. For example, it's also around improving the user interface for people who are not like challenged in some way. For example, having good loading indicators to tell people that there is something that is visually loading is also a subset of accessibility. Using the right set of fonts or using the right color contrast is also coming under accessibility. So it's also about disabled people, but not just restricted to disabled people. Secondly, like people think that accessibility is hard, man. Come on, I have to do so much of work to like make my things accessible. It's like too much of an effort for me. So I'll like quickly show you a demo at the end of this talk that just using small HTML practices, you can like just get started with HTML at a pace, and this can like really help you get started with things and like quick start accessible practices. A third and very important is like accessibility is not just about having ARIAs and all. So as I mentioned, like it is way more than that. ARIA is a subset of those guidelines, but like not the only guidelines. And fourthly, like this talk is not just an accessibility primer. It just not gives you the documentation of accessibility. Don't treat it like a documentation. It's a more practical way of approaching accessibility. And also we'll see a demo of like how we can learn about accessibility in a more visual way rather than just text and all. All right. So with that being said, let's get started, right? So the first tip that I would want to mention is using the semantic HTML tags when it comes to accessibility. And by semantic, we just mean like simple put is just use the right HTML tags at the right place. Now, why this is important is using right HTML tags is the foundation of web accessibility. And that is because using the right HTML gives you a half of your battle won when it comes to accessibility, because you get some of the features out of the box, like better focus control and focus indication out of those elements when someone is tabbing out these elements. Also, you don't have to write too much of your ARIA properties to describe screen readers what is happening, because screen readers usually rely on the right set of HTML that you are writing inside your code base, and they use that HTML to derive sense out of what is the content actually inside those HTML tags. And the more better you write your HTML, the better are they going to convey your data to your screen readers. So that help is there out of the box when you use the right HTML at the right place. And thirdly, accessibility is also about developers, right? So if there's a new developer that comes to your team, so having a lot of divs in hand might not give him a good impression of what things are doing in terms of HTML. So your peer developers would get to know like what is happening in each HTML section. So adding on to this last point, if you see the example on the left, like this is a contrived example, and I know it because I have. But if you see this on the right side, there's a div, and like there are a lot of divs here with inside the div called app. So you might not be able to give a first-hand look at what is happening here, like what does each div contain. But on the right side, when I use the right HTML, right, it gives you that small visual sort of a visual thing that what might be the content inside. So for example, if I'm working on my company on a header, I know like what is the particular sort of an HTML that is going to get impacted. So here there's the header, and there is like a side on like which shows you content on the right side of your page. There's a main tag here defined by HTML, which gives you like which lets the screen readers know that hey, this is the main content where your like all of the main stuff lies. And there's also footer showing some additional info of your page. You can use that, like you can see how the screen readers might get a hold of the HTML that you're writing. So if you see this image on the right, you can see that headers is something that is on the top of the page. Then if you have some links to navigate people to, you can use the nav tag. Similarly, there's a side tag on the right and footer on the left and stuff like that. So if you need to know the right HTML, there's this small mapping that can help you know that which HTML to use at what place. Another very important fun fact is that accessible JSX is not able to accessible HTML. I have seen like a lot of folks asking me about like, hey, I have used this sort of a code, and I'm still having issues with accessibility. So I would like to say that it's not about accessible JSX. You have to use accessible HTML inside this JSX. So naming this in the right way might not be the only thing that you would do for accessibility. So for example, this header component should use a header tag inside of it so that things become accessible. And like we are the ones like who are at site when it comes to like thinking that accessibility is hard. So I like bust that myth that I discussed earlier, right? So let's see how we make things difficult and we overadd the burden of adding accessibility and making us think that accessibility is very hard. So let's see how do we actually encounter things like this. So for example, if I want to create a simple button, right, which just says no more. So for example, someone just uses a div because they find it easy to like style things up and stuff like that. They use a div, they create an on click on that div to give it a simulation of button. And then they realize that, hey, I'm not having a good amount of accessibility on this div. Screen readers can't read it. So like, let me just use ARIA and all that stuff. Let me just give it a role as button. And then I can like just let the screen readers know that this is a button. That being done, I then come to know that, hey, now it is having a button, but it does not have the right focus. The people with keyword accessibility issues are not able to use this div, and I can't see the focus coming out on this button when using on a keyboard. So you use a tab index property on this div. You set it as 0 so that tabbing behavior is possible in this. And that is the thing that we usually do. And that adds on to the unnecessary work that we were doing, because the simple thing that we had to do was just use the right HTML, and it is all handled out of the box. All right, coming up to the next thing is keyword accessibility. So simple thing as you would be able to think out of this out of the heading is keyword accessibility is something that you should be able to use an application without the use of a mouse, right? So if you start like if you start tabbing across different elements inside your website, you should be able to go to any particular element inside your web page using a tab. You should be able to enter a link by pressing enter key. If you have opened a drop down, you should be able to traverse over the items of a drop down list while using up and down keys. So that is what defines keyword accessibility. So that means we should be able to show a defined focus indicator to show the people where exactly are they in terms of like when they are traversing our page in terms of tabbing and using a keyboard itself. And that's very important for people, because unlike a mouse, they do not have that indicator in place, and they can easily get lost in your website that where exactly am I now. And also very important is that you should not have any keyboard traps. And what it means is if I am tabbing across my website, there should not be any of the elements which is like interactable and that is left out of when I am tabbing things. And I should not like if I start tabbing from one sort of a button or one sort of element, I should be able to tab across all of the interactable items inside a web page. So that is what defines that we should not have any sort of keyboard traps. Now, another thing, like very important, that why it is super important to have keyword accessibility. So the very first point is people who are having visual issues, they usually rely on keyboards because they can't see the monitor, right? So they would be using the keyboards to travel across things and relying on screen readers to give them information for that. Also, even if people are not having visual issues, people might have issues like motor disabilities. And what that means is they might not be having a stable hand while using a mouse. So they might not be able to use your progress bar if you have that inside your website, because their hands are usually shaky and they can't use a mouse very effectively. So that's where the keyboard support comes in. And thirdly, it's a very known fact that we love keyboards, right? Because as you see, I'm not using a mouse here to traverse my slides inside this presentation. I'm also using a keyboard. We are onto shortcuts when it comes to using stuff like VS Code and using different parts of that, any app. So it's all about keyboards that we do love. So it's not just all about motor disabilities and people who are blind. It's also about improving the user interface. So yeah, semantic HTML for the win, because now, as I had already mentioned, if you use a semantic HTML, you get that keyboard support right out of the box. So if you see this demo that I'll be showing, you can see that I've used the right HTML at the right places, and the browser is actually taking care of showing me that focus outline of where I am with the simple keyboard support. So the first tip that I would want to give is how we can make a more visual and a more vibrant focus styles. So by default, if we are using the right HTML, the browser gives you a very simple outline showing you where exactly you are. But we can make that focus sort of an outline a more better one for people to perceive it. So just what we can just do is override those styles by just setting outline property as none, so that the default thing is hidden. And then we can add our styles on top of that. For example, I've added a border with a blue color here. So that's how we can improve our focus behavior there. So the very next thing in terms of single page applications like React is we usually think upon showing and hiding stuff, and we don't reload new pages each time a user is traversing our website, right? So there might be an issue that I have a form which is getting mounted onto the DOM, and I want to have focus onto the very first element of that form, and that's not possible otherwise. So we can use refs for that support if you want a programmatic control over what is the tabbing structure that we want to, or what is the focus structure across my website that I want to have. So to get a finer grain of control, we can use ref. I think most of you guys would already know that. So just use the ref, and inside our use effects or component mounts, we can use input ref.current.focus to focus that particular element. All right. We have a lot of forms inside our websites and web apps, right? And it's very important to make them accessible as well. So coming out to accessible forms, it's very important as the first step to using a label whenever we are using any sorts of input form fields. So you can do this while using an HTML4 attribute by giving it some string to the HTML4 in the label, and the same should be the value for the ID inside the input. And that's how that ties them together. Now, how it helps screen readers is screen readers usually hunt for information which is relatable among tabs. So if they encounter an input via tabbing or by any other thing, their input with this ID would be searched in the page, and they would get to know that, hey, what is this input? So this gives them more information. I get this. Let me just not use a label, right? Why is there the need there? So I would visually present inside your input. You can visually hide a label by using any sorts of class name styles. But if it's there in the DOM, it can eventually help screen readers get more information out of that. So do not hide those labels, or do not refrain from using labels. Coming up to the next thing, you can use definitely. So this can let the screen readers know that, hey, there is an input form. This can let the screen readers know, and there is this of this has some violation and some error has occurred for this, and this can give them more context over what the error is, so that it gives people more context who are using screen readers. Again, we come up to the right semantics, right? So don't forget to using inputs and labels when you're field set and legend. So field set is something that you can wrap all your similar sorts of form fields so that the screen readers know that, okay, this is a very visually similar sort of a question that has been asked, or like this is a similar sorts of inputs that are there. So it gives the screen readers a right context about what are things in this particular structure, or are these things related or not. And secondly, each field set can have a legend. So you can have a legend so that the screen readers get this part, that what is all of this particular section all about. Navigation is super important, right, when it comes to people who are using our complex UIs, and like they dig deep down, going through clicking various buttons, various links, and they go deep down into a user interface. And then they might be thinking that, hey, I'm down at some particular web page, and I wanted to go someplace which was like maybe 5 clicks back or something like that, or like 5 pages back. And they might get lost in while like navigating through your web pages. So I recommend using components like breadcrumbs. So breadcrumbs are like really good to give people that visual hierarchy, that where exactly they are in the web page and like in your web apps. So this can really help people navigate things faster when they are navigating through a lot of different web pages inside your code. Another cool tip for navigation is when people are using screen readers Lite, there might be a case that before going to the main content, you might have a nav, or like you might have a lot of links or a lot of other stuff, which someone using a screen reader might not be interested in. He would just want to jump into the main content. And the simple thing for that would be inside your app, you can just have a hidden anchor tag, which just routes you via this href property. It routes you to your main HTML tag. So the screen readers can, like whenever this gets the focus, screen readers can announce the people who are using it that, hey, do you want to skip to the main content, and this is the link that can help you. And like once they click it, they skip all of those different navigations or like different links, and they can come up to this main content directly. So this helps in like improving user interfaces for those people as well. Okay, coming to accessible images, because we also have these inside our web apps, right? So we are like super sure about that, what is there inside SRC when it comes to an IMG tag. But what is the advantage of this alt tag, right? So it gives you two advantages basically. So giving an alt tag helps people who are like not disabled in any way to get the sense of what this image is, even if this image failed to load, if there's a network error or stuff like that. So like they get to know what is that image all about. Secondly, this alt tag is being leveraged by screen readers because like people who are having visual difficulties might not be able to see what is this image. So they get that context with this alt tag. So mention a valid string inside this alt so that screen readers can announce that. Another very fun tip is I have seen like people use a paragraph, and inside a paragraph there is a text, but like that's not a written text. People use images instead of text. So I would say that is not really good in terms of using firstly the semantic HTML, and secondly for screen readers, because it does not give them a right sort of a impression like what this particular section was, like what did I go through, was it a paragraph, was it an image, what was that a card, what was that? So never do that. Like better than images, because I think like if you zoom in an image, it might blur out or like it might just pixelate, but SVGs do not. So SVGs are really better. So we can use like title and description attributes so that screen readers know what is this SVG is all about to the screen readers, because it is one of the main things that they see and like they announce, right? So a very simple solution to this is like whenever we are using any component and like there's a new screen coming in, we update our document titles so that screen readers know the context that there is this new page or like this new screen that has been added up, and this gives more context to them. You can use this is a very fun library called React Document Title. It's like it does the same thing that we have done earlier, but like it gives you a more declarative approach towards like writing JSX for handling these things. So you can use like this document title tag, add all of your JSX for that page inside it, and yeah, this can update this based on a state variable. So that becomes more cleaner approach to do. So with that being said, as I mentioned, it's a really long road because accessibility in itself is a very vast topic, and I've tried to cover. Hope that was useful. because if you see in the long run, there are a ton of more different guidelines, and there's a pool of guidelines that has been defined by WCAG. So for example, like if you're writing a textual content on a website, that should be access your website content. Thirdly, there should be like right and consistent. So that is a very good thing to have. Also, like there should be accessibility on different devices. For example, your screen or like your web app should be easily being usable on a mobile, be it a tablet. A video of a screen recorder announcing and a login form app, which is like not having much of the accessibility practices. And then I'll be showing you the same video of the same form, which I spent like around like 10 that I just mentioned. And so if I run this particular video, yeah, and like that's the issue that I usually face out of with Google Slides. So I already have things ready. So let's just quickly think of let's just quickly hear this recording very well, right?
App web content. Heading level 1. Login form. https://www.winninventory.com/blog/wp-content/uploads/20196/react.js-benefits.jpg image. Enter edit text. One password. Enter secure edit text. Visited link. Learn more. Chrome has new window. Visited link. Contact us. You are currently on a link inside web content. Voiceover.
And I think that was not really good, right? I think you would have noticed that there was an image and like the screen reader announced the whole image URL there, right? And that is like not a very good user experience. Okay, so like after trying our accessibility techniques, right? Let's try to see how things turn up here. Okay, like let's have this in the same video that I have recorded, right? Okay, I go here.
Entering React Good Daily Demo web content. Visited link. Skip to main content. Visited link. Skip to main content. Chrome main. Login form banner image. Image. Enter username. Enter. Enter. Required. Secure edit text. Submit. Button. Visit. Banner image. Image. Enter username.
All right, I think like you'll be able to have now seen the difference here, right? So it's just a very simple, like simple sort that you can do, and you would have noticed a difference. Link to the demos that I had just shown. So like feel free to fiddle out with these links. Also, these are like some of my favorite links onto like if you want to read accessibility, like also like React.js has a docs around accessibility. So do check it out. These links are going to be great. So yeah. And with that being said, let's make web accessible for everyone. Let's make sure that like we at least start with the incremental practice of having accessibility inside our web apps. So that's mostly it. Thanks a lot.
Hey, Nikhil, that was awesome. Thank you. Thank you for sharing the important message of accessibility with us. And the simple demo just really drove the message home. So
Yeah.
I think that was very crucial for people to like really understand what you were trying to say in the rest of your talk. So it was a brilliant talk. I really enjoyed it. Thank you so much. So if any of you have any questions, I think Nikhil will be hanging out in the lounge area. So do go there and connect with him and ask him all of your questions about accessibility. Thank you again, Nikhil. So thank you, everyone. We will see you in the next talk, and stay tuned. Hey everyone. So our next speaker is Milita, who's a fellow woman in tech from Serbia. She loves teaching, mentoring, and supporting women to become successful developers. So all of those things.
React India.
Hi, everyone. So in this talk, I would like to go over all the challenges and share my experience in my journey transitioning from React to React Native applications. And I will talk about how to start building mobile application coming from the web. I will cover all the differences, challenges, and advantages to keep in mind when diving into the native app universe. So a little bit about me. I'm a software engineer with experience working on React and React Native applications. You can also find me on Twitter and Instagram as Milicode. I work in a company Badinsoft in Serbia, located in a city niche with a strong tradition in technology and engineering. So in one of our projects, we needed mobile application for iOS and Android. And to write successful native applications, it needs to be accessible in both platforms, iOS and Android. However, iOS and Android applications are written in completely different languages. So iOS uses Swift or Objective-C and Android uses Java or Kotlin. And we needed to create two separate but identical applications. So, which more often means that having two separate teams in order to develop and maintain them. So it can become increasingly difficult to keep the UI and features in sync on both platforms, maintaining them and pay the engineering team as well, and so on. So instead of having to write the same application multiple times, we can write the one applications and all using React Native. That means that for the most part, we no longer required a deep understanding of Objective-C or Java in order to be an effective mobile developers. Instead, we can use our existing knowledge of React and JavaScript in order to be web developer and to create a cross-platform application. So because of that, we chose to go with React Native. We had faster development, and with single code base, we got two applications for iOS and Android. But it has one more advantage, and that is the usage of React with all of its benefits, including the wide community of web developers. So at first, starting with React Native comes naturally for React developers, and because of all the similarities you have. You will still have components and use components as a building blocks. You will still use state and props and work the same way. And you can still use JSX and your favorite state management like Redux or Context API. But when you start going deeper, you can see the more differences and challenges you have to learn and overcome. So because the mobile development is a whole new world. So let's go over all the differences, challenges, and advantages to keep in mind when diving into the native app universe. When you are developing in React Native, you're also developing for iOS and Android. So you have to set up and get familiar with Xcode and Android Studio. And that is one thing that is different from the web. So for web development, you only need a browser. For web, you're familiar with browser. It's easy to just open a browser and start developing and testing. But when it comes to the native development, you must always think about the platform, both iOS and Android. So you can use the Android emulators, which you can download and run from the Android Studio, or iOS simulators from Xcode. So simulators are good when it comes to testing and building an applications, but they can be wrong in some cases, because simulation can never replicate 100% of the real device. You can find an application working without any error on the simulator and having trouble with an actual device. And in these cases, Android can be trickier because there are a lot more devices you need to cover. You must think also about the screen sizes, and you must think about do you want to support the tablet as well. So advice I can give you is to always test your application on real devices through the development process, especially if you want to release on both platforms, iOS and Android. because we have the cases in our applications when everything was going great and the features are looking good on the simulation, but when you tested on a real device, that was not the case. So this is a great advice, and be sure always to check on the real device through the development process. When you set up your development environment and devices and emulators, the first thing you can notice that there is no HTML tags. So names for elements you will use in React are different in React Native. So where you will use the element like div, section, headers, now in React Native you will use the component view. And where you will use span and paragraph in React, you will now use the text components. Buttons is still buttons, but now you will have options to use the touchable opacity or touchable without feedback or touchable highlight, which is also view, but behaves like a button. So React Native will provide a number of built-in core components ready to use in your applications. So let's look at a simple example of how will that be. So you will import a view and a text from React Native, and that as components you will use instead of the divs and spans to display some text on your application. So text component with React Native will translate a native iOS UI view containing the text, and for the Android it will translate the application with a native text view. So think about that, about the components. Next thing I want to talk about is styling. So styling on the web, you will have a class name and which is associated with a DOM element, and CSS will target the element with a class name and assign a set of properties and values to the associated element. But React Native does not use the CSS for styling. Styling in React Native is done using JavaScript. And since React components have support for the style property, you can also create an object of style and values and pass them on the component as props. The style names work exactly the same way as in the CSS, except they are written in a camel case. But don't worry, Flexbox is still here. So for example, Flexbox works the same way in the CSS with a few exceptions. The flex directions is defaulting to the column instead of the row, and the flex only supports a single number as a parameter. And under the hood, Flexbox is implemented with the Yoga. So one thing also, for styling you can use the popular CSS in JS library, and that is style components. Style components allows you to write an actual CSS code to style your components. And benefits of using the style components is there are CSS syntax out of the box, you have dynamic styling, and you can use theming. And with style components, you can also support more complex styles like transform, and which is really great. So if you're familiar with style components and you have used it on the web before, my advice is to go for it, because you're already familiar, the transition would be much easier for you, and you can just start styling in style components. The next thing I want to talk about is navigation. In a browser world, you will have the URL. You have the current page and a back button for history. You can use React Router to handle the changes and go to the new page. And if you're using React, you're familiar with React Router. And React Native has also support for React Router. But for the navigation, you can still use libraries like React Navigation and React Native Navigation. In the web world, we have screens instead of the, in the mobile world, instead of the web, we have screens. In web, we have pages, and now when we are transitioning from the web, you will use screens. And the navigation between the screens followed with several well-understood patterns like tab navigation, stack navigation, and backstack. How do navigation work? So navigation works like you're having the different decks of cards, where cards are screened. So you define different decks of screens for each purpose. And this is because a user could add or go back to a previous screen. It's important to note that on the native, you start from the first screen defined in the deck, and when you add a screen, it goes to the top of your deck. So when you go back, this goes off to the top of the deck as well. This means that the first screen is loaded in the background till you dismiss the stack or go back. So next thing I want to talk about is platform-specific code. So unlike React Native addresses the need to write a different code for different platforms and build applications that follow platform-specific UI and UX guidelines. React Native offers two alternative ways to build the cross-platform applications more efficiently. First one is the platform module. So React Native provides a module called platform to detect which platform or which version of a platform, if you're developing for Android, the application is currently running. And it's especially useful when you're using components that contain only smart part of the platform-specific code. So you can open platform from React Native, and then you can set some kind of condition to check if the platform is iOS or Android. The other way is to use this platform-specific extension. So React Native will load matching files for a specific platform by automatically detecting whether the file you're working on has a .iOS or .android extension. And in this way, you can be sure that each time you're coding for iOS or Android, React Native will always import the correct and required component. Also, one more thing that you don't have to worry about on the web and that is important to think about when you're working with mobile application is the application state. So user can have the application in the background or user can have it in the foreground. And this is very important because you don't want user putting your application in the background, and when they come back you maybe want to show something or update your state. So user back and forth on your application is very common and you must always think around it. You can use the application state from React Native, so it can tell you if your application state is in the foreground or in the background and notify you when your state changed. With application state, we have three states. Active state, when the application is running in the foreground. We have the background state, when the application is running in the background, and user is either in another application, on the home screen, on another activity. And we have the third state. Third state is inactive state, and this is a state that occurs when transitioning between foreground and background, and during periods of inactivity such as entering the multitasking view or in the event or incoming call. So this is really important, and you can use this state to detect if your user used your application in the foreground and background. Next thing is the native features. So there are many native features mobile has to offer, like push notification or camera. And on the web, though many of those are not used so often, but when you're building an application, you must think of when do you want to ask a user permissions for those or how to handle those permissions for future use of your application. For example, when you're asking for user permission for the camera in order to update the profile picture, you need to have this check every time since the user may have pressed to not give the permission. So also have that in mind. Next thing I want to talk about is connectivity. So this is one of another important thing you have to deal with when user don't have connections or mobile data. So when you open your applications, you don't accept to just close or show nothing at all. You should be able to view some offline cache data and maybe write a message and then have it automatically be sent out when the connections went back. Similarly, you may have cases when users have the slow connections. So maybe you're on a train, on a tunnel or something like that. And you should definitely build timeouts and retries in your applications. And that is something you probably do for the web, but I don't suspect you do it everywhere. And it's definitely worth doing in the mobile applications because the requests will timeout, and if your applications go into the weird inconsistent state, it's not going to be a pleasant experience. One of the cases how LinkedIn application handle this. So I'm currently now having connections, but on the home screen I can see the cache data. And when I open use tab navigation to navigate to the other tab, I can see the message that there's no internet connections, and I have a button to refresh refresh and check if the connection is back. So when you're talking about mobile devices, always think about the network, and you must build your software to support these cases, beginning with connectivity prompts, including some offline methods, like I say, like caching, and be prepared for the possibility of your connection breaking in the middle of the network activity. One advice I can give you in these cases is you can check out the package NetInfo. The NetInfo package provides information about the user's active network connections and connectivity status of their mobile devices, and it also identifies the user's current network type like Wi-Fi or mobile network. So we use this package in our applications, and it's really great. So my advice is to check it, and if you have the cases when you need to check the connection type or quality, this is a great case for using this package. So next thing I want to talk about is sharing code. So if you're building both web and mobile applications, you can leverage some of the code reuse. Converting a React Native applications to React, you can use the React Native app to bring a mobile app to the browser, but it requires some significant modification as well as some adjustments in the user interface. You can share the logic between the mobile and the web, and also make the components and UI independently for each platform. So sharing a code base goes beyond simply reusing code. The React Native process can get really complex, and sometimes it's easier to develop a web and mobile application separately. It all depends on the type of your application you're building and the specific features you want to include. So always think about what you want and how to build, and does it need to be like, can you use the sharing code? Is that the great case for you to go or not? And talking about sharing code, I also need to mention the monorepo. Monorepo allows you to have the multiple projects which share common dependency, instead of installing the dependency for each of them. And they're also simplifying sharing code between your import code from one package to another. Example, some shared code that you wrote. So one of the most popular options is Yarn workspaces, which is great. And one more thing when we're talking about monorepo is Lerna. Lerna is a tool for managing JavaScript projects with multiple packages. Lerna is a really great tool. We have used it on our applications, and my advice is to check it and to see it works for you as well. So what about testing? In the mobile applications, so developers make mistakes, and testing is important because it helps you uncover those mistakes and verifies that your code is working. Perhaps even more importantly, testing ensures that your code continues to work when you're working on a feature or add a new feature, and when you're also refactoring the existing code and upgrading major dependencies in your projects. So default template of React Native ships with Jest testing framework, and you can use Jest to write your test in React Native. So if you write test in the web before, you probably use Jest and you're familiar with that. And there are several libraries that can help you with testing, and that are Renderer, which is developed alongside code and provide objects without depending on the DOM of the native mobile environment. And there is a React Native testing library built on the top of the React Test Renderer and adds fire event and query APIs you can use writing your test. So both libraries are really great, and you can check each of them and see what works best for you. Also, one more thing I want to talk is debugging. So for debugging in the React Native, you can use the Chrome developer tools, and you maybe used it before, so you're maybe familiar with Chrome developer tools. But there's one more thing also I want you to check out, and that is Flipper. Flipper is an extensible mobile application debugger Flipper is a platform for debugging iOS, Android, and React Native applications. It can help you to visualize, inspect, and control your application from a simply desktop interface. And Flipper is a tooling that I strongly recommend for mobile developers, because with Flipper, you will also inherit the plugin ecosystem that exists for native Android and iOS applications. This means that you will be able to use plugins that are aimed for the native application for your React Native application as well. For upload the device logs, the device crash report. You can inspect your network request. You can inspect a device preferences. You can inspect cache images. You can inspect native layout elements and more. So my strongly suggestion is to check Flipper. It really helps us in our application. We use it every day, and it's also one of the great features I love is you can inspect the network request and see if everything is working smoothly. Next thing I want to talk about is deployment. So on the React Native side, we are using the native way of deploying applications. So remember that React Native is only the tool of writing not native applications. So you will have to build and upload your build for iOS on the App Store, for Google to the Google Play Store, and for Huawei on the App Gallery. So after your build is uploaded, for example, Apple will run some automated tests on your applications for some basic info provided for the App Store and let you know if there are some issues. So after everything is okay, you can test your application with other developers. And this is the way you can send an application somewhere for testing without plugging a device on your machine. And it's very important here to note that each deployment will need to pass some validation from Apple. That will take maybe a few days or maybe a week in order for your release to be available to the end users when the testing phase is over. And for the Google, you will use the Google Play Console to publish your applications and maybe games with the Google Play Console. And also the TestFlight provide a great beta testing program. So if you have some tests, your application publishing to the beta testing program, you can use also a TestFlight, which is really great. And also one thing to mention when we're talking about deployment is the Code Push. Code Push is part of the application center. So Code Push is an App Center cloud service that React Native developers can use to deploy mobile applications updates directly to their user devices. So Code Push is really great. We use it in our applications, and you can use it in the cases when your testers need some bug fix to check out and some features. So you can use the Code Push to push directly to your tester device, and you don't need to check the build process. So you can use the Code Push. So that will be all. Thank you so much. I hope that my talk will help people moving from the web world to the mobile, and I help you and share my tips that were useful from my experience. You can check me and contact me on Twitter and Instagram as Millicode, and that will be all for me.
Hey, thank you so much. That was a really nice talk. It was great to, see side by side the comparisons and the differences. So I'm a React developer. I've not really, ventured into the native world. So it was really nice to see this comparison, and it made the process so much simpler. I was like, okay, I can use React Router. Wow! So things like that was super useful. So thank you so much. It was a lovely talk, and thank you for everything that you do to support women in teaching and mentoring. I think that's very inspiring. Thank you.
Thank you for having me.
So if you have any questions, please head over to the lounge area. You can connect with Melita over there, and she will share more insights with you. So stay tuned until our next talk, everyone. See you.
See you. Bye.
Hey everyone, welcome back. So our very next speaker is Trishul Goel. So he is going to talk to us about micro front ends. So it's a topic of interest to me, and I see a lot of teams adopting it, and it's getting popular by the day. So I'm really excited to learn more about it from him. But before that, there are some fun facts about Trishul that I learned. I just definitely have to share it because it just blew my mind. So he was actually a chef before he ventured into the world of technology and software development. So I'm sure there's a really cool career transition story in there somewhere that I would love to hear at some point. And also he does these cross-country motorcycle rides. I was like, what? That is so cool. So let's give a very warm welcome to Trishul Goel. Over to you, Trishul.
Hello, everyone. I'm Trishul. I'm principal engineer at Westwing. By the day, I do some e-commerce architecture for Westwing, and by night, I volunteer for Mozilla. And today, I'll be talking about destructuring front-end monoliths with micro front-ends. So what is a monolith? Okay, monolithic application is designed to be self-contained components of programs are interconnected and interdependent. So the monolithic application as all-in-one solution. So right from databases, UI components, everything is in a single code base. So in modern world, we already broke this into backend and the front end. And backend is furthermore divided into microservices. So by the evolution of JavaScript, we are already having lots of code in front end. All the business logic are residing in the front end. And now what we have is something called as front end monolith. And with this same monolithic architecture, we are having the same problems of monolithic back and front end. Like all code is in a single place. So whatever we write is in the single code base. So with all the code comes the more complexities. Increasing size of repo every day. Each feature we build, more and more code is being put into the same code base. All the teams are working on the same code base. So inter-team dependencies is increasing. So with the inter-team dependencies, we increase the friction between the teams. And all in all, putting together, we have a slow development to deploy cycle. For a feature to the cycle of development to deploy increases. And on top of that, if we put everything together, we are only strong as the weakest link. So if any team breaks anything, we cannot deploy anything to the production. We have to fix everything, and then only the other teams can move on there with deployment. Micro frontend architecture is a design pattern where monolithic frontend app is destructured into small independent apps. These micro apps are stitched together as a single page on the fly. So consider what we are doing essentially here is a huge piece of code, and we are breaking it into small bits and pieces. So each micro frontend is capable of running on its own. each micro frontend has independent repository. So there is no direct code dependencies between the micro frontends. Each micro frontend has its own code base, so they can follow their own rules, own code structure, and whatever. Each micro frontend have independent CI pipelines. So different test suits, we can write different testing algorithms, we can write different deployment script, whatever suits to the micro frontend. And finally, we have independent deployments. So this is the main reason we move towards the micro frontend. It's to unblock the deployments of different teams. Just give me a second. Oh, slide. I'll try to reshare my screen just in case. Finally, we can have independent deployments. So finally, we can have independent deployments. So this helps us to move all the team individually. So one team breaks something, it's their cup of tea. So fix that, and it will not block other teams. So all in all, putting this together again, we have parallel development cycle. So all the teams can move parallelly, and each team can move with their own pace. They do not need to depend on the other teams for blocking or moving ahead. It's again breaking. Okay, it takes a bit time maybe. Okay, so let's have a look at the architecture of the micro frontends. Okay, it's still breaking, I can see. Sorry for the trouble. I'll try to reshare this one again. Okay, let's get back to the architecture. So consider this. There's a host, and there are different micro frontends, let's say 1, 2, 3. And so host does not need to care these remote 1, 2, 3 were compiled or served. All it needs a remote URL, which it can consume to build itself up. So let's have a look what we did at Westwing. I think the slides are still broken. Let me reconnect. Maybe that would help. Okay, sorry for the bother. I think this should work now. So consider this e-commerce website. So this is what e-commerce website. We have a small shop. So part of the shop, we have some homepage, product listing page, details page, cart page, checkout page, and header and footer. So this is an ideal e-commerce website. So in a monolithic world, all these code are in the same code base. So the cart team and product listing page team is working on the same code base. So if they have to deploy any feature, they have to coordinate with all the teams, like, okay, everything is working or not. And if anything is is not confident from all the teams, they have everything is getting fixed. But in micro frontend world, each of this page is in its own micro frontend. So the cart team has its own micro frontend, product listing page has its own micro frontend, payments have its own micro frontend. So they do not need to bother about what other teams are doing, and individually can move with their own pace. So in Westwing, we have created these micro frontends, and not only on the code part, but on the team division part also, this follows. They follow the same structure. And then all these micro frontends are exposed, and then all these micro frontends are consumed by something we call as app shell, basically the host. So the host contains header and the footer, and whenever the request is made, let's say homepage. So what the host does, gets a header and the footer and imports homepage micro frontend and builds the page on the fly and serve it to the user. So for users, still is the same website, but for the code, from the code perspective, it's coming from two different systems. So this is how we consume app shell and micro frontend. So along with the app shell, along with the header and the footer in the app shell, we thought that let's put some shared business logic into the app shell. So we have lots of shared business logic which is needed throughout the micro frontends. So we thought that let's put it in the app shell so that we do not need to repeat this stuff again throughout the micro frontend system. So the first thing which we put in app shell was to know if the user was logged in or not, or what's the login state, let's say username, email, or some data about the user. They get it from the app shell. We do not need to spill out these out in all the micro frontends and just get it. The next thing which we put there was tracking. We housed all the tracking into the app shell. For example, Google tracking, Facebook tracking, or whatsoever tracking we want to implement. We implement only in one place, that is app shell. So it's maintainable and easily available for all the micro frontends. All micro frontends need to do is send signals to app shell, and app shell will decide where it needs to be going. Maybe internal tracking or GA or whatsoever. So this gives us more hold over the tracking, yet it is distributed throughout the system. The next thing we put was system config. So we put all the configs into the app shell, and micro frontend does not need to care about where the config is coming from. All it gets the value and utilizes it. For example, the remote URLs, the configurable hyperlinks, and so on. And the final thing which we put in app shell was the routing. So app shell is responsible for all the routing. And that kind of makes sense because app shell has header in the footer. So app shell should know which packet needs to be served. For example, if a request is made to the cart, so app shell should decide like which micro frontend it's consuming. And even if some of the pages require routing, we expose a function to micro frontend with which they can handle the routing, but still it will be handled by the app shell. The micro frontend will just pass some parameters. So this made sure that we have all the required stuff in app shell, but still it is available to the micro frontends. So as we see, we have lots of data transfer between app shell and the micro frontend. So we need to have a very proper communication between them. So we have to establish a very dependable and straightforward way in which app shell and micro frontend can communicate with each other. And even more, some micro frontends need to communicate with each other. So let's see how we try to solve that problem. So broadly, there were two ways. One way, like if we follow the same tech stack, let's say React and React. Micro frontends are in React and app shell is in React. So this is very straightforward. All we need to do is pass the data via props. It can be an object, it can be a function, or whatsoever. So this is pretty straightforward. But what if we don't have a same tech stack? Let's say app shell is in React and the micro frontends are in Vue.js. We cannot share the data with the browser. So for this, we exploited our basic JavaScript functionality, something called as custom DOM events. So custom DOM events are technology agnostic. It resides in your browser and it can be invoked by just plain JavaScript. So this is available to all tech stack and can be used by anyone. So let's have a look at sample custom DOM events. So this is how we create a custom DOM event. It is like any other event, like for example, click event. You need to add an event listener and define your custom event name. And all you need to do is attach a callback. So this is how you subscribe to this custom event. And dispatching a custom event is again pretty straightforward. All you need to do is create a new instance of custom event, put your custom event name, and put some data. Once custom event is ready, all you need to do is dispatch. Once this custom event is dispatched, whosoever is subscribing to this event will listen to it and eventually do what, in this case, just consoling the custom data. So this enabled us to set between app shell and micro frontends. So this solved our communication problem completely. So with this, we kind of have an overview of architecture of micro frontend, what we were planning to do at Westwing. Now let's have a look how we actually implemented this one. So we followed some traditional approach. At first, we thought, can we do it with iframe? And very soon we realized, no, we cannot. It is really not performant and really not maintainable. So the next thing which we thought was node modules. And for a while, we tried this with node modules. So the remote components were kind of remote module, node modules, and we exposed them and consumed them into the app shell. It was working fine, but again, we are having the same problem, like dependent deployment. To update the node module, you need to update the app shell and redeploy it. So again, we are tying the deployment of micro frontends and app shell, which was not ideal for us. With Webpack 5, we have module federation, and this was answer to all our problems. So with module federation, Webpack can actually reference a remote module which need not to be present at or not present or even not known at the compile time of the host. All module federation does is pass a reference, and based on that reference, the host compiles the whole code. And when this whole compiled code runs at the runtime, then the modules are loaded from the remote, and that can be available as if it was a native module to the system. So how do we do that? So consider this. There's a host and 3, let's say, remotes. So these remotes basically compile their code irrespective of the host. And the compilation process is independent and individual, and they just expose the packages to, let's say, S3 or any remote location. And when host compiles, it just needs a reference with module Webpack Federation Webpack plugin that, okay, there is a remote. It will be available at the runtime, but right now I don't need it. And when the host boots up, it checks the remote location, downloads the package, and put all the reference in places, and basically it's ready to load the website. Now let's have a dig into the code. So consider this a very small component. It's a simple component running just S3 and putting a prop title into the code. So let's expose this component. So how will we do that? So in Webpack config of remote, all you need to do is add a module federation plugin, define a namespace for this remote, and define a file which is called as remote entry. This can be any name, but remote entry is by convention. So what this file is basically metadata of all the remote. So all the packages, all the chunks which will be available from the remote or required for running this specific component will be available here. So host will only look for this file, and this file basically will tell host what all packages you need to run this component. And finally, we need to expose the component. So we expose the main component and in the main namespace. And in addition, we have some shared libraries. So this is the good part of module federation. Actually, this could be a problem, but module federation takes care of it. So while building remote and host separately, we use React. So we do not need to load two Reacts in the same browser, which is totally not ideal. So here we can define like this will be shared. So you do not need to load React and React DOM on your own, but you can get it from the shared, shared from the host. So this actually makes sure that only one version of React or whatsoever library you want to share is into the scope of the browser. Okay, so this is how we expose the remote in module federation. Now let's check how the host will consume this one. So this is very simple config which we put into the Webpack config of the host. And here we define the namespace of the host, and then we define the remotes. What all remotes will be available for this, this host. So this is the namespace which we use to expose the remote module. And this is the actual remote address where the remote entry file will be there. And again, we can define the shared modules, shared libraries, which will be available, which will be loaded from the app shell and will be available to the remotes. Okay, so till now, we already bridged the connection, like remote is exposing a module, host is consuming a module. Let's see how this is consumed within the code. So it is really this simple. All you need to do is import it as if it was from Node modules. So this is the remote namespace, and this is the expose component namespace. And this remote app can be used as any other React component into the code. And you can pass the data, the props, or anything. So all the magic lies into the module federation plugin. And once that is set up, it is really, you don't have to change literally anything into the code, as if it was natively present into the host app. Okay, now let's try to check if this really works. I will try to demo this. I have created a small demo, and hopefully this works. Let's check it out if it works or not. So, can someone confirm if still you guys can see my screen, the code screen? Awesome. So here's a project. I created host and remote. So let's have a look at the remote project first. So let's have a look at config file. So for Webpack, we have this module federation. And as explained, it has a remote namespace. It has a remote entry file. And it exposed a component called a shared component. And it shares some libraries. Let's have a look at this shared component. It's a very simple component. It's a very simple component. It's a H4 and it renders current count, and there's a counter variable. So this counter variable is passed as a prop, and whatever is passed as a prop, it will just render it. And on the remote, we just consume it as a normal component. We pass a count1 and render it into an app. So let's quickly run it and try. Meanwhile, it builds. Let's have a look at the host app. So host app again has Webpack config. And it is having the namespace and defining a remote, which is remote 1. And it's expecting a remote entry on 3002 port. So let's check our 3002 already. I think it's built. Give me a second. Okay, so we can already see our remote app running. And there is this shared component, which is passing the current count 1, because in remote app, we put this count 1. Let's make it count 2 maybe, and let's check. This is count 2. This is totally working on the remote side. For the host, we already saw we included the module federation plugin. It is defining that it will get the local host, it will get the remote entry from localhost 3002. And let's quickly check this remote entry file. So it's basically just a metadata file of all the components which we are having here, and that can be used. So let's check how it is being included in our host app. In host app, all I need to do is just pass the namespace of remote and the expose component. And then remote component can be used like anything. So if you see, we have a remote component which consumes a variable counter. And counter is a state variable. This state variable is present into the host. It has nothing to do with the remote. So let's run this one and check if this works the way we expect. So just to give you context, this counter, what we are doing is we have a click button. Whenever we click the button, it just increases the count. Nothing fancy, just to show that it is functional component. So let's go at okay. So now we see this. We are using the same shared component as we were using it here, but the current count is 0 because the data pass was 0, and this shared component is being served from remote. And when we use it, it is as if it was the native component of this host app. Has all the shared data, whatever we need to do. Just to elaborate this one, let's have a look at the network call. I'll just increase the font in case it's not very clear. So let's have a look at our file remote entry. So this remote entry has been served from 3002, basically this server, and all the components which is required for this are loaded from the remote entry. So basically, whatever is being run here is not present in the code base of host. It is being served from remote. So this is what we can do with module federation. Okay, so this was the demo, and I guess this works. So let's get back to our slides. Okay, so this was all about micro frontends, how we kind of thought of the idea, how we try to implement it, and everything looks very good on paper, but when we try to implement it, it was not the piece of the cake. So we faced some challenges, some small, some big, but I'd like to share some of the challenges which we faced. The first challenge we faced was design consistency. So since we are splitting the code into multiple repositories, it's super hard, super easy to kind of go away with the design pattern and maybe have different components having the different designs. So to make sure that we have the same design throughout our system, we implemented something called as UI kit. So we put all the UI components into a node module called as UI kit. And whenever a micro frontend or app shell has to use any UI component, they just import it from this UI kit. Even if it's not in UI kit, they need to implement it in UI kit and then use it from there, so that the next micro frontend which is using, they will be using it from the UI kit. So this makes sure that wherever, let's say, action button is on the website, even if it's coming from different micro frontend, it will be the same throughout. This also helps us to keep the same theme consistency throughout our website. The next one which we faced the problem was initializing a new micro frontend. It doesn't sound that it will be big, but when we try to implement it, it was super big. Because with each micro frontend, we have Docker setup, we have CI pipeline script, we have S3 publishing script, we have Kubernetes setup and whatnot. And all in all, we have to write the end-to-end test and for everything. So doing this for every micro frontend was really a pain because it's too much redundant work. So what we come up with was templating engine Temporeto. So what we did, we used this templating engine so that we can put all the required things into one template. And whenever we want to initiate a new micro frontend, all we need to do is use this template. And this template is kind enough to build the whole system for us and create a new repository for us. So in practicality, it looks something like this. So I'm not sure if it's super readable, but I can explain. So what I'm doing is we have this template repository where we have multiple templates. So all you need to do is basically create using this template, and it gives us option of different templates, which we already created. So one of these template is micro frontend template. So this template has everything. And to build up, we can also pass some variables, like for example, the name of micro frontend, some identifier, some description. And based on this, it spins up the whole template. So the output of this command will be a complete setup repository, which has all the Docker setup, CI setup, all the Kubernetes setup, all the end-to-end tests, all the code structure, and most importantly, all the Webpack config the way we want. So this helps us to initiate micro frontend literally under a minute with all the goodies which we want. And add-on point to this one is it just not helps us to create, but also to maintain the templates. So all the micro frontends created are kind of bind with this Temperator templating engine. So for example, we have a requirement that, okay, now we have a new testing script. We want to have visual regression tests in all our micro frontends. So it's really kind of not optimal to go to each micro frontend and ask them to implement this whole system, because it can be inconsistent and obviously it's a redundant work. So Temperator again comes to save our day. So what we can do is we can update the template with the required changes. For example, implementing scripts and Jenkins scripts for, let's say, visual regression. And all the micro frontends just need to do is update their template. And out of the box, they will get everything, whatever the template has the change. And this templating engine basically follows Git diff. So that should be, that can be easily handled. So this was a complete solution for our all problems which are having generating a new micro frontend. The next one was decoupling code from app shell. So instead of creating a new app shell, what we did, we named our monolithic app into the app shell. And one by one, we try to remove the code from app shell. So in this perspective, the first thing we do is like moving components to the design system. The design system we created, first we created the components there, and one by one, we moved the code to the design system. But yeah, it was a lot of work. And then we have to, then we have some shared logic between micro frontend. So for example, we have a price formatting logic. So we are multi-country e-commerce website. So we have different price formats for different countries. And this logic has to be kind of implemented in various parts of the website. For example, cart, product listing page, detail page, everywhere we have to show the same price in the same format, I mean. So this is a pretty static logic, and rewriting in different micro frontends will really kind of flaky. So what we did, we exposed some node modules. Basically, we created our small NPM libraries where we exported this static logic. And all the micro frontends, whosoever wants to format the price, they just import this logic, and we get the same functionality out of the box for everyone. So we ported some more static logic so that the micro frontends do not need to re-implement this one and just can import one. And these logics are kind of very not dynamic because they don't change over the time. If they change, it's really kind of very, very rare. So it's safe to put in, let's say, NPM repository. And the last one which we faced was building an efficient developer experience. So with the micro frontend system, the very first iteration, how we ran this one was ran all the micro frontends and app shell on your local system. So you have to boost literally 3 or 4 node processes just to make sure that all the website is running. So you have 3 micro frontends and 1 app shell. So you run all the different repositories and make sure that everything is working together, which is not ideal, because if you want to work on just 1 micro frontend, it's really not optimal. So what we did is we have a Docker-based approach. So we know that we only need to pass a remote URL. So in a Docker image we created for app shell, we accepted all the remote URL from staging. And in addition, with the URL, we parameterize these URLs. So any URL can be passed via environment variable. So when you want to run on your local machine, so all you need to do is run your local instance for micro frontend you are using, let's say localhost 3002, and pass this URL into the node in the environment variable of this Docker image and boost up your Docker. So this will run every other system from staging, but your micro frontend from the local. So that's pretty relief for our developers and boost our productivity a bit. So with this is all I can share about micro frontends, what we did in our West Wing. With the micro frontends, the experience we have is like our team velocity has increased, our developers are happy, our PMs are happy, our stakeholders are happy. We are still far from done. We are learning day by day, but we can say totally that all the efforts we did in past 6 months or maybe 8 months, it's totally worth it. So with that, thank you, everyone.
Hey, Trishul, thank you for that great talk. So I think my favorite part on it was the challenges that you shared, because I feel like it's just pure gold, because anybody who is thinking about adopting micro front-end architecture will gain this input from your experience, right? Which you've learned the hard way. You're just literally giving it to them on a platter, saying, hey, consider these before you just jump onto this architecture without really thinking it through. So I think that was amazing. Thank you so much. So I think we have a couple of questions. If you look at the Q&A, I think the first one was about sharing framework libraries, but I think you've already addressed that with the Module Federation plugin. The other one was about sharing TypeScript typings in the app shell.
Yeah, that's again one of the challenges we face. So what we did is like when you share the things via props, I mean, obviously we will not share the types. So what we did is like whenever we published anything in the app shell, we created a TypeScript pack. We created an npm package for types only. So this is into our build script of app shell. Whenever something changes into the app shell, we update these packages. And all the micro frontends using this can just import this package and be sure like what is the type of the data which will be available. And just not about the data which we are passing via props, but it also comes handy for the custom events, because in custom events, you really need to know like what you're publishing is being accepted by the app shell or not. So if it is typed, that really helps us to make sure that everything which we are kind of using is accepted by the app shell. So just create another npm module for the types that kind of helped our typing in the whole micro frontend system.
Awesome. So I guess there are a bunch of questions pouring in. I will let you pick one more, and then the rest I think we can handle in the lounge for lack of time.
Sorry for the glitch which we had. I don't know what the browsers are.
Technical troubles
yeah,
out of our control. So
okay, so I can take this one. What is being used for the remote shared components? Any external library or pure Webpack config? So this is totally on the Webpack. We do not need any extra overhead on the config side. All you need to do is implement Webpack Module Federation plugin in your remote, and the Webpack Module Federation plugin, the counterpart of that in host. So all the connectivity is done by Module Federation itself. So you really do not need to put any effort there. All you need to do is make sure that you are using at least Webpack 5.
awesome. All right. So I think there are a lot more questions. So everyone just head over to the lounge, and Trishul is going to head there as well. So you can connect with them and get more dedicated answers. Thank you again, Trishul, for the amazing talk. So, all right, everyone, until our next speaker joins us, stay tuned.
Thank you, everyone. Bye-bye.
All right. So our next speaker is here, and it's Sanjali, who's going to talk to us about building decentralized apps for Web3 in React, which is a very niche, a very interesting topic in the current times. Because if you see Twitter, like everybody's talking about Web3 and all of building apps with the latest technology. So I'm personally very interested to learn more about it. So a fun fact about Sanjali is, she's really all for sustainable living, and she's gradually adopting a plant-based lifestyle, which is cool because I have that in common with her. Like I've been having a plant-based lifestyle for over 3 years, so it's like cool coincidence. We're going to chat about this afterwards for sure. So also this is Sanjali's first big conference talk, so let's give a very, very warm welcome to her. Over to you, Sanjali.
Thank you, Anushri, for such a lovely introduction. So I'll just start sharing my screen and get into it. I think you've shared pretty much everything about me. So I hope everyone can see my screen. Just a quick words about myself. I've been working as a software developer majorly using JavaScript for the last 7 years, and I recently, from past 3 years, I've been working into React, and it's very fascinating. We all know it. That's the common thing which binds us here. So today I'm going to explain about how we can create React applications which connect to Web3 backends. Just a quick summary of the talk, like what all I'm going to cover here. First thing, I'll just explain what is Web3 and why do we really need it at the first place. What is the reason behind making this shift from Web 2 to Web 3? I'll explain a bit about the blockchain and the things involved, like all these tech stack involved in a Web3 application. I'll also explain the architecture of an application, because without that, I think we won't be understanding it as a whole. After that, I'll cover maybe a little bit on the backend, and then I'll also tell you how a React application can connect to the backend. And later we'll just discuss a bit about what is in the future for a Web3 app and all those things. So let's just dive into it. And I'd like to start with a little story here. So I think around 2005 or 6, and I was in, I think, 7th or 8th standard, and my geography teacher gave me a project to collect information about various types of soil patterns in India. And all I did was I went to the internet and I searched about that, and I got a load of information, like a lot of pages which had so many information. It was boring as well to read. But I somehow finished my project, and that was the time. Like connecting to the internet was an issue. I can still that sound of connecting to a dial-up internet connection through our big boxes of computers, it's still there in my mind. So that was the early stages of web, where the content, it was just they were serving just static HTML pages. And later on, like as we moved on, there were more interaction involved in the web, and we started calling them web applications. This is the time of Orkut and Facebook and those those nostalgic times. And then the web kind of became more interactive, and we started to see like phones which could connect to the internet. They could stay connected to the internet, and there were so many applications which were coming which could cater to phones specifically. All this was possible because till this time it was easy to host applications on the internet because of cloud, like the advent of cloud, and we could actually rent the servers, and it was becoming like very inexpensive to create our own applications. So this was, and then this was the time of social media as well, where like a lot of business models emerged which were based on social media. So this was like the time of Web 2.0, where most of the innovations were in the form of mobile and cloud and social media. But we are already excited. We were excited to connect to people through just sitting at our home. But then there was a problem there, which people started noticing after a long time. The problem was our data was not ours to control. The data was kind of being stored in huge servers and the data centers which were controlled by just one man or some people actually. And we could actually we saw many security breach cases over the past just because the entire data, like everyone's data, was actually controlled by just few private tech giants. So I think we all must have watched the movie The Social Dilemma, and I personally kind of stayed off the grid for like 2 whole days, but then I had to come back because you can't stay like that. So how do we solve it? Like people, then we start like there were people who started to think we should take the control out of just some people and it should be distributed. People should be rightfully able to own their own data, have control over their data. Then that is when the talks of Web3, like a shift in the paradigm. This is a shift because these applications are like very different than our usual applications. So this is like an entire new generation of the web, and it's kind of a leap to more open, trustless, and permissionless networks. What does this mean is like, what do you mean by open? I'll just explain these 3 terms. Open means the applications which are built for a Web3 platform, their source code is open. They are open for everyone to see. All the developers or anyone can actually look into the code and see what is happening. It is trustless because the nodes communicating through this application on a Web3, they don't have to trust a third party for their data storage and those things. Like they can directly communicate. There's no third party involved. And the third one is permissionless. Permissionless means when there are applications which are built on Web3, they are not censored, or they cannot be censored or governed by anybody. So that's why these are like more open, trustless, and permissionless applications. But how is it all possible? This is possible because the data is not centralized to one system. The data is built, the applications are built on a decentralized data network. So the data is spread across the network. And hence the applications which are built on a Web3 are called decentralized applications. So yeah, I've covered like why we actually need it. So just a quick word, because we want users to have a control of their own data. And actually the users could use their data to barter their data in exchange of some kind of money or any currency. So we all will become the part of the data economy and not just the few people. So that is the motivation behind the Web 3.0 shift. And yeah, so this is like the evolution which has happened. We got Facebook and Uber and those applications which were based on a central server, and then now we have Bitcoin and Ethereum and those things. So yeah, and you can see like the value they've created has the graph is going up. So this is the evolution. And yeah, so I've explained why Web3, what is it, but obviously we want to know what is the tech behind it. We all are like tech people, right? So before I go to explaining the entire model to you, I would like to cover some of these big words which are being used for any Web3 application, which I like to call Web3 vocab. And the first one, everyone could guess it. It's blockchain. So what is a blockchain? Blockchain is like a distributed data network. It's controlled by everyone in the network, like a peer-to-peer data network. And the data in a blockchain cannot be changed by anyone randomly. The data, if you want to change some data on the blockchain, you have to get the consensus of everyone involved in the network, which makes it difficult to change the data in a blockchain. So this is how like the data is spread across across the network. But what exactly are these words? So block is like an entity which stores your data, And why chain? Because they are all connected in the form of a big chain. So a block in a blockchain knows about the block which is before it and the block which is after it. So that is why it's called a blockchain. And the apps which are working on blockchain are generally working on an Ethereum blockchain. So what is Ethereum? Ethereum is a platform for running these decentralized applications. They are written in Solidity. I'm going to cover this in some time. Solidity is a language in which these applications are written, and Ethereum understands this language. So that is Ethereum, like a platform to run your application. And how does it? So there's this thing called Ethereum Virtual Machine, which is like a large global state machine. It stores the state of the entire blockchain, and whoever wants to execute something, they want to execute it. They have to connect to the EVM and then execute their code. And after the execution of the code, the state of the EVM changes, and it's broadcasted to all the nodes connected to the blockchain. So I know this is not very clear right now, but when we go further, you'll be able to put everything together. So as of now, just remember that these are the entities which are involved. Okay, so the last one is smart contracts. So we know, okay, we have some code, it runs on a platform and everything, but how? Because in our normal applications, we have APIs, right? We have services. We connect to those services and we execute the code. In a Web3 application, those APIs are kind of replaced by smart contracts. They are written, like I've mentioned, in a language called Solidity. And anyone who wants to execute some code, they have to write a smart contract, and then through their front end, they can call any smart contract and execute the code. So yeah, that is smart contracts. And the code of smart contracts is stored in blockchain. So it's kind of distributed across the blocks. And yeah, so that is smart contracts. And this is just a small diagram of how a blockchain technology would work. So whenever a computer requests a transaction, it is broadcasted to a peer-to-peer network that consists of other computers, like the blockchain. So when the transaction is broadcasted, one of the nodes picks up the transaction, tries to execute it, but it tries to verify it first. So after the execution, there is a verification stage where, because all the nodes are connected, right? And every node has to be involved, like every node has to know the state of the blockchain. So there has to be a verification that, okay, this is a correct transaction. And then when it is verified, all the nodes change their state according to the new transaction. And that is how like the transaction is stored. And after that, the new block of the transaction is added and the transaction is finished. Now, so then just a bit, I'll just take a little bit of detour and cover this part. Like we have these cryptocurrencies and Bitcoins. So how do they work? What is a Bitcoin mining basically? So whenever there's a transaction request submitted to a Bitcoin blockchain, there are people who want to who verify this transaction. Why do we have specialized people? Because this type of transaction verification takes huge computing resources. And they have to kind of solve a puzzle to verify to validate the transaction, and they have to submit this thing called proof of work. So when the transaction is verified, they submit it to the blockchain that, okay, this is correct, this is the proof, and update your state. So the people who are doing this, they need some reward, right? Who are validating your transactions. So they kind of get Bitcoins, and they are called miners. So you can earn Bitcoins in say 2 ways. One is mine the Bitcoins, which requires huge resources and time and everything, or buy it from someone who has already mined it. So this is how the Bitcoin thing works. Yeah, so they mine, they validate the transaction, and then it is added to the blockchain, and everyone update themselves, their data according to the new blockchain, the block. So yeah, this is how the blockchain technology would be working. Now, what exactly are DApps? Now we have covered some bits and pieces and all those things. So DApps are those decentralized applications which are built on a data network, which is peer-to-peer network, not a centralized network, centralized entity. The backend of those dApps consists of smart contracts which run on a blockchain, and the front end front end can be anything, like we generally use JavaScript, so Angular or React or anything can be used to connect to these. I'm going to explain how this is going to happen, but these are the decentralized applications. Okay, so I know, I mean, for me, it was very difficult to imagine how the architecture of a dApp would be. But I found a really good article. I have the links after the talk at the end, where they've explained it very nicely, like how a dApp application would look like. So let me first start with reading something from the blockchain. Reading means you want to connect to the blockchain and you want to read the data from the smart contracts. This is the entire smart contracts, EVM, like Ethereum block, virtual machine and blocks. This consists of the Ethereum blockchain. We connect to the Ethereum blockchain. And so when you're giving a request to read something, right, from your front end, now we know that every node in the blockchain stores the state of the entire blockchain. What that means is that when you want to read something from the blockchain, if you just connect to one of the nodes of the blockchain, your task will be done, because then you can just read the data. So there are two things in this. Either you yourself become a node, like you make your computer the node of the blockchain. But what are the requirements for a computer to be a node of the blockchain? It should be able to store the state of the entire blockchain, right? But what like, do you think your computers are that much powerful like your normal laptop? It's very difficult to manage this entire big blockchain on your general laptops, right? So the better way is to connect to an already existing node and send request to that node to fetch you the data or execute the smart contracts on your behalf. So that is when these providers come into picture. These have connection to nodes in the blockchain. You just get connected to the provider and your request will go through the provider to the blockchain and the data will come back. And that happens through an RPC mechanism. Like the smart contracts give you a way to connect to the blockchain through JSON RPC. So now we are able to read the data. Cool. Now, what is the problem? The problem is writing. Writing the data to a blockchain is not very easy. The reason is, first, whenever you want to put something in the blockchain, you have to encrypt it. It should be encrypted by some kind of signing authority, and then only the encrypted data could be put into the blockchain. First thing. Second, when you want to change something in the blockchain, you will have to pay some fee. Like I've mentioned earlier, right? There are people who are actually validating your transactions and they earn money. So you kind of pay some fee to them or in general to the network when you want to update the state of the blockchain. So there are like these two complexities. What does that mean? That every time you want your user, like your user wants to write something in the blockchain, your user will have to pay some fee, which is not a very good user experience, right? So there are two things which, so these are the two problems, right? The problem of signing your transaction is taken care by this guy called MetaMask. So what is MetaMask? It's kind of, it's a, it's like a browser extension connecting to a blockchain directly. So we install this MetaMask extension, which takes care of signing your transaction and then putting it, forwarding it to a provider. So we have MetaMask to take care of that. It creates a private key for you, and whenever you're sending a transaction, a write transaction, it will sign it for you and it goes from there. So, signing thing is taken care of. MetaMask also works as a provider for the same reason that it is connect for the encryption mechanism. It is connecting to the blockchain, right? It has the connection to one of the nodes, so that's why you can use it as a provider as well. Of writing data, so you want to save the, so that means that the user should not, like, we want our apps to not change the data for every write in the main blockchain. So what do we do? Data in an external file system. Of decentralization, right? So there's this file system called IPFS. So the full form is Interplanetary File System. Storing the data, it's just storing the address of the data and the data is in another decentralized system. And writing to this IPFS is not going to cost you anything. So this is how we have the cost thing is taken care of. Okay, so we are able to write the data, we are able to read the data. Now, what is this thing here, graph? Well, this is a tool to query from your blockchain network. Like we have for us, like in our normal applications, we have these SQL query languages, right? Here we have the graph, which works on the GraphQL, and this indexes your smart contracts. So whenever you want to connect to a smart contract and get data, you can just, like how the indexes work, you can store the indexes and contact the smart contract. Okay, so we can query the data through this. Then there's this one thing. We haven't dealt with the scalability issue, because what do you think? Like, storing the data in blockchain can scale, like can become very expensive very fast. So you don't want to store everything on your huge blockchain. So then comes this thing called, like, this idea where the applications do not directly interact with blockchain. What they do is they've created a sidechain. Intervals update the blockchain. This is like very simplified explanation. So that way we are not connecting to this huge blockchain all the time. So it kind of takes care of the, when your user base increases, it takes care of the scalability. And one of those providers is called Polygon. And this is what we have here. So your front end will to the Polygon, and the Polygon will connect to. I think this is all coming together. Whenever there is a write request, the signer will sign it. The provider will connect to the blockchain, the smart contract, and put it there. It will store the data here. The hash will be stored in the smart contract. You can query the data through this graph and scale it through the side chains. Cool. So I think this is a very basic architecture of a decentralized application. And yeah, and now we know, okay, this is the architecture, this is how it is going to be, but we are here for the code, right? So let me show you the code, and I'll start with the smart contract. I have it here. Yeah, this is my smart contract. So I think most of the when we think of blockchain and those things, but and you will get many examples which are of code which is doing these things. When I was actually reading about these things, I had this huge confusion. I get it, this blockchain is very, like, financial applications are cool, you can make payment through the these applications, and like it's you can create an exchange of these bitcoins and the cryptocurrency. But since it is like a new generation of the web, there has to be applications which are not financial, like our normal day-to-day applications, right? How are they going to deal? Because what I thought was these blockchains just store the data of transaction, but that's not true. The blockchains can also store your smart contracts and code. So this is like a very basic to-do app which we all make, like when we are learning something new. The first thing I made when I was learning React was a to-do app. So this is like very basic to-do app. We'll be able to create the to-dos and list them in our front end. So this is the smart contract for that. So this SOL is the extension for Solidity. We are using the Solidity programming language. Contract is the keyword they use to define any kind of contract. Then this is like public. They also, like in Solidity also, you have access modifiers. Public is something which is used to create public properties, and they will have public getters and setters like we have in our normal object-oriented languages. So this is the task count, and then there is a struct like we have in our normal languages like Java. So this is a struct which will have ID, content, and like whether the task is completed or not. And there's a mapping between the ID and the task. Then we have a constructor similar to normal Java.NET. Then we are also exposing two functions, which is create task and toggle completed. So these are the functions which will be called from our front end, because we'll be able to call these functions from the front end and create tasks. And when the task is created, this function emits an event which we define here. So this is like the task created event, and we'll get all the data related to the task. So how we send a response, right, from our APIs to a front end. Similarly, here it will be event. So and our front end will be able to catch those events. So okay, we have our API, like our functions defined, and this is how the Solidity smart contract would look like. Then we need to compile it. So that our EVM is able to understand that compiled code, and also we'll be able to distribute this after compilation, so that we are able to call that from our front end. So after compilation of a Solidity contract, a JSON is created, and that JSON will have this very important thing called ABI. What is this ABI? This is what your front end knows about the contract, or this contract offers, what are the functions, like how we have our interfaces, right? We know through interfaces like these are the methods available for us. So APIs are something like that. And we have all these all these methods we defined there. See, tasks we had there, and then like task completed event is there, create task method is there, and toggle completed. So all those which we want to expose, we have it in the ABI. An array of like a JSON array. The address of this compiled smart contract, which is this. This address identifies every contract in the blockchain, uniquely identify the contract in the blockchain. So we have it, and it gets generated after you compile a smart contract. So we have address, and we have the ABI which we are going to use. Then what do? You have compiled a code. Now you want to deploy it on your blockchain. So deploy means you want to put it on the blockchain. And what does it really mean? When you want to put something on the blockchain, it is a write operation on the blockchain, right? So this write operation means you'll have to pay, right, in forms of, so here when you deploy something on an Ethereum blockchain, you have to pay in terms of ETH. So that is what we have. Like when I deployed my contract, I actually had to pay some ETHs. I think you can see the cost here. And so like there's a cost it specifies in terms of gas, and you have to pay in terms of ETH. So it needed this much gas, and it costed me this much ETHs. Okay, so I've deployed. So every time you have to deploy your contract on a blockchain, you have to pay. So, okay, I've deployed my smart contract, and now I'll be able to access it. So now we'll come to the front end. So to connect to the backend, JavaScript has provided us this new thing called web3.js. So it's a collection of library. It allows you to interact with your Ethereum node, and you will be able to connect it through HTTP or IPC or WebSocket. So let me show you that code. This is my React code for connecting to my blockchain. This is all normal stuff. What we are most interested in here is this function. So what is this function doing? First thing, it is connecting to the provider. So if you remember from the architecture diagram I showed you a while back, we have to connect to a provider to interact with the blockchain, because I did not want to make my laptop a node of the, the blockchain. It's not that powerful. So I used provider, and I had MetaMask in my Chrome installed. In any browser, you can just install this extension. So what it does, it connects to the provider I have on my, like I want to connect to. So you're connected to the provider, then you get the account. So this is your Ethereum account, which has your ETH, like how many ETH, how much ETH you have for payments and those things. So you connect to the account. For that, there's just a method given by Web3. It's called get accounts, and it will fetch all the accounts you have for your ETH in your Ethereum. Cool. We have connected to the provider. We've got the account. The next thing is, yeah, now we want the to connect to the smart contract, right? So this is what we'll do. There's this function provided by, like there's this class provided by the Web3 library, which is called contract, and you create a new object of that class. You have to provide your ABI, like which I showed you there in the other code, and the address. So this was the JSON array, and this is the address. So this is my constant file. Yeah. So this is the ABI. It's just a copy of the ABI I showed you in the smart contract here. This is the ABI we had here in the config file, in the JSON file. It's just that API, and then the address also, which I showed you. So this is the ABI, this is the address. We are just going to connect to that from where, like when we are creating a new contract object, we'll pass the ABI and the smart contract address, which we want. And yeah, so now you got contract, and then every contract will have this methods object, and in this methods object you'll have all the methods exposed by the smart contracts. So task count was one method, task was one method. So this way we'll be able to connect, we'll be able to call these methods. So you can see, like, we are able to call these methods just like we would call a normal JavaScript method through its object, right? So this, like, it makes it that easy. You just get the contract, and then you can just call the methods normally. So I got the task count, I update my state, and then I get the list of all the tasks I have, and I update my state again, and I kind of render all that. Cool. So we are able to connect to the smart contract and call the methods and get all the data from the smart contract. What if you want to actually create something, like put something in the smart contract, or you are all getters and getters, right? Method, which is provided by the Web3 library. So what do? You call your create task method, which was exposed by the smart contract. Then you send it. So send means this will actually send it to the smart contract from which account. So you have to provide the account so that they can charge it. So you send this from this account. The method will be invoked, and I showed you, like, it will emit some events, right, like created task and those things. So when that event is emitted, it is caught here, and then like this once function, and then you can just do a callback, anything you want after the event is emitted. So again, I want to update my states and get all the things, so I just call that method here. So this is how you call the methods exposed by a smart contract, and then it's kind of promise, right? Like when we call our APIs, and then after we get the data, we call the then method, right? So it's something similar to that. Yeah. So these are all the things, like very basic, you need to know, and I'll quickly show you what happens when I run my application. So, okay, let me start from the beginning. Yeah, so I'll create a task. Mm, yeah. And see, like it has created this for me. Like go for a walk, and I can also show you the contracts, and then you can see the create task and task count and those things. So yeah, so this is like we have access to the contract, and we have access to all the methods. Cool. So yeah, the code is done. We know it has a lot of methods you can using these. So okay, I think yeah. So the code is done. We now have a running app. We know how a smart contract is created. We were able to deploy it. Then we were able to call it from our method. So I think like most of the getting started part is done here. All I'm left here with just discussing a bit about what are the limitations. So this Web3 is very new right now. It's evolving every day. It's very nascent right now. So the user experience and the interface is not very evolved. And because there are not many users, the underlying principle of high security is not fully utilized, because like I've explained, when someone wants to change a data in the blockchain, they have to get the consensus of everyone. But since like if there are less users, it kind of becomes easier for people to do some malicious activities. But when the user base expands, it would become all the more difficult to get this consensus and submit the proof of work and all those things. In those cases, the security will be great, and of course scalability is not like that much evolved. So there's works going on for how to improve the scalability of these applications, but it's not that, I mean, it's still in its evolving stage, not very developed and mature. So these are like, this is the future, like this is the future and the limitations of any application in like these DApps. So yeah, these are some of the differences, like some very good articles I found about the blockchains. And I think yeah, I'm done here.
Thank you so much, Sanjali. That. I think people are going to be referring to and building their first Hello World app or whatever. I think your talk is going to be referred for a long time. I think it was brilliant. You covered all aspects of it. So great job. Thank you for sharing your knowledge with us. Really appreciate it. So it's time to express our gratitude for our sponsors. So thanks to our gold sponsor Lab 49 for supporting us. So Brian from Lab 49 would like to share a few words. So let's hear him out.
Lab 49 here. Very excited to be speaking with all of you. I wanted to spend just a few minutes talking about Lab 49, our involvement with the conference, and also how possibly we could work together in the future. So first and foremost, I want to start by saying how happy we are to be here and to be sponsoring React India. It's really great for us to be able to give back to the engineering community, provide this workshop, which we're really excited about and hope that you're able to attend. And a big thank you to the conference organizers. Just to introduce myself a little bit more, my name is Brian McAllister. I'm the interactive practice head at Lab 49. The interactive practice is everything UI and mobile engineering. And so engineers in this practice spend most of their time doing front-end engineering or mobile applications hand in hand with our product and design team, and often in collaboration with our back-end engineering teams. I'd like to spend a few minutes just talking about Lab 49, the company. So about Lab 49, we are a small consulting firm. We specialize in the finance industry, and that, of course, is going to influence some of these later topics, the work that we do and who our clients are. But I do want to talk a bit about the uniqueness of working as a consultant, which I think is one of the aspects of working with Lab 49 that's really important to understand, and something that I believe is a net benefit to your career as an engineer, because working as a consultant means that you get exposure to all kinds of different projects. You get to experience different tech stacks, different teams, different business lines within the finance industry, exposing you to all kinds of different concepts, from technology to asset classes that certain applications might be working with, and working with lots and lots of different people. It's a really exciting way to work. And at Lab 49, we believe that it can function as a career accelerator due to how many new things that you can be exposed to. So I will talk a little bit about the type of work that we do. Because we're a consulting company, we work with many different clients on many different projects. And because we're focused on the finance industry, we are focused on applications that serve that particular type of business. Finance industry is quite broad. There's a lot of kind of specific areas that you could focus in on. Some of the interesting work that we do really focuses in on trading, and so trading applications. And these applications are interesting for a number of different reasons. First and foremost, the technology from the perspective of UI engineering, for example, is quite interesting and quite complex. And some of the topics that you'll find yourself having to understand and deal with are concepts like streaming data, very, very large data sets, very complex user experiences with workflows that consist of many, many individual segments that users need to be able to understand. Also, you're dealing with a type of application that typically for our work lives on a desktop. So not necessarily working within a browser, but getting a desktop experience. If you've seen photos or movies of traders and the work that they do, you got usually monitors with charts and graphs and different UI elements, grids, very, very common. And all of this data is updating and changing in real time on the screen while traders are having to do their work, which would be to submit and manage trades. It's technically very complex, which is incredibly interesting. And it's also very complex on the user experience side, which makes it very interesting to implement and to work with product professionals and designers who are typically working shoulder to shoulder with our engineering teams. Just to speak a little bit about who our clients are, as I mentioned, we focus on the finance industry. So for the most part, our clients are large financial institutions, so big international banks, Fortune 500 companies, investment managers, hedge funds, all sorts of different types of financial institutions, some of whom are actually startups. We'll work with smaller fintech companies on occasion, certainly in the crypto space. That's another area where we've been able to work with smaller companies who are doing really new, cutting edge, interesting things. Going into a bit more detail about the types of projects that we work on, as I mentioned, they tend to be both technically complex and complex from a user experience perspective, but they really do run the gamut in terms of size and complexity and length of project. Because we have so many different projects with so many different clients, the compositions of the teams can be quite varied based on the needs of the projects. We have engineering skill sets ranging all the way from the front end, user interval engineering, all the way through to end types, building APIs, for example, database integrations, through to building and learning models or movement lines are relevant to the work that we do. And at Lab 49, because we have all of these different types of engineers, there's a great opportunity to work with these people and learn all of these skills. And so what I want to point out is that we're hiring. We're hiring in a lot of different locations. Certainly we're hiring in India, and we have a few people from Lab 49 who are in attendance. I'll talk about that in a little bit more detail. I do want to talk about why working at Lab 49. I've touched on this in a few different ways, but hopefully it's becoming apparent that we work on really interesting projects with really talented engineers. One thing that I'd like to point out in particular is the workshop that we were able to run at React India. This is very representative of the type of work that we're able to do here for our clients. So hopefully you were able to attend the workshop and interact with our team and work through understanding what are some of these concepts that you would need to understand and be able to implement as an engineer here at Lab 49. And then the last point is our team is attending the conference. There are a few members of the Lab 49 team, both engineering and recruiting. We have breakout rooms that you're able to attend. Our recruiting team can provide all kinds of different information about how to get involved and how we can continue the conversation. And then we have a bunch of engineers from the team also attending, both conducting the workshop that we're doing, but also here in attendance, looking forward to interacting with all of you. So that's it. Very excited to do the React India conference.
In the first place, or really have a problem to solve. And my favorite part of this website. This was my problem because the former choir member who built and maintained it was long gone, no longer responding to emails. And either we keep holding our Christmas concert on December 19th every year until the end of time, or I use the little HTML knowledge I have to build us a new website where we can update our concert dates. My initial exposure to React was through the online learning platform Scrimba. At first, I thought I would only learn enough CSS to make a more modern website. But I just kept taking courses, and it turned out I loved working with React. Scrimba uses an interactive video format for lessons and guided code screencasts. The neat thing is, you can pause the teaching video at any time and play around with the code right in your browser window from that exact moment in the video. Whatever you type, changes right in your preview window so you can see the effect your code changes have. Then, when you hit play again, your changes are gone, or saved if you chose to. It's right back whatever you lost. It wasn't a low-code environment by any means, but with nothing to configure, it was low environment. This was how I learned React, right from the very beginning. It was also the only way I coded in React for months. I didn't have any code running on a local machine. I didn't have any particular software installed. I was using an older Chromebook that had limited local storage and didn't run Linux. I didn't have a terminal or a shell or a console. I just had a browser window and a lot of notebooks. What this allowed me to do was to quickly get into the flow of React without any prep work or any knowledge of a traditional development environment at all. I could write components and even fully functional tiny React apps before I even knew what npm install did. With a basic foundation now in React, if not in traditional development processes and tools, I was ready to figure out how to actually build apps and websites for myself. But I didn't know where to go or how to start outside of Scrimba. At this point, I didn't even really know what I was looking for. I just kept putting words in a search engine. When you don't know the term IDE, it makes it just a little more difficult to find one. But eventually, I found some options. Since then, I've used a variety of these online code editors, and the nice thing is that pretty much all of them just work, even if they each work a little differently. I was able to successfully write at least some React in everything from CodePen to Replit to StackBlitz to CodeSandbox to Gitpod. Now, if you ask anyone, what's the best way to learn to code? They are almost certainly going to tell you to build things. And it's true. But maybe one of the hardest things to do when you're learning is deciding what to build. Since many coding tutorials build clones of popular sites and apps, I figured that would be a good place to start. After using these videos as a starting point and building a few for myself, like a Netflix clone in CodeSandbox, I decided to look at the apps I used most frequently to try to get some inspiration. Now, one thing to know about me is that I'm a bird watcher, and I have no fewer than 6 birding apps on my phone at any one time, not including the Bird app. And what I noticed was that many of these apps pulled their data from the same source, eBird, which is the global citizen science project where I submit my bird observations along with hundreds of thousands of other people. And that's when something really exciting happened. I realized that, yes, eBird had an API, and yes, I could apply for a key, but when I checked out the docs, I realized that through their API, I could access more information about my own account and sightings than I could from logging in on the website or using the official app. Specifically, there's no real way for a birder to check on the status of a rare or unusual bird submission, which must first be reviewed and then validated by eBird before the observation is admitted to their database. Otherwise, people could just be reporting a penguin in Toronto or a flamingo in Reykjavik. Remember, this is all just a website where people are free to report whatever they saw. Well, there was no way for me to check on the status of a rare or unusual bird sighting, but there is now. Before my app, I could report an unusual bird, but I could never actually tell when it was reviewed or whether or not it was deemed valid for research purposes. This first version of my app was written in Code Sandbox and allowed me to render to the screen some of those object properties that just aren't visible from my account page on eBird's website. React had actually solved a non-trivial problem for me and for that Savannah sparrow that wintered in my backyard when it typically should have left by the end of October. This was the first time I'd written a piece of software, top to bottom, to do something that I couldn't otherwise do. It felt pretty good, and it kind of still does, as all these excessive animations might indicate. Maybe it's still part of being a beginner, but I can't help but think this only exists because of me. So, side note to all you experienced React developers, please let us get excited over little things like this when it's still all so new for us. It's actually pretty cool when you think about it. As I learned more React and thought more about what information I wanted to fetch from the API that would be useful to me and hopefully to other birders, I made some improvements and built more features. And all this time, I still haven't done anything more than open a browser window. This time in one browser window, but probably a lot as I consulted docs and looked up how to do new things as I went along. Now, I did rely on some other tools throughout this process. Several of the online IDEs allow you to connect to or import from GitHub or GitLab in the repositories. So my project could live outside of these editors and have version control, but I could still only use these tools in the browser. I didn't have Git, I had GitHub. The web interface, and this was before Codespaces or the github.dev web editor, doesn't exactly give you the same command line controls that you'd normally have. It often needs to be refreshed after doing things, and every single file upload or edit is a new commit. There's no just save button. It also wasn't as straightforward to revert to an earlier commit if I wanted to throw away an unsuccessful experiment. And of course, I had lots of little tiny commits working this way. But one of the nice things about using a Code Sandbox or Gitpod environment is that if I code myself into a corner, known to happen, then I can just delete the instance and start by pulling fresh from GitHub next time. That's been pretty liberating as a learner. Eventually, I figured out that for me, this was actually the best way to use these online code editors. While they do save your work as separate instances of your project, instead of going to my dashboard and reusing them later, I just open fresh from the source every time using URL shortcuts such as githubbox.com or the gitpod.io prefix. There are also Chrome extensions that add Open Sandbox and Open in Gitpod buttons right when viewing your repository online. Now, sometimes I'd want to start a new project with more than just a basic React setup, which for me had always just been a one-click start from new template project in an online editor. That was pretty much what I knew. And this is now the point at which learning things out of sequence, or at least out of expected sequence, is creating a bit of friction in my ability to progress. When I come across a new thing to try, I'm usually faced with a project setup that looks like this. Or this. I had still never typed anything into a terminal window, and yet I already had basic React apps successfully up and running. I was in an unusual position where I thought I was ready to go further and learn new things, but it just felt like nothing was meant for me. And to be honest, at times it was incredibly frustrating. Even when I felt pretty good about my progress with React, I would often feel utterly incompetent as a programmer. Instead of facing some of these typical obstacles, especially around a dev environment or tools early on, I was hitting them now. There was a lot of suffering in silence because I felt like I didn't even know enough with these basic knowledge gaps, and therefore maybe wasn't even worthy enough to ask others for help. And some of the things I needed help with, I didn't even know how to describe. So I have to point out here that this is where documentation can make or break a community. And as I'm right in the middle of recording this video, the new React docs have just been released in beta. And that's super exciting, even though I have to update my slides. This little downturn for me was all happening right about the time when Gatsby 3 was released. And they'd been working on their docs, including tutorial walkthroughs that they also made into live coding videos. These resources were so helpful and instrumental in getting me over that little hump. I still wasn't really using a terminal window, but the docs helped me understand the overall task I was trying to achieve and gave me better vocabulary for figuring out a solution that I could get to work in my environment. By learning more about what was actually going on, I, for example, discovered that instead of adding a package with npm install, I could just go right into my package.json file and type it in. I could edit a config file manually to use an updated version of Node. These were all things that I could totally do in my environment. So, after I had rebuilt my Community Choirs website from scratch in Gatsby, remember, that's what prompted this entire journey in the first place, and the site was now humming along with little maintenance required, I wanted to explore building a new personal blog for myself where I could continue to use and practice React. I had originally chosen Gatsby for the Choirs blog because then I would understand the React behind it, even though I probably wouldn't do more than update concert dates and monthly announcements. But I was feeling a little more adventurous and could get away with something a little more experimental just for me. And I was still learning React, so I didn't just want to blog, I wanted to keep building. That's right around the time people started talking about Astro. Astro files are similar to JSX files, so the language of the overall project was familiar, but then, because it allows you to include components from a variety of frameworks, I could write React, well, pretty much everywhere inside it. I think of my Astro blog as a home for a bunch of React components, ranging from very tiny experiments like exploring sharing state and context, to now being a permanent home for my bird app. Now, when I want to test out a new idea or learn something new in React, I don't actually go looking for an online starter anymore. I open up my own website and add to my growing list of experiments. And then I blog about it, including what I just built right in the page. This allows me to play around learning more and more parts of React with the safety of knowing that I'm not going to mess up my main site itself. Most recently, I've been incorporating Jest and React testing library into my Astro blog, and I'm still really only scratching the surface of what I can do there. All this React learning for myself has even allowed me to get involved offering support in the Astro community, where not everyone brings React experience. And with my familiarity with the online dev environments, it's easy for me to throw their code into a quick, temporary environment to troubleshoot. This is how I started contributing to open source. My very first pull request was to add a Code Sandbox config file to the Astro starter template. Thanks to the knowledge, experience, and confidence I've gained by learning React, I've also since become one of the maintainers for this open source project. So whether you're watching this talk as someone wondering how to get involved or started without a lot of traditional support or tools to work with, or whether you're someone looking to take advantage of the recent shift to remote work and become a little more location independent, or whether you're a community builder wanting to be inclusive towards a new emerging category of developers, I hope that I've been able to highlight some of the differences, challenges, but most of all successes when all you've got is a browser tab. Thank you for listening.
Oh my God, Sarah, what a brilliant talk. I mean, if I'm being honest, I found myself smiling throughout the talk. I was laughing. I felt so proud of your journey. I went through like this whole roller coaster of emotions within a bunch of, 15 minutes. It's congrats on all of your accomplishments, just amazing. And I had a couple of aha moments because I've been doing development for so long, I've kind of forgotten the beginner mindset, and I think you just took us through almost, it was like a movie, through the lens of someone who's just in the initial leg of their journey of learning front end, and it was just beautiful. Thank you for sharing this with us. I think you're on mute.
Right. Well, thank you so much for the opportunity to share the story, and if it helps anybody else have a bit of a smoother journey than I did, then I hope it has given some information.
It would be, for sure. Thank you again. Thank you so much.
And enjoy the rest of the day.
Thank you. We will. All right. All right, we're back, and our next speaker is Daish Kato from Japan. He's built several global state management libraries in his time, and he's here today with us to share one such library. I'm sure there are going to be a lot of interesting features that we're going to learn about, so I can't wait to see what he has. So let's jump right in.
React India.
Hi everyone, thanks for having me a chance to give a talk today. I'm going to talk about Vertio, global state for React. So here's a little bit about myself. I'm Daish Kato, and I'm a freelance programmer. I'm based in Tokyo, but my working style is online and across countries. And my focus is on JavaScript and React. I also work on various open source projects. Some of them are experimental libraries, and some of them are practical libraries. Today's talk is about global state libraries for React. I have been developing several libraries for global state. This is a list of major libraries. Zastand is a tiny library for module state. Jotai is like a flexible extension to React context. React Struct is a library mainly used with React state and context to optimize re-renders. It works somewhat magically with proxies. Proxy Memoize is a library mainly used with React Redux. As the name implies, it uses proxies too. And today's topic is Vertio. This is a library that also uses proxies. It uses proxies extensively. And it works like magic. In this talk, I will show how to use it. Even if you don't know well about proxies, you will see how you can use the library. So what is Vertio? It's a library for global state for React. It's first released in November last year, so it's about 1 year old. Vertio's syntax is unique. Actually, it's not unique, it's just plain JavaScript. It turns mutable object into self-aware proxy. You can then create immutable snapshots, which React can use. Essentially, the goal is to connect global state to React as easily as possible. Okay, let's dive into the demo. So suppose we would like to create a counter app. I will show some steps to explain how to build it. At first, we create a global state at the top level. The global state has one property called count. We then define a function called increment, which adds 1 to the count. Next, we set interval, which invokes the incremental function every 500 milliseconds. Finally, we define the app component. In the app component, we use global state.count. Now, the count must be incremented periodically, so our hope is to have the incrementing count on screen, right? As you might guess, this is not how it works. We need to have the component re-render when the global state changes. Let's see how Vertio can help. This is the working version. As you see, the counter is increasing. So what is changed? We first import 2 functions from the Vertio library, proxy and useSnapshot. We use the proxy function to wrap our global state object. The increment function isn't changed. It's just mutating the global state object. In the app component, we use the useSnapshot hook. We get a snap variable and use it in JSX. That's it. Pretty easy. Now, how can we add a button to increment the count? So we added a button which just calls the increment function on click. It works. This means while we use a snapshot in JSX, we mutate global state directly in a callback. Let's make sure if it works with multiple components. We removed setInterval and added 4 counter components in the app component. Now, all counter components refer to a single global state. The state is shared among all counter components. So far, we have only one property in the global state. Let's add another property. We now have 2 properties in the global state, count1 and count2. We also defined 2 increment functions. Then there are 2 components, counter1 and counter2. Each component uses count1 and count2 respectively. In the app component, we have 2 counter1 components and 2 counter2 components. They work separately. You may not notice, but this is render optimized. Let's naively add math.random in both components to display the random number for each render. As you can see, only the component with updating count number re-renders. The way it works is, the use snapshot hook detects and remembers which property is in a global state is used in a component. In the counter1 component, only the count1 property is used, so it re-renders only when count1 changes. This is what I call render optimization with state usage tracking. If you look closely at the code, you notice counter1 and counter2 are very similar. Let's see how we can make a common component. The new counter component takes a name prop. It uses the name prop to access the snapshot object and invoke the increment function. In the app component, we pass name props to counter components. We get the same behavior as the previous one, even though the counter component uses snapshot based on props. The render optimization also works as before. Let's look at another example. Our next example is To-Do app. We start with an empty array in the global state. The next ID variable is a naive way to get a unique ID. The add to-do function is interesting. It adds a new item in the to-do array with mutation. It's just a JavaScript syntax. The next is to-do list component. It uses the use snapshot hook and renders the list with the snap variable in JSX. The add to the form component is nothing special, and it calls the add to do function. And that's it. It works as expected. Let's add a new feature, removing a to-do item. In this step, we have a new function, remove to-do. It takes an index argument and just splice the array. In the to-do list component, we add a button and call the remove to-do function on click. Let's see how it works. Looks good. Because this is to-do app, we should be able to complete an item. This is the last step. We add the toggle to-do function, which changes the completed property in the to-do item. We can change a deep property pretty easily. In the to-do list component, we add a checkbox to toggle the completed status. Also, if it's completed, it shows strike through on the item. Does it work? It's working. I hope this demo showed the basic usage of the Vercio library. Now let's discuss a little bit about pros and cons. The major advantages of Vercio is that it allows mutation. It feels just like a normal JavaScript object, and you can mutate it. In React community, we often prefer immutable updating style. Vercio bridges the gap between the mutable world and the immutable world using snapshots. Another advantage is render optimization with state usage tracking. It helps reducing application code pretty much. A disadvantage is it's very flexible and leaves responsibility to developers about how to organize global states. Also, proxy-based render optimization isn't perfect, and there are some gotchas. All that said, I would encourage people who got interested to try it. If you have questions, the first pointer is the Vercio GitHub repository. There are short docs and wiki pages. You can reach me out via Twitter or Discord. Discord server links are in my GitHub profile and Vercio repository. That's all. Thank you all for listening.
Hey, thank you for that talk. I found it very, very interesting. I think the audience will also have a lot of questions as to start weighing. Okay, what are the differences? What are the pros and cons against some of the more popular global state management libraries? So I think I request everyone to head over to the lounge and get in touch with Daisuke Kato over there and ask all your questions. Thank you so much for your talk once again. So we are here with our next speaker, Travis. So Travis is here to talk about layout composition with all of us, which, if I understand it correctly, it's applying the component mental model that was popularized by libraries like React and bringing it into the context of CSS. That's
Correct,
my
yeah.
understanding. Whoa, yes, okay. So I'm really curious to learn more about it and looking forward to Travis's talk. But before that, there is a fun fact about him that I would love to share. So he used to be a licensed stockbroker in another life. And in my opinion, it's the knowledge of stocks and software development, the two skills together, they're just an amazing combination of skill sets to have. And you can make a lot of money in both the professions. So Travis, are you a millionaire yet?
No.
So he's also a really nice person who sends thank you tweets to everyone who follows him. So, all right, I'm done pulling your leg, Travis. Let's jump straight to your talk.
React India.
Hey, everybody. At React India, so excited to be a part of this. And today we're going to talk about how to achieve layout composition in React. A little bit about myself. Once again, my name is Travis Waithmare. I'm at Twitter, at Travis Waithmare, and I blog at non-traditional.dev. I'm a senior software engineer for Anonymy Labs, where we're building privacy solutions for both businesses and consumers. And I'm the creator of the Bedrock Layout Primitive Library, which you can find at bedrock-layout.dev. And I recently released a course called Composing Layouts in React. Now, we are currently living in the age of components. Most major front-end frameworks nowadays are based on components, and there's a good reason why. Now, in the React docs, it says components let you split the UI into independent, reusable pieces and think about each piece in isolation. These components can be simple components that can be composed together and built up complex UI. It allows us to achieve heights before this model was introduced. Unfortunately, CSS was not designed around the component model. In fact, it was designed around the entire website and to solve problems from the top down. She will do something like this, where you have your general styles at the top of your style sheets, and then you work down to more specific styles as you go. Components, on the other hand, work from the bottom up. We break down our UI into specific parts. Often these parts are isolated from each other, and then they're composed and built back up to build our complex UIs. So we have two competing methodologies here. Now, many of us reach out to tooling to help us bridge that gap, and it solves a lot of that, but it's not enough. Things like Sass allows CSS modules, CSS style sheets, they help us solve that problem of maintaining our CSS style sheets without conflicts across our different components, and it allows us to grow our CSS style sheets at scale in a maintainable way. But what they don't show us and they don't help us do is make our CSS composable. So then the question is, how do we achieve layout composition? Well, let's look at this hero layout, for example. This is something probably many of us have done in our lifespans as developers. A naive solution would be do something like this, where we create a hero container, and then a hero top, a hero left, right, etc. And we put all of our styles that are related to our container in that container style, and so on and so forth. Now, you could use CSS methodologies to get us a little further and a little bit maybe more attainable naming scheme here. We could use BEM, object-oriented CSS, functional CSS, or atomic CSS. All these things help us manage that style sheet at scale. just like tools like Sass and us. But once again, it forces us to focus on what our layout is doing, and we're looking at these as unique layout patterns, and we're missing this opportunity to create consistent layouts across our web pages. So what if I told you that CSS layout could be componentized? What if we looked at our layouts as these layout primitives? What if we created components that all they do are stack things in consistent ways, put things in line, split, cover, frame? What if we created these components that just did one thing and one thing well? And then we use those together, compose them together, and that's how we achieve our hero layout. In JSX, it would look like something like this, where we have a stack that wraps everything. Our menu bar on top is using an inline, and so on and so forth. Now, what's great about this is that this doesn't work just for our hero component now. Now we can then take those same primitives and maybe other ones and compose them in a different way and build a sign-up form, a blog post feed, or a feature page. So you're saying, Travis, that tooling and methodologies don't help us achieve composable layout. So how do we do that? I'm going to propose to you that the solution to composable layouts is the principles of encapsulated CSS. Now, you're probably asking, what is encapsulated CSS? I've never heard this term. Well, that's probably because I invented it. Encapsulated CSS is a term I use to summarize the rules of how to apply CSS in a composable way. The focus of encapsulated CSS isn't about names and creating class name schemes, but it's about what CSS properties apply to which elements in the component. And it's based on the principle of encapsulation. So why is that important? Why would we want to follow encapsulated CSS? Well, the biggest enemy to composing layouts is having components or elements that have built-in opinions on how they should be laid out. And when they come in with these pre-built opinions, they conflict with what we actually want them to do in the context of this new situation. By following the rules of encapsulated CSS, that will help us avoid those layout conflicts that prevent us from being able to compose elements together correctly. So if we're talking about encapsulated CSS, I think it makes sense to take a step back and go talk about what encapsulation is in general. Now, this is my definition, but I think this is a good definition for, in a language agnostic way, to explain what encapsulation is. Encapsulation involves grouping related things and restricting access to except through appropriate channels. In JavaScript, we have a concept of a module. In this module, we get access to, for example, in React, things like create element, use state, or use effect that allow us to build our UI. But we are from accessing those internals that actually use those elements. Another example in object-oriented programming is having private properties with getters and setters, where we can control access to those private properties. In functional programming, we have this concept of closures, where we can create a closure around fields and return functions that get or set the values of those values inside of the closure. So the question then is, where is that boundary of related properties in CSS? How do we group our CSS properties? Well, we don't need to look much further than the box model itself. If we have, for example, a 10 by 10 square with a 1 pixel padding and a 1 pixel border, that means we have a 14 pixel inline size. Our width is about 14 pixels. And this is true whether we add margin or not. The content and the actual box of the element doesn't change size by adding margin. So it's fair to reason that from the border inwards is how we should group related properties. So that's good in theory, but like it's good to have some much more practical rules to follow. So that's why I have these two principles of encapsulated CSS. The first one is that elements do not lay themselves out. Now, by layout properties, I'm talking about any position, size, or margin property. Anything that impacts one of those three is a layout property. So in this case, set and display, width, margin, position, all these things directly on an element, that's not okay. That breaks the first rule of encapsulated CSS. The second rule of encapsulated CSS is that elements style themselves and they lay out their immediate children. Now, they lay out only their immediate children. So things like setting the border color padding, things that are decoration, those are great. Set those on the element. And then when you need to set layout, have an opinion on how the layout should be for the children, you can use things like the direct child combinator, for example, here. And that is how we achieve composable layouts. Now, there's many ways that solutions for layouts with CSS. Before we had Flexbox and CSS Grid, we started out with Normal Flow. Normal Flow was the only option for our CSS. Now, we could consider maybe we should just use props. And this is not a bad method to think about how to use our CSS in the context of React. We can expose a prop, we're in the context of a parent container, and then we can just set a prop and we can set those layout properties directly. And that is correct, that would work. That does not break the general concept of encapsulated CSS. The problem with that is that becomes very unwieldy very quickly. Are we really going to expose every single potential layout property and just keep floating those up? We're going to have way too many properties. And plus, does it really make sense for us to have a title component or like a calendar component with a random margin left property or a random min width property? So this is a solution, but I would highly recommend that this is used very sparingly and probably only for components specifically designed around layout itself. Now, for normal flow, I would highly recommend using the direct child combinator instead. The direct child combinator allows us to stay in CSS and directly select immediate children of the parent container that we are setting our style properties on. Now, CSS, Flexbox, and Grid are a different scenario. They're kind of created in a more modern time and with modern understandings of how we do things on the web. And so what happens is when we set display flex or display grid, we're not actually doing anything directly to those divs or parent containers. What we're doing is creating a container that allows us to set the layout properties on the flex items or grid items, respectively. So Flexbox and CSS Grid naturally follow the rules of encapsulation very well. There are a few flex or grid properties that need to be set on the direct children, and for that I recommend going back to what we would do with normal flow, which is using the direct child combinator. So let's look at this contrived blog post component. We have an article with an H2 and a bunch of paragraphs that we're mapping over, and all these are coming from props. Now, to style it, we could do something like this, where we have our blog post and we want anything that's decoration related, that's style related, we are setting directly on the elements, like the blog post. We're setting the padding, the blog title, we're setting some text transforms and some text color. But anything that is layout related, we're doing directly from the parent container context. And then overall, the whole blog post has no opinion on its how it is positioned, sized, or how much margin it has. This allows this blog post component to be composed any way that we want it to, and we can change how we lay out this blog post component in different contexts if we want to. And it has no opinion. It also allows us to abstract out any of these things like the H2 or those paragraphs. Abstract it out, maybe make a more general purpose component if we find a reasonable need for it, without having that context follow us from this blog post component if we don't want it to. Now, earlier here in this discussion, we were talking about layout components. I'm sure many of you are like, let's get back to those. Why haven't we talked more about those? And there's a reason why. Layout components shouldn't ever try to solve every potential layout. And that's where the rules of encapsulated CSS are important. It's important to be able to know how these layout components are built and understand the principles behind them. So when we need to build our one-off situations, things that our layout components are not good fits for, we can build those on the fly without breaking our compositional layout patterns. It's also good to understand what makes a good layout component. When does it make sense to actually make that abstraction into a layout component? And this is a rule not just for layout patterns, but for any abstraction we follow. And that is that any abstraction we make should always be worth it. In other words, it needs to solve a lot of problems. It needs to be a common enough problem that we solve. We can reuse this in multiple places. If it can be reused in multiple places, then it's definitely not worth the time creating this abstraction. A good layout component should also be focused on the problem that it's trying to solve and not how it does it. In other words, we don't want to create flexbox components or margin components or grid components or padding left components or so on and so forth. What we do want to make is components that solve an actual problem, things where we're trying to put things in line, where we're trying to create stacks of components. Those are examples of good components. We'll see some examples of it later here in this talk. So once again, we don't want to focus on how we get there, but on what problem. Good layout components should also be stylable. In other words, they should expose the class name and style props. Their only opinion is layouts. So they still need to be able to be styled, get colors, and have all those decorative properties applied directly to them. And finally, and I think this is like one of the most important things, and so I put it last, is that they should not break accessibility. In other words, you should be able to easily continue to use the correct semantic HTML and not have to overload your web pages with divs all over the place. A good way to do that is to use the polymorphic as prop to allow you to pass in exactly what elements should be rendered onto the page. So let's go over a couple examples of good layout components. Now, in all these examples, I'm going to be using style components. This is not because you have to use style components to make layout components. It's really just because it's a good way that I feel to show these examples all in one, as well as I just really like to use them. But everything about what I'm going to show here can be applied using just vanilla CSS if you want. So I've talked about this already. There's this idea of like creating stacks. If we look at something like this where we have subscribe to our newsletter widget and we need to put things on top of each other, you'll notice that despite the fact that we have different types of elements, they're all based on this one principle of putting one thing on top of another with consistent spacing. So in our component, we could build it like this, where we give it a display grid. This creates an automatic one column by default. And then we can pass in a gutter prop to define how much of a gap in between our elements there will be. Now, I've created a little spacing scheme here. I highly recommend that if you do a layout that you also have a good spacing scheme. It's beyond the point of this topic, so I won't go into it much. But yeah, just follow whatever style guide that you already have, or there's lots of great content on the web about creating a good spacing scheme. Now, the stack component then can be used just like this, where we can wrap the entire thing in one big giant stack, and then each one of those can be stacks of themselves, and then we can continue to compose multiple levels deep, just continue to stack. And I think it's good to point out that this layout can easily be achieved simply by composing one layout primitive. Now, the other one I'm going to talk about today is this idea of an inline cluster. Lines of text and paragraphs are some of the most responsive things we have on the web. And because they just automatically, as they run out of space in the inline direction, that they'll automatically wrap to a new line, and they'll cluster according to the justification that we've set, whether that be the start or the end or the center. Now, we often want to achieve that same type of layout with our elements, not just with words in a paragraph. So let's take this layout, for example, where we have this navigation section of our menu bar. We want it to be centered, aligned, but I want to have that gap just kind of like our stack, but we also want it to wrap and cluster according to the justification that we set. And we can do that with something like this, where we're using display flex. We're setting the flex wrap to wrap. We have that gap property that works the same way as the stack property, so I kind of did bring all that code in. And then we just have this justify align map where we have start and center, and we're using that to set the flex start, flex end, or center. And I want to just point out, we've gone through the point to take away the fact that we're using flex. We could have exposed flex start, flex end, and center directly, and that would have worked, but now we're getting into the weeds of how the inline cluster is implemented, and we don't want that. A good layout component is agnostic to how it gets there. It's just what properties are exposed. So that's why we're exposing just start and then center, because in the future we might find a better way to do this without flex. And we don't want to be tied down to the flex or bring that concept into here, make people have to understand flex to use inline cluster. So now we can take our menu component and we can wrap our nav section as an inline cluster, pass in the correct spacing and justification alignment, and it just works. As soon as we run out of space in the inline direction, it will just automatically wrap and cluster in that according to the justification, which in this case is end. Now, there's a lot of different components we can go over, and we don't have the time to go over every single one, but I would highly recommend that you check out the library over at bedrock-layout.dev, as well as you can also check out my new course at Composing Layouts in React, or you can always hit me up online at Travis Waithmare, all capital case. I love to talk about this stuff online. And once again, I want to thank everybody at React India for letting me come out and speak to you today. And I hope you have a great
Hey, Travis, thank you for that lovely talk. I was wondering, like, what is the adoption like for, layout composition in your experience? Like,
It's kind of a newer concept, and there's so many of us who were taught CSS, like the way it was developed in like '99. So it's really foreign. And in fact, it was when I was introduced to the idea, like it was really hard for me to really think about it. So in practice, I think it's still kind of generally kind of newer kind of way to think about CSS as a composable thing. Mm-hmm. But it's coming out there more and more. You'll see blog posts where people will say that margin is bad and we should stop using margin. And that's getting kind of to the point, but it's not all the way there, which is, it's not bad. It's applying it directly to our elements that are bad. And that's the final step that helped me at least finally get to that point where I understood how to make composable React. And then it's just really kind of just down to just programming principles, like just not allowing yourself to just add that quick little margin top or that quick little margin to the bottom just to make that layout work according to the design, and following through on those good programming principles.
All right. Beating laziness now, that's something.
Yeah.
All right. Thank you so much, Travis. If anybody has any more questions, please head out to the lounge and connect with Travis over there. Thank you so much.
No problem. Thank you.
All right, everyone. The last speaker of the day is Gant Laborde, who is here to bring JavaScript to Apple TV. Sounds fascinating. So I'm all set to like get my mind blown, if you know what I mean. Some fun facts about Gant before that. So he told me that he can throw playing cards at a very high speed, almost like a weapon. When I learned that fact, I was like, okay, if only we were like, you know, in an in-person conference, I would have convinced the organizers to have like a separate booth to demonstrate that skill and like arrange the cups into like, you know, on top of one another in a pile and just make him, you know, just flaunt his skill. It would have been so cool. But anyway, let's jump right into the final talk of the day. Enjoy.
React India.
Welcome, friends. And this is JavaScript on Apple TV. Ooh, all right. Now, this is a super cool talk, a super cool concept. So you're asking yourself one burning question. Who is that devilishly handsome man giving this presentation? My name is Gant Laborde. So who is Gant? I go by Gant Laborde on the Twitter sphere. I am one of the 3 owners of Infinite Red. I'm the Chief Innovation Officer of the company, and we're the best React Native dev shop in the world. Mic drop. So I also have some really cool titles after my name, sometimes React Native Core Contributor, Google Developer Expert, Web Machine Learning, Oracle Groundbreaker, AWS Community Builder, Cloudinary MDE, Distinguished Toastmaster. I generally don't say all those things, but you know, the slide needed something on that side, so there they are. I'm also a published author, and yes, I brought JavaScript to Apple TV. That's what this talk is about, but I also brought JavaScript to machine learning, and that's a lot of fun too. So if you're interested in machine learning, please check out my O'Reilly book, Learning TensorFlow.js. You can grab it on Amazon. It is a page turner. I have to say that legally. They make me say that. But it is a good book. It's a really good book. Okay? So let's dig in here just a little bit, talk about what this Infinite Red place is and why I say that we're the best in the world. We are React Native professionals, and it comes quite often that people have to build things in iOS and they have to build it in Android. And now that's sort of like expanding out and now I need to build a web, now I need to build a Windows app, now I need to build a Mac app. And so generally this happens quite often for any product whatsoever. I'd say that you are uniquely positioned to do a lot of those things, and that's sort of what I'm going to show you today through the wonderful technology of React Native. Now, how many people actually use React Native? Since this is virtual, go ahead and look to your left, no, your other left, and look to your right. Good. You see those people? You shouldn't see those people. It's virtual. And then raise your right hand up and put your right hand down. I don't know if you're doing any of this, but the truth of the matter is a lot of people are, okay? So you can have a lot of fun. Just know that there's no way I could ask people to raise their hands and you'd see a bunch. So just take my word for it. There are a lot of people using React Native. So let's go ahead and empower our React Native. We'll definitely check it out here a bit. So one of the other things I say here is that we are React Native professionals. And the reason I say that is because we've worked with all kinds of amazing companies and there's some cool stuff that we have out there. But, you know, we've always been working in the mobile market, and the mobile market is a huge industry, right? And you want your app to go wherever the user is. A lot of us do web, and we think to ourselves, oh, well, I could just do web. Well, hopefully my story today helps persuade you that you can't just get away with web all the time. There's 2.2. The mobile market is still interested and important, right? All of you listening here own a Apple or Android device, right? Raise your hand, everybody. Good. So that means software is about that experience. And the trick is when we're doing React apps, we have a wonderful developer experience. And when people are on computers, they have a wonderful React experience. So we have mobile first paradigms that help make sure that they can pull it up on their phone. We can assure that we have the DOM, and everybody's used to go ahead and kicking off a brand new React app. There's nothing new or difficult about that. Then we say, let's bring React over to mobile. And that's what happens for React Native. React on mobile. So one of the things that happens here is that people get afraid. They immediately say, like, okay, I'm changing platforms. What are the difficulties that are going to happen there? And I don't look at those as difficulties. I look at those as places to customize per platform, because the setup there is great, which means that we need a level of abstraction above the platform. It means no DOMs. It means some stuff like that. So what we do here is we elegantly interface with what is natively there. You still have all of your React knowledge. If you're great at hooks, if you're great at state management, then all of that plays in directly. All the business logic's still there, but the key is that it actually gets rendered down into the native components so it can interact seamlessly. So what am I talking about when I say that you actually render things unique per platform? Well, in React Native, you don't have, a paragraph tag. You have a text, and the text, when it gets rendered into an iPhone app, becomes a UI label, and then when it gets rendered down into Android, becomes a text view. And if you're using React Native Web, it gets rendered into like a div with a paragraph tag inside of it as well. So this level of abstraction allows us to ignore the what it's called on each platform sort of mentality there. And then when we get to actually work with it, we're working within the native framework for each platform without having to worry about knowing what each of those are and then being able to customize it when we need to. So you might say, like, why not just put websites on everything, right? Why not just pull up the website have a web view on the phone, a web view here, and a web view there? Well, obviously, you've probably heard that that's a terrible user experience, one. But it's also slow, and it takes the person out of the appropriate experience per platform. So why did we all get interested in building mobile apps in the first place? Why did we all get interested in building websites in the first place? Because we influence the world. We actually build things that are cool that you can share. You're building an experience. And as a developer, just kind of making it work isn't the right way to do it, right? So these statistics come from internet statistics from Oberlo.com. But over 65% of the world has internet access, spends over 7 hours a day, and then almost half the world has smartphones. So when we want to build a great experience, we want to go to where people are. And I think that that's going to be a really good segue into, like, let's follow a person. They're sitting there on a desktop during the day, and they check their phone. And then later on they leave and they go home and they watch some TV, and then they go work out and they look at their smart wearable devices and stuff. Well, that's super cool because they're using all of these awesome computer interfaces. But as a developer, this is a little bit of a pain, right? And you all know that. They could be on iPhone, Android, tablet, iPad, smartwatch, TV, macOS, Windows. And so in the web world, we go from web to all devices. We save our time and we save our price, but we sort of lose something, right? What happens when we decide to go in a platform like TV? TV has aspects that web shouldn't have. So Apple TV has 3D icons and a specific user interface. There's no mouse, right? So I'm going to be using Apple TV as an example to sort of show why there's power in identifying what the platform is, why we're going to not just do web views all the time. So one of the great benefits here is that we can actually dig deep down and do some cool stuff. So there's this concept called the dancing bear, which is that for a little while, we're all just really impressed that the bear dances at all. We don't care how well the bear dances. And the truth is, when you first get something to work on all the different platforms of web, it's impressive to say you support all those platforms. But what about when you want it to be good on every platform? And that's why I talk about, instead of pushing websites everywhere, push JavaScript everywhere. And that's the benefit that we can have here. And we could do that with React Native. React Native's always been pushing this learn once, write anywhere kind of experience. It's battle tested. You can access native if you need to. And then if you know React, you can reuse your React knowledge. So this is our adventure into an Apple device using React Native. So this is a device that specifically would not be terribly useful with a website. We want that native style. And that's what we're going to do. We're going to put JavaScript on Apple with React Native. We know why. Now let's talk a little bit about how the hell this thing actually happens. First of all, what's the developer experience like for actually developing JavaScript with React Native on an Apple device? It's really good. It's actually not difficult at all. And so that's really important to us. If you're used to doing web development, you're going to really enjoy the way of doing JavaScript on Apple devices. If you're used to doing native development, this might seem a little bit alien for you. For mobile development, we often find ourselves stuck going through this insane transform of trying to identify things. In web, you save something and then you immediately see it update on the other side. Well, that's sort of the experience that you want to have when you're developing on mobile devices. But how cool would it be if you could actually have that hot module reloading? Well, with React Native, you can. Check this out. So what you're seeing there is the developer experience. I'm not wired to my Apple TV. I'm actually sitting on the couch. And when I hit save, it immediately updated and ran the code again on Apple TV to go ahead and show that. That's the great experience. I'm sitting there and I'm looking at live Apple TV app. And then as I code, I can actually save and do it there, or I could do it in a simulator. That's an amazing developer experience. So now we know why we want to do JavaScript. We know how it's going to be doing it there. What about actually thinking a little bit in the platform? Let's go into that for a moment. Generally, when we think about web, we have a bunch of things that we actually think about. We think about what browser people are going to be using. Is it Chrome? Is it Firefox? Are they using Edge or Opera? And then let's pretend that we actually have an interaction on that browser. Well, what happens is the mouse comes in, we have a hover event, we have focus, we have click, and all these are available and optional for us. And that's the user interface. It's the mouse and the keyboard. So you're set there. But what happens is when you move over to mobile, you don't actually have that same kind of experience. In mobile, there's no such thing as hover. And you don't actually have something called click as well. So when you actually in mobile, you actually can hold your finger over it, but nothing happens until you actually press. So you have these pressable events, and you have to think about that there. But you could press wherever you like, and you can kind of add the information wherever you want on the screen in a way where you don't even have the computer know or the mobile phone know where you're going to press next. But this all changes in Apple TV. In Apple TV, you don't have the sense of easily like pressing on a particular thing. Here, the concept of focus is key. And so you actually have a totally different platform behavior. You have to use your remote. You have options to go up, left, right, and then you have the ability to select. Thinking specifically about those differences is going to be important because this is what lets you dig deep down into what is specifically for each platform. Now, before we actually get into writing the code for React Native, it's going to be really important to understand those abstractions we were talking about earlier. We talked about how a text element, which normally you would think would be a paragraph, is represented with just text. And in different items, it's UI label and it's text view. So let's get very serious and talk just for a moment about those platforms, React-powered code, and a lot of these pieces here. Because if we look at that, then the code becomes very simple. Utilizing React Native means that we're going to use React code. We can bring in any of the JavaScript specifically for the platform while keeping those React Native abstraction components. And the React Native abstraction components are things as simple as this. Where you would normally use a div, instead, you would go ahead and use a view. And then when you have a div that scrolls, it's very important on a mobile device to identify that something should scroll or should not scroll. So we actually have a totally separate component there, which would be a scroll view. As we mentioned earlier, you have the text, and then when you have input, instead of calling it an input with type text, you would just simply go ahead and call it a text input. And this will allow it to have the correct components on each of the platforms as well. You can look at all the supported components on reactnative.dev. So we're going to code a simple UI for a variable amount of player names. And the idea here is that the number of players, we'll get that first, and then we'll use the text input to get the quantity and update state. And then we'll be able to loop through X number of inputs for each of those players' names. So if we first take a look at this code, it looks very simple. And we have is scroll view, because we have no idea how many players we're going to have. And then inside there, we have a view, which is going to be sort of like a div, which pushes everything out. And then we have a text, which says how many players are going to be in this. And this is just simply saying the place of a paragraph. And then you have a text input. So we're going to ask them, and we're going to say the keyboard type for this one is numeric. This will help out a lot, given on, it'll bring up the correct virtual keyboards for each platform. So we want to get a number, so we're going to say it's a keyboard numeric, and we want the number of players. And then when we go ahead and we get new text inside there, we're going to dispatch using Redux to change the size of how many render player boxes should actually happen. And then we can just say, all right, so if I type in 0 there, then we'll dispatch 0, and then it'll give me 0 player boxes. If I say I have 10 players, then I want 10 player boxes to go ahead and get dispatched. Simple enough. This is like your normal to-do list example, except for identifying how many players that we particularly want. And then you could read this React Native code just like you could normally read React code. But let's take a look at what that experience looks like. We're going to look a little bit later into, let's look right now into the code for rendering the player boxes. So we'll take a look at that. When you're rendering the player boxes, you can see that there's a specific amount of text boxes that you can have there. And when you put this on a mobile app, I went ahead and made everything red so that we can really kind of identify it. And so if we say, how many players do we have? And I type 1, I see 1 box. I type 11, I see 11. And so if I type 5, it gives me 5 players. So this is a pretty simple setup for a variable number of players. And then I should be fine in order to kind of show this inside of a game, or trying to figure out how many players are going to be in this particular game. And so this works out pretty well for something like React Native, and this would work well for web, and this would work on iOS and Android. But let's go ahead and take a look at that, how it would work on Apple TV. So Apple TV, we have this sort of, when we have the numeric screen and the keyboard pops up, we have how many players we have. And then I would select that. So we have our first box. Now I can't click on it. I have to actually give it focus and then press the middle button. Remember, this isn't actually like that. And then you can see through the display here, when I type 3, you only see a few. If I type 11, it'll make 11 boxes behind there. There's a semi-transparent view of what's going on behind that box. So I say 5, now I have 5 boxes. Now I have to give focus to player names at each one, and then type those in. And this is how I have 5 boxes that come out of that, and it takes up this entire screen, and I would be typing out the player names. So if I type it here, you can see that automatically it moves on to the next box for me without any code. So I can kind of have all the code names set there and then say done. And then there I have it. All the players are set inside the game on Apple TV running the exact same code. While I was able to go ahead and create the exact same experience using the same code on multiple platforms, we have a very important question here. How did that feel? Did it feel right for a Apple TV experience? If you ask me, it kind of felt a little bit sloppy, right? It didn't feel like it was a good user experience on Apple TV. You could see through the screen. You could see all the other parts there. And then when you had to give focus to each of those pieces, it felt like I was trying to jam too much information onto a screen and the text was too small. Well, see, we can do better. We can think specifically about the platform, and then here's where React Native is amazing, right? You see, on most platforms, you have on web and desktop, there's a care about space and interactions, right? You have lots of space, and you have lots of ways you can interact. So that's pretty good. On mobile, however, you have a lot less to interact with everything. But then on TV, things change. you have tons of space, and you don't have an easy way to quickly interact with one thing or another. This is the inverse of that mobile experience, and this is what I'd like to show you here, is that even though the code runs, just like a web view could run on all the different platforms, even though this code runs specifically on one platform or another, it's about customizing the experience, because the space versus the interaction capabilities has to be paid attention to. So let's go ahead and utilize the space and the hardware so that we can get a proper feel. And what I think this means is that we can build components specifically for React Native on Apple and specifically for the experience on mobile, and then have React Native switch out which component they show depending on the platform. So here, let's take a look at some code. Instead of allowing the person to have to actually constantly act, what we can do here is we can write the code to adjust using a use TV event handler, and this will give us the ability to actually adjust based on the input from the remote control. And we can increment and decrement the number of players, and this should feel a lot cleaner. So we want clean, focused UI UX experience. And then when we write code and we actually present it, you get a number counter that's so much better. Number of players, you can actually use the keyboard here. Here I am sliding up and sliding down to increment and decrement the numbers. And you can see when we get to 9, we do this cool flip, and it comes back. So anyways, super cool setup. Ready, flip, there it is. So this is the cool way to actually do the experience here. Imagine if I asked for a number of players on this screen, and then on the next screen, I gave you those variable number of people so that you could actually figure it out. And this uses the device specifically to it. And that's the beauty of this, is there's nothing stopping us from diving into native. You see, now we have the ability to dive directly into native. And that gives us the ability to do things specific for that platform. And it works out quite well, doesn't it, sweetheart? It works out quite well because we can actually dig directly into what makes that platform specifically important. And we can adjust to make that experience proper. So what does the React Native process actually look and feel like for everybody? You're researching, you're building, there's a thriving community, there's constantly new components created by people. You can decide to go ahead and do a number counter like that and then release it. And then ultimately you can build it all together quick and easy. So here's a little example of sort of I threw together for what does it look like if you're trying to get the entire user sign-up experience. And so if we went ahead and did here, you see we have some animations, we have our number counter. So I have my incrementer, looks nice. And I'm going to say I want 4 players. So I go ahead and scroll down, I have 4 players. I'm going to choose single or double elimination. So I'm going to choose single elimination. It prompts me for the usernames, which I'd already entered. That's why they're showing them here. But you can see the usernames, and then I can go ahead and go to the end and play a nice little video to say, all right, now you've got all your information. Let's go ahead and play. And you can see the bottom was animated with reanimated. It was set up in a bunch of different ways. It actually makes it really fun. And if you were actually holding the remote, doesn't that feel natural? Wouldn't that feel correct just to go ahead and select the correct things and then move on each of those? You can actually build all the cool things that you want to build for web directly on Apple TV or mobile using React Native. And I think that that's where the real power of all this comes through. So like I said, we are a React Native dev shop. We do a lot of code. And you might be wondering, well, how much native do you actually have to do? Let's say that if you take a look at the statistics here, most of our projects, we actually code half of it about from scratch. So we actually do a good bit of it from scratch, just doing the JavaScript, coming up with the idea, and awesome stuff. They're either from NPM specifically in JavaScript, or NPM packages that are out there already existing for us for React Native. And then we often have a little bit of time to come in, say 15% of the time, modifying, customizing libraries, getting them adjusted. And then if I had to say how much we actually dig down into native, it's 2% of the time. I pulled our entire team of building React Native apps. We do have to get down to native every so often. It's not for every client, but this is a wonderful experience. You're actually taking all of that sort of coding, the building, the websites, and you're able to apply it directly and easily. So I hope that you try out React Native with us. If you're interested, go ahead and check out React Native content. We have tons of it. We do the React Native conference in the US. We have the React Native newsletter, and then we also have React Native radio. Definitely come join us and listen in on all that. If you want to get set up, we actually have academy.infinite.red, and we have how to get set up with React Native already set there. And if you get stuck, don't worry. Like I said, we're the best Infinite Red React Native shop, and we also do consulting, training, and I'll say this, we're the best at Rocket League. Come test us out. So with all that, I do want to say the contributor and the maintainer of Apple TV for React Native is the one and only Doug Lauder. This guy is great. He's been maintaining it since 2016, and I wouldn't be able to do any of this stuff without him. The fact that he's constantly updating when new features come out, he actually integrates that directly into React Native. Super awesome dude. There he is wearing our Chain React shirt. So he's spoken and gone to our conference before. Definitely reach out to him. Doug Lauder on Twitter. I'm Gant Laborde, and I hope now that you understand it's super awesome. We can bring JavaScript to Apple TV, and we can make it pretty awesome. Thank you so much.
All right. Oh my God. Okay. The content was phenomenal, right? But his presentation style was just out of the world. I mean, hashtag speaker goals. I wish I can present like that someday. The energy, the way, his style, the confidence, just brilliant. I'm just speechless. What a brilliant finish to a brilliant day. So we are at the end of the road here. I think I just want to take a minute to thank everybody. Thank you for this opportunity. Thank you to the organizers. Thank you to my fellow MCs, Rajat, Wilva, and Ankit, for being such awesome people for helping me and making all of this possible, right? It was a teamwork. And all of the amazing speakers that I got to introduce, it was such a great experience. I had so much fun, and I'm so lucky I got introduced to all of you and you lovely audience. So thank you, everyone. Thank you for listening and interacting, learning. Thank you for being in this journey with us, honestly, genuinely. Thank you. That's about it. This is me, Anushree Subramani, signing off. Until next time. See you.
Hello, everyone. One second. Sorry. So, Rajat, we are almost at the end. How did the talks in the day go?
Very well, actually.
Yeah, I can see you look pretty relaxed now.
Yes, I can see you are looking very relaxed as well.
Yeah, yesterday I was under a lot of pressure, but today I'm so much relaxed.
Why is that?
Oh, yesterday I was wearing a very tight bow tie, so there was a lot of pressure on my neck. So that was the pressure I was talking about.
Good joke.
Okay, so I would like to take this moment now to thank all our sponsors, our gold sponsors, Anstack.io, Lab49, Ceylon, Native Base, and Gupshup.
And also our bronze sponsors, Moon Highway, Unibuddy, and Turing.
I would like to thank them for the amazing support that they have lent us, and because of whom we have got this amazing setup and the conference running for 2 days long. As part of this, I would also like to thank all our amazing speakers for the excellent content and talks that they have put out there. And we could all see the amount of hard work that has gone into it. And it was loved by one and all. Thank you, speakers.
Also, our very, very special attendees who have stuck with us for the last 2 days and who have interacted with the speakers, and promoted us on social media and forgave us for all the technical difficulties we had.
Really, it means a lot.
I have one question for the audience, though. Did you all love the remote edition, or did you wish we were in person?
I think if somebody if you are trying to type in the chat box, we are looking at it right now. You can tell us what you like. Did you liked to see this talk in the comfort of your homes, or you would have loved to have an in-person conference interacting with everybody? And the kind of comments that I've seen over Twitter, I know that we could have had much better experience if we were in this all together. So we have heard you. We know. I know Abhishek is also writing in-person conference. Saurav is also writing, and I think everybody. So we hear you. We know how awesome it can be. So at this point of time, I am announcing that the next version of React India 2022 will be in Goa. Woohoo! I hope that you all are also as excited as we are. You can show us your excitement in the chat window. Yes. Okay. The organizers are calling me. 1 second.
Dude, we are on live.
Hello. I just announced that we are going to Goa. Yes. We are not going to Goa? I'm not going to Goa. Okay. It's fine. Cool.
What are they saying?
Nothing. It's actually I've been. I'll not be the MC in the next conference, but I think it's all right.
No.
It's all right.
Hey guys, what happened?
I think I was a great host.
You were the best.
You were amazing.
Can you pass me a tissue,
Please.
Yeah. So I think I was a great host. I have to eat. So
Yes, you're
yeah,
better.
right.
You're the best.
But
You did amazing. Okay.
cool.
I think next
I
year
think I'll have to excuse myself.
Okay.
Am I going to be in Goa tomorrow, next time?
Well, give me some space, please. Yeah,
Dude, come on.
just a bit of space.
What? No.
Okay. See you all in Goa next year.